doing waste as well. We have wind research, but we are doing waste research as well. Just been to a big conference last week in Berlin.
We can talk about our core product actually isn't waste. That's 30% core product is packaging waste. Which is a big problem in Germany, I know.
I've seen that. That's what I was talking about last day.
It's a pragmatic approach on the partner now in Germany, that's what I mean.
It's not
Good morning, ladies and gentlemen. On behalf of Litvan Group, let me welcome you on our first annual Wind Turbine Blade Materials and Recycling Forum. My name is Teresa, and I've been already in touch with you regarding several arrangements. We have gathered here for 2 days of conference, very intense one, where our distinguished speakers will present their cutting-edge strategies, new innovations, and updates with the industry. Each speaker will deliver 20-minute presentation, followed by 5 minutes Q&A session. For the questions, please just raise your hand and I will give you the microphone. We have also several participants online, so let me extend our warm welcome to all of participants joining online. Also, please always use the microphone so we can transmit the sound. You can either use this table microphone or we have a hand microphone just below the lectern. For the presentations, you can use the clicker here to move the slides, use the pointer, etc. All the presentations will be shared with you via our online platform approximately 1 week after the conference, since we allow our speakers to do some changes, add different slides, etc. We will have 2 coffee breaks. Each coffee break will take place just here in front of the conference room. For the lunch, we will go downstairs, and also we have an evening drink after the conference. I believe very deserved one for everyone. In the conference folders, which you have received from my colleague Michaela, you can find the agenda with the timing. Good news is today there are no changes, so the timing and everything is correct. For tomorrow, we have 1 speaker cancellation. I will give you the updates tomorrow and send you the updated agenda. You have also the delegate list and the speaker's bio, which you can read, and also the evaluation form of our speakers. So please don't hesitate, rate their presentation, the content, presentation style, and
Thank you, Teresa. The world will build more wind capacity in the next 30 years than in all of human history. And what we do with the blades will determine whether the growth is truly sustainable. Good morning, everyone, and welcome to the 3rd Annual Wind Blade Materials and Recycling Forum. It's an absolute privilege to stand here as chair, because this room represents something rare in our sector, a genuine collaborative space where innovators, operators, engineers, researchers, and policymakers come together with a shared purpose to build a circular future for wind energy. Over the next 3 decades, the next 30 years, the world will install, repower and retire turbines at a scale we've never seen before. The blades we design, manufacture, decommission, recycle, reuse and repurpose will move through global value chains that are now only beginning to take shape. And the decisions we make today will echo through 2050 and beyond. For me, this is a challenge that is not abstract. In my own work with Plaswire, I've seen firsthand how difficult and how necessary it is to turn circularity from ambition into an operational reality. But I also want to be very clear. Today, I'm not here to promote any one company or pathway, and that includes Plaswire. I'm here to help create a space where every organization, every idea, every approach, every voice can be part of the solution. Because circularity will never be solved by a single technology or a single actor. OEMs here will tell you that. It will be solved by systems. We have to create systems, and by collaboration, and by the collective intelligence of rooms like this one. Over the next 2 days, you'll hear from companies already operating at industrial scale, from innovators pushing the boundaries of what's possible, and from engineering partners who turn ideas into real-world production. You'll see solutions that are ready now, solutions that are emerging, and solutions that will shape the next generation of blades. My role as chair is simple: to help us stay honest, stay ambitious, and stay connected. To make sure every voice, whether you're an OEM, a recycler, a researcher, a policymaker, or a startup, has a place in the conversation. And to ensure that we leave here not just inspired, but aligned on the actions we need to take next. Because the truth is this: the future of wind blade circularity won't be built by waiting for perfect solutions. It will be built by scaling the good ones, improving the emerging ones, and inventing the next ones together. Thank you for being here. Let's make this forum the moment where the sector moves from ambition to acceleration. Now, a few little housekeeping points, because this is going to be a super 2 days. First of all, there's no expected fire alarms today, so if you hear one, you have to get out, right? There are 2 fire doors behind you. Leave everything, turn around, walk away, but let's not anticipate that's going to happen. On the back of your badges here, you'll find a QR code which will allow you to download the photographs and any videos and so forth as they're put up online. And you can use those in your social media and whatever else where they'll be useful for you. We have a lot to get through in 2 days, so please make sure we keep on schedule with presentations. I'm sorry, but I will cut you off if you go over time. So don't go over time. Questions, be sharp and succinct with your questions. Don't meander, please. And let's get the most out of this for everybody. So our first presentation is about the future of wind blades in the market, the outlook and the development. And I welcome up here Dirk Brise, Chief Executive of Trend Research.
Thank you so much for introducing and for the introducement general in to the conference. It's always very hard to speak after a native speaker if you are not a native speaker, so I'm sorry for my accent and for any error I'm going to make regarding the language. Yeah, hello everybody, good morning, I hope you're fine. I have to put the scene as I was told, and I did it quite a lot of times by now, and I can do this with the mood barometer, the global wind energy market index we are doing for now 8 years. It's going to be the 9th year this year. And we are doing this together with the Hamburg Messe, the wind energy event, the biggest trade fair we've got worldwide. Sorry. So I give you a short overview, short introduction, then overview over the market sentiments in the wind energy, onshore and offshore wind. I hope this is the right scene. And we'll look especially at one question we are doing in the mood barometer, which is about wind turbine sizes, which maybe is interesting for you because it's definitely related to the blade size. And then I've got some short slides or a few slides about the impact of the grid bottlenecks and the value chain, just an overview, and maybe 2 slides about the, if I've got the time, about the targets we are facing in the wind industry in selected countries. Where do we come from? We are a market research company and consulting company. We are doing this for about 20 years right now. The mother company, Trend Research, was founded in 1997, so 28 years or 29 years ago. And we are delivering studies and surveys and so on. This is the survey I'm going to present you the results about today. It's, as I said, the 16th in the 8th year. We're doing it twice a year, so it's 16 now for 8 years. And we are doing it together with the Wind Energy Hamburg, or for the Wind Energy Hamburg, as you can see here, which I was just saying. Biggest trade fair. It's going to take place again this year in September. So if you want to come to Germany and to Hamburg, I think you're very welcome, and maybe most of you will be there, I think. During the last 8 years, we've conducted 16 rounds by now. You can see the numbers here about the visitors, the participants, the survey completed, and so on. So we think with about 400 people worldwide opting in and claiming or taking part in the survey, we think we are quite in a good position to say that's a representative study worldwide. We are covering 4 different regions, let's say. That's North America, Asia, Europe, including Germany and the rest of the world. This is, as you can imagine, 9 years ago when we decided to do it like this. Maybe we have to change it in the future. Maybe we have to put some, for example, Australia or something separately. But we kept it till now to get a better comparison, you know. The first question is about in which business are you in? And we are asking if is it onshore or offshore wind or both? Yeah. And what you can see here are the figures, and it's quite interesting how it was or how is it changing during the years. So we see the 43% now doing both, and about 38% in the last survey was just onshore and 14% just offshore. So the majority is doing both. These are the numbers of where they are in which business they are in. There are much more numbers of what position or function in the company, what part of the value chain, everything. I didn't put it in the slides because I would have needed too much time, but if you're interested, I can give you the figures as well as in what region are you active. This was another question we are asking, or is another question we are asking. But the main part of the survey is of asking how is the sentiment, how is the mood, how do we assess the wind energy development. And that's one of the results. Generally spoken, you can see, I think I can get it here. Oh, yeah. Oops. You will see in the following slides, you will see green for onshore and blue for offshore wind. So if we are differentiating in between offshore and onshore wind, you can differentiate as well. by these just colors. And then you see down there the answers to the questions: how do you assess the current development of the framework conditions? The framework conditions certainly are still the most important things we are looking at, because the renewable energy industry still is mostly dependent on the framework conditions, on the politics, on the targets, on the grid connections, on the subsidies or CFDs they get granted, and so on. So this is the first question we are asking. And what you can see here is we had the biggest decline we ever had in the States last year, in spring last year. This was really disruptive, let's say, because it went down from about 60 plus down to 40 or 30 minus, which was the biggest decline and the biggest development we ever had in this survey for the last in the last 8 years. It's almost the same in the offshore wind industry. This is now offshore wind, and it's almost the same. We see that Asia had a problem last spring as well and went down as well as Europe, as the rest of the world. But Asia was recovering in autumn very quickly, although the United States or Northern America countries didn't recover as they did. Europe and especially Germany recovered a little bit. Germany less, Europe better. Then we are asking, how do you assess the global market for the onshore wind industry? This is onshore again, another would be offshore. And we see here a very steep decline as well for the States, but also for Europe, for Asia. In the last spring, in the autumn, it was getting better. Onshore as well as offshore. Offshore generally is a little bit better than onshore, let's say, if you compare it. It's a little bit higher. And you can see in 2022, everybody was very, very positive talking about the industry. And we are talking about an industry, we just heard it, which is quite in a positive mood. We are talking about growth, we are talking about new investments and everything. This is not normal. There are so many industries in the world, in all over the industries, which are not having these growth rates we are experiencing here. So we always have to be clear, also when we are talking about, oh, there's a growth lag on whatever, it's still growth. It's not more and more growth, but it's still growth. We are still investing in onshore and offshore wind industry. We are still installing new turbines, new parks, having more and more business on the service and on the recycling business in the end. So it's still a growth industry, okay? You always have to remember that. There are other industries like chemistry, for example, which are really, really in a bad shape, or automotive or others, which are really having problems. So this said, the outlook for the next 2 years and the 12-month year, this is a little bit newer for onshore and offshore as well. Yeah, and I told you I would get you a short introduction to the technology reasons, which maybe is interesting for you as well regarding the next steps and then the conference where you're heading for with the turbines and the blades. We are asking a few questions about special things, like here the saving potential in wind energy development. What do you expect? And this is quite impressive as well for us. There were about 5 years where the industry was saying we are seeing big potentials, more in offshore than in onshore, as you can see, much more in offshore, but always in the positive side. Yeah, they are expecting bigger turbines, better efficiency. Maybe floating for foundations would be a game changer for offshore. This is always why the offshore numbers are higher than the onshore, and so on. But this, in the last 3 years, it went down, and it was getting nearer offshore to onshore. So the new technologies or the saving potentials for new developments is getting down. And we'll see that by the turbine size as well. It's more or less the same effect. We can see it here for onshore turbines. We are asking, what do you think, how big will be or what capacity will have the newly installed onshore turbine in 2030? I know it's 2026 right now, so it's only 4 years. Maybe we have to pose the question then about 35 or whatever in the next years. We are keeping on 2030 for the last 3 years, or 3 years about, for the last 6 rounds, to get again a comparison, to have the same goal or target 2030. But what is interesting is that in the beginning it was getting higher and higher. They are looking for 8.5, 8.6 megawatt per turbine. And in the last round, in autumn this year, it was getting down the first time. It's 8.3. This is more impressive, even more impressive in the offshore business, because, you know, in the offshore business, the Chinese companies are offering 22 megawatt turbines, whereas the European companies like Siemens Gamesa or Vestas, they said, or they are saying, we are offering you 15 megawatt turbines offshore, but we are now taking a pause, or just we want to earn money. We have to earn money right now, so we won't do the race any further and keep on with the race, developing a new bigger turbine size every 2 to 3 years. Every turbine size, as you know, offshore development costs you about 200 to 300 million euro. Yeah, so you have to pay. You have to build up new production sites. You need bigger ships, whatever. So, and even only the turbine costs you 200 to 300 million, maybe even more. And you will never get back the money if you don't sell these turbines. So, or selling only small quantities. They are saying now we keep at 15, maybe 16, 17, but not getting into the new generation, the 22 turbines. And that's for us, for me as a market researcher, is one of the crucial questions, and maybe for you in the conference as well. What is it going to be? Is it going to go further? And are the Chinese then, discover or how do you say, win the market? Yeah, and the Europeans are getting out of the market because they don't have the efficiency what is expected for the cost efficiency as well. Or are they good with this strategy, and will they keep on the strategy and be successful with it, just doing the same size? Offshore, you've seen that it was getting from 18 to 19, and now getting back from 19.4 to 19.2. And we are very keen on what the development will be in the next spring survey, which will be taking part in March. And if you would take part, I would be very grateful if you would take part as well. We need the experts to say how they think it's going to be. We are talking about or asking about delays caused by grid bottlenecks, which is one of the biggest obstacles the industry is facing all over the world, I think, onshore as offshore. And what is quite impressive, the branch is still saying it's about 3 years we are having delays. The delays are about 3 years we're experiencing it because of the grid bottlenecks. And I just got an additional slide, which is not in the desk. I'll give you the slides for the participants later. What the problem therefore is, because if you look at the targets and the new investments, then you will see this delay, especially. Okay, some outcomes. It's just text, so you can read it if you want. I just want you to ask to sign in. If you would take a photo, I've got some small leaflets as well, which I can give you. If you would sign in for the Trend Index, then you can take part the next time. We'll send you an email if it's if it's started. It's not started yet. It's going to take place in March, as I said. But if you are interested, please take part. looking at the value chain, and this is maybe the thing you are doing then the next 2 days. First of all, you have the projects and the financing and everything, and then you have to manufacture the blades and the turbines and the foundations and so on, and then you have to bring it. In this case, it's offshore wind. You have to bring it out, sometimes even 70, 100 kilometers or 70 miles out of from the coast. All this business we have to do with the warranty surveyors and everything. It's really a big market by now. We have got about 900 companies only in Germany which are doing business in the offshore wind industry, and it's a huge market. I was talking about the targets, and we've got 3 countries in here as an example. It's out of a new study we are just doing, the United Kingdom, Germany and the Netherlands. And you can see everybody is aiming forward for new, bigger investments and targets and let's say in the end numbers. Why that? Because of the climate change targets. But if you look at the reality, then you see, and this is the example Germany, then you see that the target is much. This is the target, the red line, and we are going to miss the target by far in 2030. We all know that all the parks which will be installed in 2030 are now fixed. I mean, there won't be new parks for offshore wind in 2030, which we don't know yet, because you need about 8 years to get everything ready till you install and get into operation. So these figures are quite set. It's about 21 gigawatt, and the target is 30. So we are going to miss the target in Germany for 10 gigawatts. And that's almost the same in the Netherlands, in Denmark, in the UK, in different countries. So what we're experiencing right now is quite a big hole in the growth and in the growth rates. And the question will be, or the decisive question will be, are we able to get back to the plan or not? And that's what we are discussing right now in the industry, and maybe that's the first setting of the scene for you today. I'm running out of time, so thank you very much for listening, and I hope you have a very good conference during the next 2 days. Thank you.
Do we have any questions, please? I have a question here. How do we assess the current market situation for wind projects globally, onshore and offshore?
Well, as I said, it's still a good market. It's a growth market. There are going to be quite a lot of investments and new installations onshore and offshore. Onshore, certainly it's easier because the grid connection is much easier. Our chancellor says in Germany he doesn't like wind turbines. He hates them. He doesn't want to see it. He's saying it's just a bridge technology for the next 20 years. And then we are getting rid of the onshore wind turbines because we have got other sources. And then they are accepting it offshore because you can see it offshore. But onshore, he wants to get rid of it. There are many other people who are saying different things, but that's the thing. Globally, I mean, everybody knows what Trump is saying for the wind industry, onshore and offshore. Even before the first term of Trump, you know that in Scotland there was a project, and it was quite opposite. He could see it from his golf club side, and so he was saying, I don't want to have it and whatever. So, and there are others which are not in favor of wind industry. But talking about the climate changes and the climate targets we have, and about, and if you don't deny the climate change effect, that's one thing what Trump is doing as well. But if you don't deny it, then you have to do anything, and you have to install renewable energies. And if we're talking about renewable energies, there are not so many options. You can get the solar photovoltaic thing, but in the end, wind is one of the bigger players because water, running water and everything is almost done. There's not much potential, so you have to go into wind. And talking about wind, if you got shore, if you got on a coast, then you certainly normally are going offshore, because onshore the place is limited and not everybody likes it. I don't understand why countries like Norway or Australia, because why they are going offshore. I don't understand that. I would say they can be on the coastline. There are not many people. There's a lot of wind. You get 3,500 hours per year. So you don't need offshore. You don't need the hustle with the boats and everything. But there are countries like Germany, like the Netherlands, like UK, which is much better to get offshore right now, and we've got the technology and we've got the solutions, and it's in a scale where right now I think it's a good thing to invest in. It's one of the best renewable energies. And let's say wind doesn't cost anything. I don't have to tell you that, you know that. And wind is free and it's in your country. You're autonomous. When I see what we paid Russia for the gas and still are paying Russia now the States for the LNG deliveries, for the gas, the heating in Germany, it's a fortune. Yeah? Right now it's very cold, so we are paying lots of euros and getting more autonomous together maybe with H2 or others, with the electrolysis from the all-electric society. I wouldn't speak from the all-electric society. I think that's not the case, but we can get a big part of the industry and the energy market autonomously. So we are then better up than before, certainly.
Thank you very much. One more question. Yep.
Hello, my name is Robert Slepman. I have a question for you. You mentioned already we miss our climate targets. You explained it a bit. But what is the real root cause of missing our climate targets? Because I think there are only two main reasons. There's the profitability of the OEMs and the whole supply chain profitability. Next to that is the capacity to build new turbines. There's a limited capacity and also a limited capital injection. And the capital is caused by, I would say, the profitability of the OEMs, who needs to install the turbines and make the turbines. So how do you see this?
Yeah, thank you for your question. It's a very good question. First of all, I didn't say we are missing the climate targets. I said we are missing the offshore wind targets. Yeah, so that's a difference. The climate change or the climate targets is quite more difficult, and we are not up to say if it's going to happen or not. But what we can say is we are missing the offshore wind targets. Definitely, we missed it in 2020, by the way, and we are now missing it for 2030 for sure, and for about 50%. 10 out of 20 gigawatt we are installing is 50%. So why? I think that's very different in between the different countries. And if we, for example, talk about Germany, we are right now having 16 gigawatt being awarded. You know, I think you all know that. BP, Total won the last ones, and RWE now won in England in the round 7. And so out of these 16 gigawatt, only 4 have got a final investment decision. Okay, so we are having about 12 to whatever gigawatt, which are not clear if they are going to come or not. And these projects have been awarded quite a long time ago. Some of them. Yeah, that's one thing. The next thing is in the last auction in Germany in August, there was no offer. So it was totally, as we have seen it in Denmark and the United Kingdom as well, there were no new projects. And you don't see it right now, but in 7-8 years you will see this. You've got this downturn. In Germany, we experienced this in 2021 as well. And it was a 2020, 2021. It was a political decision to say we are getting out of the high targets, the high new investment targets for offshore wind and onshore wind, by the way, as well. And then we've seen a downturn of the whole industry. And then that's coming what you said. The industry, the value chain is not working anymore. It's breaking up. The people are getting out of the business because they don't have any business, and they are not coming back. Most of them are not coming back. We are right now doing this study again to see if what's happening in Germany, especially in Germany, but we fear that we are going to have the same effect this year or next year as well. And then there are many things. One thing is many more reasons, let's say. One thing is the grid connection problem I just showed you. Another thing is what you said, the financing. Yeah, when the interest rates went up, we've seen financing problems because of limited capabilities and so on. And so we have to get these 16 gigawatt really done, really financed, final investment decision, and then constructed. I think we are going to miss the targets much more than it's shown here in the scenarios. I think we are more on the red line than on the blue, and we are not going to be on the green line, I think. Yeah, I'll be here. I have to leave. Sorry, I have to leave in the afternoon, but I'm here in the first break. Yeah.
Just one question over here as well, please. Yeah.
Hi, thank you for the talk. I'm Paul Leahy, University College Cork. You showed that the predicted size of turbine was slightly dropping in the last round. And do you break down the data by where the responses came from? I'm wondering, will we see divergence where Asia, China goes for very, very large turbines, and maybe in Europe things stay in the smaller range?
Yeah, as you know, we can do this. I haven't got a slide with me because there would be many slides only for this question, for example. But the Asia is higher. The Asia rate is higher, much higher than the European and the North American. Yeah, that's right.
Thank you.
But the question will be how many Chinese turbines and projects in total and value chain we are going to see in Europe. You know that the first projects are now there. I'm about 20 years in this business, and I've seen a lot of Chinese investments. London Array, one of the first UK parks, it was built with, or it was supposed to build with monopiles from China. And they have to rework everything monopile, as I know. So it wasn't very successful. And that was about 10 years ago, or whatever, 12 years. So we've seen ups and downs and attempts. And so I've been on the Anaheim US Trade Fair, again, 10, 12 years ago. And there was one big hall, only Asian producers. And you could buy your complete park with everything, just the park, and it wasn't successful. We're going to see what is happening now. We've seen it in the photovoltaic industry, but this is different. The turbines are more complex and so on. Sorry, I'm taking the time. Thank you.
Dirk, thank you very much indeed.
Thank you.
A big hand. So Dirk has set the stage for us. We welcome onto the stage now Laurie Gilbert, who will present about the future of the wind industry in France.
Thanks, everyone. Okay. So I'm here today to speak about the French market, and I think it's quite different from most of your country ones. So before going deeper into the subject, maybe in few words, who is Qnergy and who am I? So Qnergy is a developer, constructor and operator of renewable facilities, solar, onshore, offshore, wind and storage. On my side, I'm deputy head of repowering, so I'm in charge of all the repowering projects for Qnergy France. And obviously, who means repowering means waste coming from the wind farm, and so what to do from them. Could you hear me? Yeah. I'm leading the activity on the French market, and so I'm focused on all the French wind farm. So briefly, what is the history of the wind industry in France? So I think we start working on the wind industry late in comparison to all other European countries. So we start to work on it end of the 90s. So we're working on this activity for about 25 years. It was quite complex at the beginning because we have a lot of constraints on the French market, so it was complex to develop this activity. So it takes few years to come to like a well-developed industry until mid-20s, when the activity is well developed and we could observe a lot of wind farms commissioned every year. And now on the French market we have about 25 gigawatts in operation. And so because we started 25 years ago, we are facing the first end-of-life issue. That is mean what we do for the wind farm, we decommission to put new wind farm on the same place. So wind industry, 25 years of experience on the French markets, a lot of wind farm to decommission, about 5 gigawatts right of now. And so the aim of today is to present what are the issues faced on those wind farms and what are the solutions proposed for the French markets. So end-of-life issue, I think the issue are the same as for all the country, what to do from a wind farm which is aging, so following the operation until the until the death of the wind farm, so running until destruction. Opting for revamping or large maintenance operation. So it's, I think, something which is sometimes observed in other countries. The difference on the French market is that we could pretend with repowering project to a new CFD for 20 years. So repowering is most of the time the solution preferred for the French market. That is why repowering is more and more investigated on the French markets, and other solutions as revamping or run to destruction are not the most famous one for the French market. But repowering leads to a lot of constraints, especially because you need to develop a new wind farm, and so you need to face the issue locally, and most of all, you need to tackle all the constraints to be able to build a wind farm which is compliant with the current regulation. This is a key challenge for the French market because in 20 years, the constraints are very different from the one at beginning of 2000. Though there is a lot of landscape or biodiversity constraint in most of the country, but I think the most important one which are facing in France are the technical one. It could be quite strange, but we have a lot of theoretical and radar constraints on the French market, which make the wind development very complex and kept the turbine tip height and turbine dimension, which is very complex because I think it's one of the only markets on the world which is requiring such small turbine. When I'm speaking about small turbine, it's like turbine of 125 meters, 150 meters, which is very small. So 150 meters, I speak about the tip height, which could appear very low for most of you, I think, when I see in the previous presentation, like turbine about 8 megawatts or something like that. It's not at all what we have on the French markets. And so with the repowering, we need to redevelop wind farm located in this kind of constraint, which was not the same at the time they were built at the first time. So we need to manage them. We need to find a solution to be able to reinstall a turbine and so a wind farm there. This could take time, but also it could make put a developer in a very difficult situation and prevent them to be able to repower the wind farm. So we have a lot of wind farm, but 10% of the wind farm in France we will not be able to be repowered because of this kind of huge constraints that limits the development. So what's solution for that? I think one of them is the one I would like to present to you today. It's the second-hand markets and the reuse of old turbine for installation of new one. it could appear like old-fashioned, but I think it's one of the solutions to enable to tackle those issues and enable to repair most of the wind farm on the French markets. Because, as you know, small turbines are no longer available in manufacturers' catalogs, so you are no longer available to buy 125 meter turbine. It's too small, capacity is too limited, so manufacturers will more develop their large dimension turbine as 150, 175 rotor diameter, which is not at all what we could use for the French market. So we will investigate the second-hand market. Second-hand market has a lot of issue because you need to dismantle the turbine to reinstall it on a new side. You need to refurbish it. It's like for your smartphone. You need to have a full refurbishment to be able to operate the new turbine for 20, 25 years. And so we are facing a lot of issue on that topic. Especially the first one, I think, is how do you dismantle a wind farm to be able to install it on a new site? The component could last over a new 20 to 25 years. Could we keep the blade? Should we refurbish them? Should we replace them? Should we rebuild them? If we need to rebuild them, is anybody have the pattern to use to build a new blades, or are we able to have the mold that enable to build those new blades? So we are facing a lot of issue with that. I will say that it's maybe quite simple for like some of the components. For instance, a tower. We could build a tower, and I think it's not the most tricky part of the wind farm to be refurbished and to be rebuilt. But some other parts, more tricky one or more important one at the blades, are very a key issue for us. And so that's a topic that we are investigating. Obviously, I will not say that all the repairing projects in France will be equipped with second-hand market turbine, obviously not. But a lot of wind farms that are very constrained right now and not able to print into another life with first-hand market turbine, we are investigating the solution, and we hope that with this option, we will be able to tackle this issue and enable to keep the green capacity installed, because repairing is not only increasing the capacity, as we often speak, but it's above all, just keeping the current one and increase it if possible. So for me, I think repairing is a key challenge, because we often speak, could we increase or could we increase? But if we don't keep the current one, we will never be able to increase. So I think it's a first issue to tackle, and then how to equip those wind farms. I think the aim was to briefly introduce you all those topics and maybe to collect your question to go deeper in this topic, depending on what you want to learn about. I don't know if you have questions.
Yes, thank you. Very interesting. My name is Bart van der Hoek. I would like to know, is this something you do then in very close collaboration with the original equipment manufacturers? Or do you see a new business emerging?
I would say very complex, because most of the time we are working on wind farms that have 30 years and older, maybe about 20 years. So most of the time they are no longer operated by the manufacturers that build the turbine. So we are more dealing with the company in charge of operation or the asset owner, rather than the companies that have built the wind farm. But yes, obviously we need to deal with it, because it had the right to maybe use the mold to produce new blade and so on. But yes, for some of the manufacturers we are facing a real challenge, because some of them are not very happy to deal with that.
Hi, Bettina Kröger, RWE Renewables Europe, Australia, onshore, just onshore. So you are maybe a customer of our Second Life wind turbines or spare parts? Sorry? You may become a customer of our Second Life turbines. So we are having a lot of decommissioning going on. We have internal spares management. So we are looking if some other wind farms or countries needing the spares, but we are also looking for external customers.
Okay.
So let's connect.
Yeah.
Thank you.
Laurie, may I ask something as well here? This is a fascinating conversation, really, and it can go a long way. In the aviation sector, there's a consignment industry where specialist companies are accumulating spare parts of end-of-life aircraft so they can be supplied quickly. Most aircraft flying today live off second-hand parts because the supply chain is just broken at present, yeah. So is there a case for end-of-life wind turbines to be put into store in some sort of way so those spare parts are available rather than trying to get new bearings built, new blades built? Or is there even a market for, or a logic for saying, let's start to concentrate on isolating a particular group of wind turbines and treat them a bit like, say, a Volkswagen Beetle car? It's gone on for decades and decades and decades as a good base material, base product for the international market.
Yeah, I think I would pick on the French market because it's what I know. When we decommissioning a wind farm to perform a repairing project, what we do for the old turbine, we try to sell them on the second-hand market because obviously it's what we have the more value and what is the more, I think, sustainable for everybody. And then if it's not possible and if nobody wants to buy them, we sell pieces to do spare parts. And yes, there is more and more companies that are collecting those spare parts, so in good condition, obviously. They're collecting them and store them, able to use them for maintenance. So there is a market which is growing there, and the aim is to be able, and once again, I think it's more sustainable for the industry. The aim is to store the component and to reuse them for the operation of the wind farm, because it's better to use, like I think, spare parts for some of them have some few years because they have already been changed during the operation of the wind farm we are dismantling, rather than building new one. So yes, obviously, I think there is a real market that is growing there and encouraged by the repairing.
All right, thank you very much indeed. A big hand. As we progress on, I'd like to welcome Julio Vidal to the stage. He's at the Composites and Advanced Recycling Technology Manager at ITEEP Centro Tecnologico, and he will talk about wind turbine blade materials and manufacturing.
Hello. Thank you very much, everybody. Thank you very much for the presentation. I'm here representing a spin-off of ITEEP, okay, Moses Productos, and I changed a little bit the idea or the title of the conference, because I'm going to focus not only on new materials that we are going to develop for the wind turbine sector, but circular materials that we want to implement in this sector. But first of all, let me introduce the company. Okay, sorry for this, but you know how it works. I have to introduce the management and everything. So we are a small spin-off. We are around 43 people. Okay, we were created from the technology center, and we are based in Spain. Okay, in Zaragoza. I don't know if some of you know where it is. You take the train from Madrid to Barcelona. There is a stop in the middle. That's where we are. Okay. We have different cores. We were mainly focused on thermoplastic materials, and we have been working on thermoplastic in the automotive, in the packaging sector. But we also observed that, well, as I said, on other products in thermoplastic, we observed that there was some room for us in the thermoset materials, okay? Mainly in the sports goods. We are a small company, so for us to produce a blade is something that is outside of our scope. But we have started to introduce ourselves in the thermoset part, and we have started to develop new materials that could be implemented in this sector. We have also thought about the end of life. I mean, when we are talking about the end of life of a thermoset, there is small differences between the end of life of a paddle racket, let's say, and the end of life of a wind turbine. Of course, the size, that's one thing that we have to take care of, but in terms of chemistry, the chemistry of both of them are quite similar. So all the approaches that I'm going to present to you are of course focused on the wind turbines, but they can be applied to our niche sectors, or we are applying them directly first in our sectors, which is the sport goods, and then we want to implement them and try to transfer them to some other players in this value chain that may be able to take them and upscale them to the size that is necessary for the wind turbine sector. Why are we a small company focused in this sector in which, you know, big companies are here, they have millions to put on the table, and I mean, we are SME, so we don't have that time of budget. Our region is Aragon, okay, and this is the future of our region. We are producing right now 50% of wind turbine energy in Spain, and if my numbers are right, it was around 5.2 gigabytes, okay? So just for a small part of Spain, it's huge amount of energy that we are producing, it's huge amount of blades, wind turbines, and the whole infrastructure that we are going to need if really we are to implement this map that you have on the screens, okay? All the, let me check, do you have a laser? No, okay. The red dots are the ones that we are trying to build in the region, and the purple ones are those that are authorized. Some of them are already running, and some of them will be running in the following years. But the scope and the amount of business that we can implement in our region in the wind turbine sector is really big. That means that we have a room to apply our improvements in this sector. Our improvements and a project that I want to introduce to you is Blade to Circ. Okay, it's a project, a European project, in which we are collaborating with different universities and different RTOs all around Europe, mainly a Spanish one, because as I mentioned to you, we are focusing in the Spanish market in this sense, but we have collaborators all around trying to extrapolate all of our results to the different environments and business cases that could be developed in Europe. And here, just to summarize which points are we working, you know the blade better than I do, but we are working on the skin, okay? We are working on different resins with bead trimmers. You might know what they work. They allow the recyclability of the blade. We are going to work on the core, okay, with bio-based carbon fiber, trying to reduce the environmental impact. And we are going to work also on the adhesives that are joining both cells of the blade and on the coatings. Why do we work in the adhesives? We have been just heard about dismantling. If we are able to dismantle the blade and separate it, then maybe shipments, movements, and so on of the whole blade will be quite easier. That means simplicity of the value chain and a high-value product. And in the coating, you know the erosion that a blade can suffer, so we want the blade to have the capacity to self-heal and through that avoid maintenance. Or if not avoid, at least reduce it, okay? So I will not go into the details of the project, but here you have some objectives, 50% reduction of, or 50% of use of bio-based carbon fiber. This means less dependence of non-European products, okay? We are going to use lignin, which is a product that we have in Europe. As I mentioned, I will focus reinforcement, bio-based carbon fiber, the matrix with the self-healing capacities and the bead trimmers, and finally, how this combination that we have done at the lab scale, okay, this is 1 meter part, it's not huge, but how it's going on and what are the results that we are obtaining so far. The numbers in terms of carbon fiber, Europe is not a small player, but Asia and North America are much bigger players, okay? We all know that. So if we want to produce our own carbon fiber to supply our own value chains, we need to think outside the box. We cannot think about bringing PAN materials because those PAN materials are not coming from us. So we started to think about lignin as an opportunity. You know the structure of lignin. What we can do is use this structure, melt it with a thermoplastic. Okay, in this we have tried several, and in literature you have several possibilities. We are working with the University of Limerick here, for example, to develop these technologies, and we are joining them with TPU. This extrusion allows us to have the lignin in the proper format, and then we can produce our filaments. These carbon fiber filaments, in this picture is up to 30%. We have achieved 50%, which means higher quantity and, let's say, better mechanical properties. Of course, we are still working on them, trying to reach the properties of the baseline. But you can see the work, it's quite similar to, well, sorry, it's because it's not pointing. We join lignin and TPU, and once they are joined, we extrude them, we produce, and then we produce the filament, okay? Here you can see the filaments. As I mentioned, our current properties are not sufficient to fully substitute the standard carbon fiber. So what we are thinking is doing a mixture, okay? 50% of our lignin, 50% of carbon fiber. And this way we try to compensate the properties of one material with the properties of the other. You can see several bobbins that we have manufactured in which there are fully carbon fiber based on lignin, and others that are starting to mix with the palm fiber. We have taken this to a textile, okay, we can produce the fiber, but if we cannot weave it, it will not be useful for the industry, and we are starting to have the first textiles. At this scale, I have to tell you that are quite small, something like such as this, okay? But a first step in the project to produce them. Once we have optimized the full weaving part, we will be able to upscale it to the next level. And we hope that in the following year, we will be able to have up to 1 meter size fabrics. With this, I go to my next point, okay, the epoxy resin and all the matrix that we used. As I said, you know better than I do the amount of material that is wasted sometimes in the fabrication of the wind turbine, and we want to reduce the scraps, and we want to use also the end of life. We have developed, well, there are several strategies for the end of life. We are going to talk about two. One, bitrumeric-like with DL Salder, okay? This means that when we want, we will be able to break the thermoset structure, okay? Separate the polymer chains, and on demand, we will join them again, so that we will retain same properties at room temperature, let's say, but when we heat up above 150, 120 degrees, they can, the polymer chains breaks, and it allows us to recycle the material. Okay. For those of you that are chemists, I don't know if there is someone in the room. If not, this slide is quite weird. These are the structures that we are trying to work on. You will see that, well, they have some bonds that they can break, and those are the bonds that we break. These bonds are here, okay? We break those bonds, and through breaking those bonds, we are able to separate the full polymeric chain. I will not go in detail because you are not chemists, so. And the synthesis that we have done, trying to increase the cross-linking so that our molecule will not reduce the properties of the resin that you are using. That's really important for us. If we develop a new resin and we tell you that it's fantastic, but the TG is for 50 degrees, nobody's going to purchase it, it's not worth it for you. So we are trying to increase the cross-linking and the breaking temperature to adapt to your needs. In this sense, any feedback that you can give us is more than welcome. And the other part is the erosion, okay? Here are some pictures, online pictures of a blade after several years, how it degrades, how the full coating is degrading, and finally, it can even produce defects in the glass, in the structural part of the blade, okay? So we want to introduce these self-healing particles with epoxy resin inside. Once they break, they reduce the erosion, or at least gives you more time before you need to apply the maintenance, okay? A new coating, a new layer. This synthesis, we have done it. We have tried to adapt the the size of these nanoparticles or microcapsules, let's say, so that they will fit the current processing technology, okay? If we make them too big, if we need too much, they are going to change the viscosity, they are going to block the spray coating gun. So we will adapt, we are trying to adapt. We are being able to encapsulate the epoxy and the hardener, and we are testing right now how this can behave in real environments, okay? We have some outside coating, and we observe if they are breaking properly on how they will behave. Some pictures of the same images that we are obtaining. You can see that really our capsules are fully, they are not broken. So once we apply them, it's not a matter of days. They will stand the conditions, and they will be broken only under the conditions that they are heated or when they are really under aggressive conditions. The epoxy resin, I mentioned also we are going bio-based, but I will try to speed up. Okay, these are some videos that we did for the infusion. First, we started with really small parts. The problem with this is that, of course, the resin is prepared for wind turbines, so it's quite liquid. The viscosity is quite reduced, and we obtained bubbles. So we decided to increase the size. Okay, as I mentioned, not a meter, 900 millimeters, 600 the other one. But you can see that the material is flowing quite nicely. It's a 2 millimeter carbon composite material that we are producing here. It takes, the upper one, it was around 3 minutes. Okay, the first batch, that is the second one, it was around 4 minutes. So we are improving, trying to reduce the viscosity of these new resins with these additives that I have mentioned to you, so that they will fulfill and they will be able to produce a full part on time without changing the current procedure. And just to finish some parts that we have also worked on the end of life. Okay, these are current blades. You know the thickness that you are using in these blades, so they are real. What we are trying to do is, through solvolysis process, we are trying to remove the resin from the matrix. The fibers from the matrix, so that we will be able to valorize both of them in separate value chains. Here you can see that we do not only are able to separate the matrix and the resin, so we are able to produce new fabrics from scraps or from end-of-life turbines, but we are obtaining the textile, the full textile, trying to retain the value of the fabric. We have done this a small scale, let's say, and we have done it at higher scale. This is already almost a half meter long part of carbon fiber in this case, okay, in which it was, if I remember properly, 3 millimeters or 3.5 millimeters thick, okay, and we were able to separate all the different layers after our solvolysis process. We then analyzed the quality of this carbon fiber, okay, is it good, is it degraded, what has happened to it in the surface, and does it still have some resin on top? You can see in the pictures that there is no resin on the top of the carbon fiber, so all the matrix have been released into our solvent. And the mechanical properties of these filaments are just 5% less of the standard carbon fiber. Okay, so we are in the good path to say that our fabrics will retain the mechanical properties. We are still upscaling everything, trying to obtain higher parts possible, and we are now studying how we can combine all these patches to make a new solution. So far, what we have thought and we are testing is for repairing purposes, okay? The old part, if there is some damage in the blade and you need to patch something and do an infusion on top of it, try to use the same fabric that is coming from other old blades without missing any mechanical properties. And just to finalize, everything that I have mentioned to you, we put it into this wind turbine end-of-life purpose. We are developing new materials from fabrics to matrices, adhesives, and coatings, but we understand that all of this is just different means to achieve this repurpose and be able to increase the amount of wind energy that we are using in Europe without the damage that all of these composites can generate in the environment once they reach the end of life. We are talking about gigawatts, that means tons and tons of material. That right now is really good, but in 25 years, 30 years, they will go down. And we have different strategies, but we need to find some strategies in which the value of all these materials is retained as much as possible. Here, just some of the examples in which we are working on. Thank you very much.
Julio, thank you very much. That's fascinating. A lot of work there and a lot of foresight for where things are needed in the future. Do you have any questions, please?
Julio, thank you very much. My name is Thijs. I work at BladeMate. Thank you very much for a very interesting presentation. One question that I had, for the re-winning this sort of carbon fiber mats, right? Yeah, this one. So what's your outlook on the economic model on this in comparison to producing it new? Because that's usually the hardest part, isn't it?
Yeah, for sure. I mean, in the parts of economics, right now we are trying to optimize the whole solvent part that we are using. Here I have focused only on the carbon fiber because it's the part that is more advanced for us, but we are also trying to recover the matrix. Otherwise, economically, it's not viable. Okay, I mean, we are lab scale, of course. Once you upscale things, the numbers can change. But at the scale that we are right now, we need to work harder and farther in the optimization of the solvent and the recovery of the matrix if we want to make a business case feasible.
Okay, so if I understand correctly, it is economically more viable to recover the full matrix rather than the fibers alone?
Both. We have to recover both. If we recover the matrix alone, it's not. The fibers alone is not. We need to recover both streams in order to make it viable.
Thank you very much.
Thank you very much. Excellent presentation. I'm chemist, so I got excited, but I think it was only you and me. Two things. I'm happy to connect you with other folks working on self-healing properties in coatings. And I think many of your concepts can be utilized there, but this is independent. A question on your new carbon fibers. You connect lignin, and I think it's lignin, it's sulfonated lignin from the paper industry, with urethane. Is it correct that it's sort of a lignin, polyurethane, lignin sort of block copolymer? Is that correct?
No.
And how strong are your carbon fibers compared to virgin?
Okay, it's not a copolymer what we are doing. We are doing a blending. Okay, we are mixing the lignin with the TPU just to shape the lignin. Okay, that's why
like a mechanical mixture.
Mechanical mixing.
Okay.
Yeah. Extrusion compounding process, so that we will mix both of them, so we can work the lignin, provide the lignin the proper shape, the fiber shape, and then we carbonize this material, so the TPU is gone, and we obtain the lignin in the proper structure, orientated in the sense of in the direction of the fiber. And in terms of mechanical properties, at lab scale, we have achieved same mechanical properties, 5% less, something like that, so really similar in good range, but at lab scale. We are not upscaling, and in this case, I will say, I can check afterwards, but it was around 20% less. Okay, so there's still some time to go. That's also why we want to mix it with a standard carbon fiber, because otherwise it will not reach the mechanical performance.
I have a question on this part, so on carbon fibers with lignin. So you performed both stabilization and carbonization on the fiber, and were you able also to perform graphitization? to improve like mechanical properties?
I will have to check.
Okay, because I actually know that I work with as well with lignin, and one of the problem was on mechanical properties, and actually it was quite hard to do a proper carbonization, apply tension on the fiber because it breaks actually. So it's really a good achievement being able like to do carbonization on these fibers. So.
Thank you. It's true. The problem that we are having right now is that during the carbonization phase, we are not breaking the fibers, but they are sticking together.
Okay. Okay.
So all of them go through the carbonization oven, and at the end, what we obtain, we look at the same, and we see that the fibers are glued together, let's say. So we don't have single fibers, we have multiple fibers joined. We are trying to optimize this parameter.
Well, good, thank you.
Well, thank you very much. A big hand, Julio. That's absolutely fantastic presentation. Now, please welcome now Eric Voss, who's going to present about refit, remanufacturing blade roots to avoid the waste of polyester rotor blades. Eric Voss is a materials and processing specialist at We4C.
Yeah, good morning. Thanks for this introduction. Thanks for the opportunity to say something about refit. The main focus for our refit process was to extend lifetime. And yeah, my name is Eric Voss. I'm a material and process engineer for the company We4C. A small introduction of our company We4C. We are a design company, so we are designing complete blades from small ones, 6 meters, to the big ones, let's say 80 meters. 2 blades designs, 3 blades turbines. We're also involved in the bushing connection for many, many years. From very small ones, M20, till the biggest one, M42, for the new types of bushings, blades. And we also have some customized projects like what I'm talking about today, the refit of loose bushings. Our office is located in the east part in the Netherlands, in Enschede. We are a small company, 10 employees, 8 in Enschede, 1 in China, and 1 in eastern part of Europe. Our work areas are in America, but mostly at this moment in Asia, but also in Europe. Why lifetime extension? Yes, I will start my presentation with a few nice paintings. Paintings of 300 years old. If you look in the Netherlands, you can see a lot of these windmills in the landscape. And yeah, 200-300 years ago, they had a lifetime and a windmill of 50 till 100 years. So the question is, 2026, it must be possible to reach that 50 years again. But reality, 20 years, 30 years, sometimes it's less. It's something to do with decisions and technical decisions, but also something to do with politics. But okay, it is what it is. And why we think as a company that it's important to have lifetime extension is that we have first more energy yield during the lifetime of the turbine, but also that gives us, the wind energy, more time to improve the recyclability of materials. So we buy a little bit of time, so to say, to improve recycling. Yeah, we as a company, we have our focus on lifetime extension. We do this, for example, with exchangeable blade tips, but also with power boosting, like vortex generators. We're giving design support, design of bushings. Yes, that brings us to my main topic, the refit. As I mentioned, it is a blade root technology for the aftermarket, so for service, for repair, but also in the end of life to extend the lifetime of of the blades. Refit, the name, repair, front infusion technology. We're doing a repair at front of the root with an infusion technology. It is we do it with an epoxy resin and with an infusion process. Yes, 2020. There was a year that the first case was popping up. There was a service company who asked us as company, you are specialized in bushings, and we have a problem with bushings in a polyester blade. These bushings are loose, and can you help us? Can you help us with this? This blade was made out of polyester. It was a 40-meter blade, M30 size bushings in it, and the operational time was, let's say, around 13 years. By doing this project, we thought, okay, maybe it's an incident, maybe some overloaded of a turbine, for example. We try to help this company. But 2 years later, in 2022, a next case was popping up. This was again a polyester blade with M30 size bushings. The root concept was identical with the first case. But this blade was only operational for, let's say, 7 years. We received also from the market that there are more problems with the blades. So that's why we say, okay, we have to do something. We have to find a solution for it to repair, because repairing of a root is not so easy. There are a lot of structural materials in it, and doing a proper repair, you have to do a lot of things, so it's not so easy. So we started with a refit project. And 1 year later, 2023, a next case. There was a case from South Asia. That is an almost 60-meter blade. Again, polyester, a little bit bigger blade, M36 size bushings. But the operational time was less than 6 years. And there was no solution to repair it, just replace it by new ones. So that means you have to replace it after 6 years, and there is a chance that after 6 years, again, you have to replace the blades. That means that in 20 years, you have replaced 2 blades, so in total, you use 3. So that's not acceptable. Then the question was, how big is this problem, if you look at it worldwide? So we did a short study, and we saw in the time frame these root concept, the blades that are produced with this type of root concept is produced in between 2012 and 2021. In that time, almost 800 blades are installed. 20% of this are polyester blades, and 20% of these polyester blades are affected with this root problem. It's a rough estimation, but it gives an idea how big this issue is. If you look at the locations of these turbines, we see that most of them are installed in North America, also South America, and Asia. Remarkable, we don't know issues with it in Europe. Just a few of them. So the question is there a problem in Europe? Maybe some of you know. Or maybe the blades are better or improved, or the loadings are different, I don't know. But that was a remarkable. Thanks to AI, what does it look like if we have 40,000 blades and we just have waste? It's something like this. It's terrible. So we have to do something. Don't zoom in too much on this picture because you can see it is not a blade. But okay, then you have an idea. There was, till 2024, there was no real answer to it, how to repair this. Only what was possible was a manual repair. We see this as a kind of temporary repair because you don't have a lifetime of, let's say, 10 years plus. And that's because you have to remove a lot of structural materials to do this repair. And the repair itself is also with the hand layer process, and it's a time-consuming process, and it's a dirty process. So from terms, also from health and safety, this is not what we want. And we talk about a high amount of blades, so we have to do something about it in automation and also to improve it so that you have a lifetime of, let's say, at least 15 years. Yeah, that brings us to the follow point. Before you can repair it, you have to know why are these bushings loose? What is the root cause of it? It's a long topic, but I want to go to do it short. Some remarkable things we saw is that the bushings is loose, they are loose, but also the surrounding materials. So it's like 2 steps. Also the wrapping laminate was loose. We also saw some dirty spots on it. In the picture you see some white spots and some, there's a pointer, isn't it? Whoop. Yeah, you see some white spots and some black spots. So the black one is dirt. We also saw resin-rich spots on the laminate and cracks in the resin. And the dirt spot is coming from oil absorption along the bushing. If you look in the bushing, then see till the end, you can see oil in it. Our end conclusion was of the root cause analysis is that the main root cause is the shrinkage of the polyester. Because a typical value of shrinkage of polyester, maybe you know it will be around 6, 7, 8%. If you compare this with an epoxy, it is around 2 or 3%. And shrinkage is a problem because the bushing itself is locked between 2 protruded bars. And between the protruded bar and the bushing is a small gap. That gap will be filled with polyester. And in that area, you have shrinkage. And that result in higher stresses in your material and also cracking. Starts with micro cracks, but during life it will be grow to real cracks. And these cracks will have the possibility to absorb oil. Now oil is like a lubrication, so they speed up the loose bushing process. So we have to do something, in our opinion, on replace the bushing not with a polyester resin, but with an epoxy resin. And for that we have, let's say, 4 steps. One is the measurement up tower, because not all the bushings are loose. It's more in the higher loaded area of the blade. And we see, let's say, 25–30% of the bushings must be replaced. And we can do that measurement up tower. It is a down tower solution, repair solution. So we have to lower it down the blade. Then the next step is then remove the bushings that are affected, including some surrounded materials. Then we are installing the new bushing, including some surrounding material, and we do the infusion. And the last step is flatten the root, because we also saw that the blade is not flat anymore. Maybe that's because the bushings are loose. So in the end, it is wise to flatten the blade and then hoist it again to the turbine. I have a video of 5 minutes. That is a video from the company Siwa. We run a project in South Asia, in Thailand. And that was the first case that we do the real refit of the blade or root. The company Siwa, and we also work together with a company in Denmark, See on Site. That is the design of the drilling machine. We can see it in the video. So it was a cooperation between 3 parties. And can I start the video? Let me see. Yes. Yes. For Asia, we call it Bushing Plus. It's a cooperation between Weaver See on Site Denmark and Siwa, company in Thailand, NEC company, also doing service. The blade root is on top. Between the pitch bearing and the blade root, you see some capping. The capping is because the bushing is loose. And you can hear it on the turbine if it is that the case. You also can see it here. Between the ring and the blade, there's a small gap. The repair of it was close to the turbines. There was a repair yard. There was a temporary tents will be set up. One tent was for drilling out the bushings, and the other one was for the refit to implement the new ones. Here you can see the drilling machine. It's a big one. You can install it on the blade root. First you start with alignment of the drilling machine, that in the right position the bushing will be drilled out. The drilling is in two steps. One is with a metal drill, because the first part of the bushing contains a lot of metal. So the first, let's say 20 millimeters is metal, so we do it with a metal drill. And the rest we do it with a composite drill, so along the bushing. Here you can see the drilling along the bushing. It is a dry drilling process, so without water cooling or oil cooling. So in the end, the hole must be clean and have a good surface. The old bushing will be removed. Here you see the old bushing. The white is the composite part. This is the result. So ready for the next step. We will implement new bushings that are V4C bushings, of course. Optimized for refit. We prepare them by cleaning, by sandblasting them. The next step is that we wind it with fiberglass roving. We do it with a machine designed by us, by V4C. And then we've wrapped it with some glass layers. Insert it by hand. The fiber volume content is around 50-55%, so what is also for the blade itself. Alignment of new bushings, so that we have the right position, the right PCD. Yes, they will be glued in, so they are fixed on the right location, and also vacuum tight, because it's a vacuum infusion process what we are doing, so we need a vacuum tight situation. So we have on the system an inlet and an outlet. In the outlet we do is a connection to the vacuum pump. We have some, oh sorry, how can I solve this? Please help. Yeah. Yeah, let's say 30 seconds. Go back to 30 seconds. Yes, thank you. Yeah, so there's the outlet is with the vacuum panels. There will be a connection on the bushing itself, an outlet that is connected to the bushing. The inlet is through a hollow thread. So on the inlet side, the resin is going in from the back. So the inlet is in the bushing, and outlet is also in the front of the bushing. Each bushing have a connection, an inlet connection and an outlet connection. And we're doing it step by step. In this case, it was around 30 bushings. So let's say 25% of all the bushing are replaced. And that is in a higher load part of the blade. When the infusion is complete, you can see in the outlet that the resin is going out. Then you knowing that the infusion is completed. And then the next step is, because it is the epoxy, you have to cure it. In the end, you have to remove everything, and the bushings are ready. The blade itself will be flattened at front, and then it is ready to hoist up again to the turbine. And that is the result at the end. Ready for the next, hopefully 15 to 20 years. These blades were 7 to 8 years old, and everybody's happy in the end. So yeah, this is in 5 minutes what our refit process is. We have a lot of projects running now. This one was in Thailand, and the next two are in India, and also with a company in Vietnam. And they are lookalikes of this one. Yeah, what's important in our opinion is because what we are doing, we have designed this refit process, and this is like a technology transfer. So we need to train the local people. We work together with service companies. We're doing the training for the drilling machine with the company CNC on site in Denmark. And we also do the infusion technology. We do education for it in the Netherlands. And we also give them on-site support for the introduction of this technology. Yeah, go short. Why we see the refit solution? Yeah, it is a control process, so the quality is consistent. We do not affect laminates around the bushing. Only the part that is affected will be replaced. It's a clean process, and in the end, we also have done a lot of tests with this solution. So static test, extreme test, fatigue test, and in the end, we also have a certification for it. The next steps in this project, it's the last slide I have. Yeah, first one, repair as much as possible, because you saw that waste, a mountain of waste, and to avoid that, we have to repair as much as possible worldwide. So that's step one. Step two, parallel on it, we also will bring the refit to a next level. Let's say it's a 2.0 level, by reducing cost and reducing process time. And we also want to do some additional strength tests on different types of blades, different types of configurations. Yeah, my last one. I started with a painting, I will end with a painting. This one is a modern one, painted by a friend of mine, so I'm a little bit proud of it. You see this in the north of the Netherlands, this painting, and I hope that in 50 years that you can still find this turbine in the landscape. That must be our goal, in my opinion. I know it is not only technical driven, this issue, it is only to do with replacement of better turbines, or more effective turbines, or more political driven, but in my dream, I will see this also in 50 years. Yes, that was the presentation about refit. Thank you. I see a question popping up.
Yes, a question popping up. Thank you, Robert Slemmer again.
Yes.
Eric, thank you for your presentation. Of course, we know you already for, I think, 30 years.
Yes.
Of course, you mentioned the polyester blades. There's only one polyester company making blades, I would say, in the world. Mostly LM Wind Power. I'm not allowed to say it, but yeah, there's only one who makes the quantity of the blades also in Europe and US.
Yes.
So, and I know also a bit of the root cause. The global expansion of making wind turbines means also you have to increase the capacity of all kind of blade manufacturing. And there was only one blade manufacturer in the world for polyester blades who had to expand rapidly.
Mm-hmm.
And it was funny to see that in Europe, the quality of the blades were better. As you said, in Europe we don't see these issues with the blade bushings,
yes.
But more in the US.
Yes.
We know also that LM started mostly in Europe, later on expanded around the globe. Mm-hmm. And there you see the issue, because it's not only an LM issue, but looking at the quality issues when you grow a company, we see it also at other companies.
Yes, yes.
At TPI, we see it at Texas in Brazil, yeah. We see it at Ares, we see it also at the new Chinese companies. So everything has to do with the workmanship of composite
yes.
projects. Yeah. The moment you have a very good quality system and you follow every step, then there's no blade failure.
Yes.
Because I can see the bushing winding giving the root cause mostly of these failures.
Yes.
That means there's something wrong in the quality process control. That's one. Yes. I think that's the main reason of having these root causes, and it's fantastic that you have made a solution for this, otherwise you have to throw all the blades away. Yes. But there is a reason behind, I would say.
Oh yes, yeah.
Yeah.
It is. What you talk about is not only for polyester blades, I suppose, also for epoxy blades.
Yeah, I know.
Yeah, it's true. Yeah, but we said mainly with polyester blades, and it's not to blame a company or whatever.
Yeah.
But what you're saying is true. It is something to do with the quality of production, but it's only something to do with the design. I think my personal opinion is this is also something to do with design decisions, because in this case, the polyester have the chance, so to say, to have shrinkage in an area, in a critical area. Okay, it is what it is, and these blades are built, so we have to repair them. And I agree, we also have blades built with epoxy, with problems, but not in this quantity. And there's more incidents. But I agree, we also saw in this case about China, a lot of blades made out of epoxy, also with problems.
Oh, yeah.
True. Yeah.
Thank you.
But we're not part of it for repair, not yet. More questions?
Does your repair prevent this happening again?
That's a good question. We hope, we believe in it, and that's because we do not repair it with a polyester resin, because if you repair it with polyester resin, you have the same situation again. And again, you have a gap between two hard materials, between the potential bar and between the bushing. And if you fill that again with a polyester resin, then again, you have a problem with shrinkage. We repair with epoxy. Epoxy also has shrinkage, we know. So a little bit of introduction of the same problem we have, but because the shrinkage is that low, and also epoxy resin is a little bit higher in mechanical properties, we don't expect a problem within, let's say, 15 years again. We did a lot of tests, also fatigue tests. Until now, we hope and we think that it is disappeared, at least for 15 years. And that's also one thing, because this is now more like a repair solution, but you also can use it for lifetime extension. After, let's say, 20 years, if we decide to extend the lifetime, maybe it is wise to say, okay, let's take a look at the blade of 20 years. Maybe in the higher load area, we will replace some bushings. If it is a polyester or epoxy, it doesn't matter. And then to extend lifetime. Yeah. I hope I will answer your question. Yeah.
Just one more question then, Eric. How about epoxy blades?
Yeah, that was this question, a combination of these two. Yeah, it is what we saw, because all these cases were coming. All of them was about polyester resin. Some of them were also from epoxy, but it was a kind of incident. But we saw, we saw that this blade brood concept for many types of blades were with polyester. And that's why we focused on the refit on polyester, because there are a lot of blades are involved. But it's true, also epoxy can have problems, because they have to do with some design decisions, but also with the quality of the production. And yeah, to be honest, not all the blades that are produced worldwide are high level of quality. So also blades with epoxy in combination with bushing solution, because it's good to tell. I think a lot of you know you have two types of connection, of blade connection. One is with a T-bolt and one is with a bushing. And within, it's, I think, roughly 50-50 worldwide. And in the bushing solution, most of them will be made with epoxy, and a few of them higher amount, but relative is a few with polyester. Yes, a boat. Yeah.
Thank you. I have still one question for you, Eric.
Oh, not a hard one.
No, another one. Okay. The blades are designed according to specification.
Yes.
We have seen in the field many operators overrating the output of the turbine. That means that the turbine has extra loads on the blades, on the turbine, just to create more energy.
Yes.
That is mostly also one of the root causes of failures. So saying, hey, it's a design failure is not maybe always correct. you always have to look at the loads also of the turbine and who's operating this.
Yes.
Because if you allow to produce more energy and going over your strength of your turbine blade, for sure,
Yes.
they will damage.
Yeah, yeah, that's correct. The first case that was popped up in 2020, the root cause analysis gives that that was because of overloading the turbine. It was true. So for us, it was the first case we had, and we say, the root cause of this is overloading of a turbine. So yeah, it's not really a structural failure or production failure. It's more overloading. And it could be that a lot of these blades that have problems is because of overloading. That's possible. Yeah. So it's true what you're saying. It's to say it is a design failure is maybe a little bit too fast conclusion. I've been in between, so I know. Okay. Okay.
Eric, thank you very much. Big hand, please.
Okay.
Before we break for coffee, we'll welcome Dr. Albert ten Buschen. He's Associate Professor at the University of Applied Sciences at Windesheim, and he's going to talk about the long-term performance of reused end-of-life materials, thermoset composites.
Yeah, thank you. Yeah, thank you for inviting me to tell about our reuse method and the long-term performance of products, new products made with it. I'm assistant professor at Professorship for Polymer Engineering at the Windesheim University of Applied Sciences. We have developed a reuse method for end-of-life thermoset composites, which is based on keeping the composite intact, but make it into smaller pieces, like flakes, with a good LD ratio, so that they can reinforce or can be used as reinforcement elements in new products. For this, you have to embed these flakes with some virgin resin in order to bind them together and to make new products. We cannot make new rotor blades from flakes that we obtained from this rotor blades, but we can make new products that are strong and robust for instance, infrastructural applications. So below you see the process that the end-of-life composite, like the rotor blade, is processed into flakes. In Rotterdam, there's the company CRC that does this on an industrial scale. And these flakes are a raw material, an industrial raw material for making new products like profiles for retaining walls. We have made, since 10 years that we have worked on this method, together with industry partners, several full-scale demonstrators, like a retaining wall project, guiding beams for guiding ships near bridges in Groningen. We also made crate mat for heavy building machines, and also decking profiles for a traffic bridge, and side panels for buses. We have shown that when you use a pultrusion process, an efficient process, you can have a positive business case and a low CO2 footprint. And we also investigated whether harmful substances can leach out, which is not the case. We obtained some awards for this method, and one of international awards was the JEC Award for innovation in the sector of building and infrastructure. So we are very proud of that, and we are also proud that at the moment also a company in Rotterdam is making profiles with this pultrusion method. This is essential to use an efficient process, a continuous process, which is pultrusion. Well, I think all of you know this process also from virgin composites, but we combined the flakes and put them into a virgin mantle of GRP mat and also layers of UD GRP in order to be able to do the pultrusion process. And in this case, also you can have a high filling with end-of-life material, which is also essential for costs and CO2 footprint. In the development, we used the pultrusion setup of AOC to show that we can produce such profiles and also have good strength properties. And in this way, we can reuse traditional thermoset composites because, well, we are gathered here to also to find solutions for the rotor blades, which are most of them up till now from traditional thermoset composites. And we expect that the coming 25 years at least, we have to do something with them. Something better than bury them or incinerate them. So we have found a solution to remanufacture them into profiles for infrastructural applications. It is important to assess also the long-term performance because we also get questions about it, and also the long-term performance is important also for the LCA. The longer such products last, the better it is for the environmental cost or the reduction of them. We know that for virgin composites at the moment, we say that they have a surface life of 100 years in outside conditions and have advantage over wood or steel that are attacked in these conditions. And our hypothesis was that also these reused composites would have the same surface life of 100 years. We base this on the fact that we have a virgin GRP mantle and completely embed the flakes with the resin, with the virgin resin. So it's important, as I said, to assess this long-term performance for the applications that we're aiming at. And we have investigated two cases, the retaining wall, which is a case of a permanent wet condition and permanent mechanical loading by the ground pressure. Traditional material like tropical hardwood will last 25 years and has then to be replaced, and with reused composite, a surface life we claim of 100 years, so that saves a lot of dismantling and replacing. For heavy traffic bridge decks, it is even a bigger difference in surface life, with the wood only have a surface life of 10 years because of the dynamic loading. We have investigated these cases and also did the LCA analysis, which is positive for this reused material because of the longer surface life. The outdoor applications, we have investigated influences of moisture ingress, but also of temperature and loading type, permanent loading or dynamic loading. And we did this with model type of test specimens, also to make comparisons. In the beginning, we only used polyester resin, but later on I will tell also about our investigations on new emerging resins. We investigated these different effects and found also that the behavior is similar to of virgin composites. We investigated moisture uptake, which is very slow with thick composite specimens. And also we investigated the effect of long-term ingress on the neat resin, which is very limited. 1 year's water storage does not give much difference in strength and stiffness. We also investigated creep loading, for instance, for retaining walls. This is important. and we could also model this creep compliance to follow the creep in time. Dynamic loading, fatigue is important for instance, bridge deck applications. We investigated this with our fatigue setup, and we have two test parts. And we could make the typical S log n curve for the failure as a function of number of cycles. Well, what is a suitable design method? We adopted the method that is currently developed for virgin composites. It's the European Eurocode that is in development. And we investigated whether we could use this method. And this method is based on the use of conversion factors to put in the effects of the environment and material factor for statistical effects on material properties. So we could work out this method also for the reused composite. And however, we saw with the fatigue that there is a difference in the predicted line with this method and with the test results. So you have to take this into account. Well, the next phase for us is to investigate also new resins that are developed, recyclable resins like the helium resin of Arkema, but also other resins from Swancor, Exxon Mobil. And we investigated it with the view on future developments, because if these resins can be used to make composites, then they can be recycled maybe in a better way than the traditional thermoset composites. So that's why we also investigated these resins. And there are some promising results with the helium and the Proxima resin as compared to polyester. The strange thing is, when you look at the neat resin properties, like the stiffness and the strength of the resin itself, then they are lower than the polyester resin. However, if you look into this combined reused composite, the results in strength especially are much better than with polyester. And that is caused, we think, by a better adhesion with the flakes, that you get a better strength. And also this is observable from the fracture behavior. Well, the conclusions are that we have to reuse traditional thermoset composites like in rotor blades for the coming decades. So we have to solve this legacy at least the coming time. We have a closed loop solution with our reuse method for this, with a positive business case when pollution production method is used. And we see that the long-term performance of this reused material is comparable to the virgin composites, which is 100 years of service life. Of course, we cannot prove this only by accelerated test, and that's why we have made also an exposition platform where we put our reused specimens. And well, I will not survive it that we tested over 100 years, but at least we have made a start. Also to see in real practice what happens with the materials in the sun, in the rain, but also under the water. We do further investigations also in this design method, this European design method for this reused material. And we do further research in these recyclable resins, like the helium resins and other 3R resins in the reuse method. So this is what I wanted to tell you, and thank you for your attention.
Hi, thanks for your talk, Chen Li from Tino. I have a specific question on your LC results. So you compare the CO2 emissions from the tropical wood and the recycled glass. Is really a fair comparison, or what is your function unity here?
What is exactly your question?
It's like, yeah, you compare like these two. For me, it's very different things. So what is like the function unity? So like, what do you compare in the LC?
Yes, well, we compare profiles that are made with this reused material, and then you can see what is the behavior also in time. So we don't have a same functionality of these specimens with virgin. However, in comparison with tropical hardwood, we made these profiles exactly with the same initial strength and stiffness as these hardwood profiles, and then also followed it in time.
Okay. One comment, you have like a document for the LC readouts, of course, is it shareable or not?
Yes, we have made a report also with these cases, and
yeah.
I can send it to you.
Yeah, thanks.
It's in Dutch, but...
I can read Dutch, it's fine.
Okay, and maybe Harold also can help you. Yeah.
Thanks.
Okay, but I can send it to you, yeah.
Hi, Dr. Bussen. Very interesting presentation. My name is Reinhard Kessing. I have a question. Can you use 100% of an end-of-life wind turbine blade for your process?
Okay, that's a good question. No, I think that not all the parts can be used. The company that is doing the shredding to flakes does have to have smaller pieces bring to the company, for which there has to be paid a gate fee. Especially the root parts are so massive that for their process it's not possible to shred it. So that's the first part of the rotor blade. The other parts can be put in the shredding process. However, a lot of dust is formed during the shredding. So only 70% of the initial weight is transferred in these flakes, and the other part is dust, which we think is also especially adhesive and also foam in the rotor blade.
I mean, that was my question, really. The fillers, if I may call them, this could be balsa wood.
Yeah.
This could be PUR foam, whatever. I didn't see that in your process. What do you do with the foams or the fillers, I should say? You sort them out, basically, everything before?
Yeah, most of it is extracted as dust in this shredding process. Yeah.
And you cannot use it. So what happens with that material?
Yeah, they have, well, not a full-scale operation for that, but they have a pyrolysis process because this dust is rather polymer-rich, so they can polymerize.
All right, super. Thank you.
Yeah.
Have you thought about the next life after the 100 years of your product that you've created?
Yeah, that's a good question. In principle, our products of reused composite can be reprocessed in the same manner. And you would expect a downgrading of the flakes. However, there is also some virgin reinforcement as well. And maybe in future, when you have industrial operations for other processes, or reused products are recognizable as composites, so then they can process also with other processes. Yeah.
First of all, very good presentation.
Thank you.
Really,
yep.
Appreciate. My question goes more to the process part. How do you ensure that all the flakes are oriented in one direction?
Yeah, that's a good question, because that's not easy. The flakes are not very like a particle-like filler. It's easier to do the dosage. But these flakes can be oriented with a vibrating gutter, so to speak, and then you can orientate them, not all exactly, but for the most part in profile direction.
Now the second question comes, how do you ensure the density of the profile. That the density is uniform, because I saw that there is a lot of voids which fills the resin.
Yeah, but that's thanks to the pultrusion process. Then you get a high compression of the material that comes in. So you have the dry virgin reinforcement layers, the glass layers, with the flakes that are orientated inside. Everything is folded together. And then in an injection mold, the resin is pushed in this preform, and then it enters the pultrusion mold, and then it's compressed. And then the compression is at such a level that you really, well, squeeze out all the voids. So you have a completely impregnated structure.
But when the compression is happening inside the mold, so the resin will stay and the flakes will come back.
Yeah, well, that is possible maybe with big profiles. We did not do this industrial, but with smaller profiles, this does not happen. Yeah, it is squeezed together and it is pulled with the UDA layers into the mold. Yeah.
Thank you.
Yeah.
Thank you very much. I have a question. What about the cost compared to other end-of-life treatment, and what are your markets?
Okay, yeah, that's a good question. We looked up, especially for the replacement of tropical hardwood, because tropical hardwood has a price level. With this process, you cannot completely compete with the tropical hardwood price. It's about 30% higher with the same quality, same type of profile. However, with the longer service life and also with the circularity, water authorities in the Netherlands are willing to pay this 30% extra. We also looked at other types of products, and then it's difficult to be profitable. In fact, we looked also at railway ties, and then you have to compete with concrete. And concrete is so very cheap, and also concrete, when it is well made, has a service life also of 100 years. So that's not a good business case. Besides that, when you want to apply this product in how do you say it, in the railways, it's quite a certification process before you are there. So it's important to find the good type of products for replacing traditional materials to have a good business case. And we found this in tropical hardwood. Yeah.
Hello, Professor Albert here. I'm here.
Oh yeah, sorry.
Yes, I actually met you 2 years ago in another conference issue from KU Leuven University.
Okay,
and thank you for today's nice presentation. I have a question for the quality control, because when speaking of the reusing or repurposing of the Winterman blade, we always have a question how we can make sure the quality consistency for the incoming blade material, because we all know for different benches of the blades, they have their different fiber layup, so which means their properties are different. If we want to reuse them in a certain application, we have to make sure their qualities.
Yeah.
Yeah.
Yeah, that's a good question. We see also when you shred different type of composites, we also investigated polyester boat hulls, composite boat hulls, then you can get completely different type of flakes and also not such effective reinforcing function of it, because they are mostly glass mat reinforced or spray up glass reinforced. However, with the windmill blades, there's a lot of orientated reinforcement. So then you get the flakes also with a good LD ratio and also with a good reinforcing action. So the flakes that we get out of these rotor blades are giving good reinforcing action in this reused method. Yeah.
Thank you.
Yeah.
Okay. Can I ask the last question?
Yeah.
So do you foresee Okay, if we go with the repurposing or the reuse method for dealing with the end-of-life wind turbine blade, is that important that we first build up like the material passport or the quality characterization standards for this field?
Yeah, I think it's important to make, also see what type of rotor blade there is. Up till now we have only glass reinforced rotor blades that were shredded at this company. But nowadays you also have a lot of carbon reinforcement in the spar caps. So we don't know what happens then, so you have to investigate what happens, what kind of material you get. And also, we have excluded up till now also rotor blades with balsa wood in the sandwich layers, because we think that this also will have a bad effect on the durability in wet conditions. So there are some limitations, and I think it's important to see what is inside the rotor blade, and also to see what comes out products that we make with this method.
Albert, thank you very much. A big hand.
Yeah, thank you.
There's an opportunity now to get a little bit of relaxation. Restroom, networking, coffee, just through the doors behind you. Thank you. Right, we return here for the second part of the morning session. Please remember to put your phones on silent, and we start up with Bettina Kroger from RWE. She's a Senior Sustainability Manager looking after onshore wind, covering renewables in Europe and Australia. And she's still going to talk about wind turbine blade sustainability and circularity.
Thank you. My background is environmental engineering, and I'm with the renewables business about 30 years now. And with RWE Renewables, I'm 16 years. It's okay. I would like to talk about the challenges of an operator. So we saw a lot of research, good solutions for retrofit, but what about us? So what is our role? How can we give impulses and work together with you? First, I will talk about the today. So how does our business look like? Where are we having assets? And I will give you a shocking overview about our decommissioning pipeline and numbers. And then I will also show you already some nice projects going on, and think together with you on how we think shall the future look like if it's ideal. And now it's not moving. What shall I do? Yeah, I did, but okay. I don't know who knows RWE as a coal and atomic company, 127 years old, funded when electricity was born. And now you see we are a green business with all different technologies you can imagine. And if you look at our portfolio, you see half is wind, onshore, half is in the US, and the other half is in Europe, UK, and Australia. The US is growing, Australia is also growing. And you may also not know that we are acting along the whole cycle of a product lifetime. So we are starting with looking for the land, developing projects, construction, operation, and we are also responsible for end-of-life management. We are a sustainable company for the whole RWE group, including also the gas part. We have ESG policies in place, and we participate in many, many ESG ratings. So the value of our company is also based on how we act sustainably. My personal focus areas are decarbonization and transformation towards circularity, and I play with the regulators, which is really exciting. So I can also advise our guys who work in Brussels or somewhere else to fight for us. And we also work together with Wind Europe. These are the shocking numbers I promised you. We have to decommission thousands of blades during the next centuries. We already decommissioned 15 years, but now it's really hard. And we have to work together on that. These numbers come from offshore and onshore all over the world. Here you see our value chain, and just where you see that little RWE, we have influence. So we just have direct influence in the operational phases. And everything what is before and after, we can just influence by finding a good contractor for decommissioning, but anything else we have to support growing. So it's really challenging. Here you see along the waste ladder or R ladder, however you call it, what we are already doing. So we work with Holcim on co-processing. I read somebody from Holcim is here. Who is it? Not here yet. We work with Plaswire on mechanical recycling in UK. We have some research on mechanical recycling into concrete in Spain ongoing. We bought the first Siemens Gamesa recyclable blades. We have research ongoing for repurposing material into noise barriers. And we have a highly developed internal spares management, and we also buy second life spares for internal reuse. And now I have some deep dives. So I said we are using the Siemens Gamesa blades. It's a bit of a, it's great that they were first, but it's a bit of a pity that Siemens Gamesa blades will need solvolysis, chemical treatment, and this is not developed yet, and there may be also environmental issues with the acid. But we bought the first for 3 wind farms and we are operating them. Blade reuse. This is a research project together with a university in Karlsruhe and the German railway highway company. So the products coming out of this research project will be a certified product for German highways. And we also developed this project together with a German railway, and after some additional certification steps, they can reach also the certificate for that. And I heard UK is also interested into that product. This is one of my decisions when I started my job 4 years ago in sustainability. We joined a consortium in Spain and we grew a company for full recycling of wind farms and solar farms. And this company is now operative, and we decommissioned our first wind farm in Spain with a result of 99.8% recovery. And yeah, this is great. So our Spanish colleagues start from the very beginning and reach the highest we ever saw. This company, Renecycle, is also 10% shareholder of a waste-to-fiber company, which is by low temperature, high pyrolysis recycling blades. We are expecting
the operation in 26 in the summer. Mechanical recycling in UK with Plaswire. We are very much looking forward to the next steps. So, to summarize, our challenges are high cost, very complex logistics. So we, in most examples, we don't really know what consultants are doing with the decommissioned blades. And we have really less recycling facilities. So if we do not grow the markets faster, we are forced to burn the blades, because co-processing and mechanical recycling would be the next steps, but they are really costly. And we have to run a business. It's not me making wishes. We have to pay as a company our decommissioning. Yeah, solutions, better understanding and cooperating on recycling, also finding partners for the downstream, and being very active in cross supply chain. And if I then dream, we have some new blades. We have some blades with materials made for recycling. We have that blade design made for recycling. We have the full value chain, including also the facilities and the products for recycling. And maybe they are different, but we have to start now with a value chain for old blades and really start with the new blades, because we can't wait another 20 years. Thank you very much.
Thank you, Bettina. Interesting presentation. From regard of your background as RWE, buying turbines, you see basically in blades recycling that the OEMs are taking 3 different strategies: GE, Vestas, and Siemens Gamesa. What is, to your opinion, the preferred strategy if you compare those with each other?
You didn't talk Nordex and Enercon?
I consider those, well, yeah, but they have not a specific...
Yeah. I think every step is great, but if we do not take the last step to have really fully circular materials, we can't make it.
Meaning?
Meaning, Siemens Gamesa, for example, is selling a recyclable blade, but it's not really...
It's a postponed strategy.
Yeah. So we do not need marketing or dancing around this topic. We need really steps.
Okay, thank you.
So I'm talking every 6 months to all the experts of turbine suppliers, and we have all producers in our fleet, and yeah, we need action, more action.
I have one question, if I may. Reinhard Kessing, my name. You mentioned in one of your slides that there is some blades that you are sending to incineration. When I went to school, I learned that glass doesn't burn very well. with a content of 40 to 60% glass content in a blade, how can you, with conscience, send it to incineration?
There are new technologies available which make it. I'm not in all the depth, but yes, I know that they killed their facilities with testing blades and processing and burning blades, but I didn't had a close look into the new technology.
Yeah, I'm very much aware of when you burn a blade, the VOCs you generate, the HAPs, hazardous air pollutants. So I think this is just an excuse of the industry to get rid of the blade when there is much better uses for it. I mean, this is incredible that people still promote it. I mean, it's almost worse than landfilling. At least there they don't emit. So
Yeah.
you know, I think we should hook up together and you know, look at what are the
Therefore,
possibilities.
I'm here and I'm showing you examples, and I'm trying to convince the blade manufacturers to take more steps.
Yeah. And by the way, every blade that was ever made is already 100% recyclable today, if you have the right technology.
For which, yeah, and for which cost?
No, profitable. Like I said, we should hook up.
Thank you.
I had a question. Sorry, I had a question around. You had your waste hierarchy shown there, and you had 3 technologies for recycling, being pyrolysis, pyrolysis, and mechanical grinding. Were those in order of preference for you, or have you ranked those in terms of order B's preference?
Yes and no. So we are having decommissioning markets in a lot of countries, and we have to take and support what is locally possible. So in Spain, it can be to invest into a company and a pyrolysis plant. In UK, it can be mechanical recycling plus wire methodologies. In Italy, we are not sure what road is for us the best.
Yeah, but in theory, if you had all 3 available, is there a preference?
I guess mechanical is at the moment the best,
Most mature.
and pyrolysis is the most promising.
Yeah. Okay.
Yeah.
Interesting.
Yes. I actually agree with Reinhard, and that doesn't happen so often, but yeah, if you incinerate it, the glass is basically turned into ashes, and you still have a lot of emissions. So it's, for me, you know, I've been in the wind industry since 2000. I built a lot of turbines, roughly 50,000. So, you know, I'm pretty passionate about it, about the wind industry, and the wind industry being really circular. So that is for me, for us, for our company, that is total greenwashing, because the industry, you know, a lot of them, they simply don't know better. But I think it's the worst application that is out there. So I'm not scared about your numbers, because 2,000 blades, that's not even our yearly capacity that we are building up. So that's fine.
For which company are you working?
Jewel Mine. So we are basically recovering all the resources with a very high material health. So different system, not pyrolysis, well, high temperature thermolysis. But it has the, you know, you probably will learn tomorrow about it when I speak. Yeah, I think there is a commitment needed, especially from players like you, that projects get off the ground, right? So usually we work with the asset owners, because the decommissioning companies, most of them, I'm not saying all of them, but most of them, they give a damn where the blades are going. So it's basically you have it in your hands to decide where, how they should be, for example, recycled. And with some of your competitors, they have, I think they like the way, how that goes. So, yeah. But my question is, how do you actually select the route or the strategy? Because for us, from the outside, it's very intransparent. Yeah, so that would be very interesting. Know what are the decisions criteria to either invest or to decide for certain technologies. Yeah, I'm curious about that.
Yeah, I can answer that. So we are developing our strategy beyond 2030 for blades circularity. And we signed also a landfill ban with Wind Europe. So we have sometimes the problem not to landfill, but to burn, and we want more. But the business, sometimes we can just advise the business, and they are then deciding what cost. But with the so we are the sustainability experts, and the departments. So if you decommission a wind farm, then it's the construction department paying, and they just have a budget. And if they are not allowed neither to landfill nor to burn, so no landfill, we are there yet, but also what comes next needs a board decision, and we are working on that. And then it will be implemented. I'm -1.
Yeah.
Okay, we have a little extra time.
Yes.
I think it's all about shareholders' money and investments. So first a little history, and Albert, then you know it also. In 1976, the car industry was willing to use composites. And in that period, the Europeans said, you need to prove that it is recyclable. So DSM and BASF worked together to design a new machine. That machine was called ERCOM. That machine is operational, it worked, and we proved in Europe that it was possible to make from out composites fractions to reuse them as nearly virgin material. So the same process we are now looking at. So we are 50 years further. So there's not something new what we're developing here by shredding and getting into fractions. We proved it in that period already. However, it was more expensive to reuse the materials rather than landfill. So what is the root cause? Is we don't want to pay for a sustainable solution. And it's the same now with RWE. I think the developers should insist to reuse the materials and not keep it open. 10 years ago, we had also discussion with RWE about sustainability. And I've been working at all blade manufacturers, and they all said, yeah, we have a sustainable solution with new resin systems, but nobody wants to pay for it because the turbine price goes higher. And all the developers say, no, it's too expensive, we don't do this.
At the moment, you just can pay, buy Siemens Gamesa recyclable blade for a higher price.
Yeah, that's,
And that's
but we're talking about 10 years ago, eh? So,
because we have to buy what is available.
yeah.
And we did it for offshore. For onshore, we said maybe we push more the onshore suppliers.
But I mean, this is already for many years the same topic, 10, 15 years. But if we had decided in that period, we're gonna pay more to get recyclable blades in the end, we would not have ended up in a not recyclable part of the business. Because that's the issue now. the new resin systems, which are recyclable resins, yeah, it's much easier to recycle a blade.
Yeah, we are where we are now. We have to make best out of it. And we also have to push regulatory to have law that we have to recycle. And we have to have eco-designs for the whole turbine. And this is my wish.
May I comment?
-5.
Can I comment? Yeah, okay, very quick. Yes, so from Đức Trung Dao from Hoisim, so first worldwide cement producers. So for the co-processing, technically it's possible because to produce a clinker, we go to 1,450 degrees Celsius, so we can melt the glass fiber without any problem. Economically, it's not because it's so expensive. The cost is high. We release the CO2 to the atmosphere, and every kilogram of CO2 we have to pay, or we have to pay. So other side of on the problem of VOC cost, I think that co-processing will not be viable in the future. So it's really from our strategy in the future. So we want to work on the reuse or recycling. And the problem is, again, it's very expensive on the pre-processing, the shredding process, everything like this. And our main conclusion through the European project that we will present tomorrow with my colleague, like a circular economy can exist, but it has to be supported by the economic support, because we refuse today to recycle 1 ton of a blade with 50 euro, meaning that we need to increase maybe 3 or 4 times the price if we want to stay in the circular economy system. And this is a problem today. If we don't have any support in terms of price, in terms of gate fee, we cannot process the circularity for the end of life wind turbine blade waste.
Thank you so much.
Bettina, thank you very much. Unfortunately, Pascal Gallo is unable to join us now, but Jochen Karthauser will come forward now to discuss about the conversion of used wind turbine blades for construction materials.
Thank you very much for the introduction. And we had the second conference in October 24. It's great to see a couple of familiar faces. Today I would like to update you on progress at Wingbeam regarding noise barriers, sleepers, and other products. Then I will go into value chain considerations and topics which are of general interest to all of us. So, right. Our general purpose, like many of you, is to solve the issue of used wind turbine blades. We have a vision where basically all this so-called waste can be converted into valuable products with lower carbon footprint in cooperation with the whole ecosystem of the industry. Bettina was talking about it. Cooperation is needed, and that will also be one of my conclusions. So compared to 2024, we have changed the organization a little bit. We started in 2021 as a purely Norwegian company. We're hosted at a former sawmill where we can accept blades. We have a workshop. We have sister companies working in epoxy, plastics, thermoplastics, recycling, and the like. That is Norway. We started a Swedish entity, and that's a holding company now owning the Norwegian company, which still is the most important company. That's where all the people are. But why Sweden? Well, we have lots of aging wind parks. In Sweden, it is expected that some 10,000 tons of blades will be available annually in a reasonably short time frame, 1 to 3 years. And that will be a constant flow of some 10,000 tons of blades. Then Sweden is an EU country, logistics is easier. There's a very intensive R&D community with which we cooperate. So there are a couple of good reasons to be in Sweden, and likely the first production plant will also be located in Sweden. So in this Norwegian facility, 100 kilometers south of Oslo, we have also the storage, but also a large workshop where we can produce prototypes and pre-series of products and the testing required for that. We have expanded our teams, and I apologize to all the ladies. We should have, the gender diversity is very low, but we have a diversity in terms of the gray shades in our haircuts. And it would take, but we have a great diversity also in experience from business running, energy, plastics, production industries, business consultancy, and so forth. So there's a lot of experience in this team, and it would take me a couple of hours to go through the CVs of these people. I just want to point out a few. Paul Francis Hansen is the key inventor, naval engineer, machine engineer, lots of 20 patents in the composite field. So he's really the intellectual engine. Then we have expanded the team with a few Norwegian industrialists, and I'm happy to say that Frode Vattum and Hans Christian Alveberg are with us today. So you will meet them in the breaks. Frode will be our future CEO. Hans Christian will be our CTO. He has a lot of experience, among others, from the offshore wind sector. So we're very glad that we strengthened that team. We have some seniors with a lot of epoxy and thermoplastics background. We will need this in our product development. Right. Of course, we don't work in isolation. We need a network. One example for that is we participate in a Swedish program which is directed, it's called a Partnership for Reuse of Wind Turbine Blades. That's sponsored by the Swedish research community. And in that consortium, you find academic partners, RISE, it's Research Institutes of Sweden, Gothenburg University, Chalmers, a couple of companies in the recycling field, but also utilities like Vattenfall and Skellefteå Kraft, and also the Swedish Wind Power Association. They, of course, work with the IEA 45, the task group for recycling of composites. A very important person here is Dr. André from Chalmers, highly knowledgeable composite guy, so we're very happy to work in this project. It's actually not only turbine blades, that's the most visible composite waste. Ships, pipes is, of course, almost 80% of the composite waste, and that needs to find homes as well. Now, where are we in technologies? We have incineration. Nobody is favoring this here. This is a transitional period, but it has been done. It's almost a standard today. In the recent conferences, Vestas and Stena Recycling were presenting solvolysis. Jewel Mine, McKean, some universities were presenting pyrolysis. And here we have a couple of examples on mechanical grinding, like Albert Blademate, I know is here today. The German Blattwerk design, they're using at least segments and make products out of it. And we are also part of that industry segment, sawing to segments and using the stuff in the construction industry. That's where we are. My apologies to those who are not on the list. I'll put you on the next year's list. To show a few examples of what is possible in the southern Swedish city Lund, a parking garage has been built with Vestas blade segments. It's Lloyd's Architects who did that. The blades are not load-bearing elements. They're just sort of decorating the facade, but they have some ventilation, some functionality is there. It's a very nice parking house covered with solar cells, so it has received a couple of architectural awards. And these projects sort of contribute to a feeling, well, you can do something with these elements in a structural manner. BladeMate, I think they will today or later present a noise barrier built from a complete blade. Also, the generator house has been converted into a sort of summer house or something where you see this project in cooperation with Vattenfall. The German Blattwerk Design sells a couple of articles like tables, sun chairs, lamps, and the like from cut-out segment. You can order that on the web. So that's just to show you some examples of what you can do in the mechanical field. Of course, Kescon will present the formation of panels later on, as it's also part of the mechanical recycling of composites. Now, our guiding principles are, in reusing the composites, we want to preserve the strength of the composites, so we produce long rods, basically, or long segments. We are aware of that we have to achieve the lowest cost possible in converting this to products, and then it's a requisite that you need a scalable and industrial process to do that. And the products have to have a very long lifetime, so 50, 100 years or so, like Albert said earlier. So therefore, we focus on beams and pillars for construction purposes, for house building, railway sleepers and noise barriers and similar articles. We covered those quite broadly with a number of patent applications which are now published and in the sort of European processing stage. So in the end, we want to cut blade like in 4-meter sections or 6-meter sections in order to get it transported, and there are of course very different types of materials. If you go into more detail, we believe that the toughest, the best parts are of course around the spare box and the shear webs. From those composites you can make extremely strong rods in different dimensions, say 4, 6, 8 meters long. The larger surfaces are very suitable to produce noise barriers. And then there are some areas like tips and tailing end and the like thinner composites, which probably ideally are granulated and then put into some mechanical products like panels, like Albert or Reinhard is producing, or Koyos Titan, where do you have Johannes over there, that are suitable products. Now, on the noise barrier side, we're happy to work, we have started a partnership with a Swedish company, Bra Bullerplank. Translated, that means good noise barrier, so Norman est Omen. On the left side, you see Mr. David Bodin. We showed that on a fair in Stockholm, and people were not aware that you can make noise barriers from wind turbine segments. It attracted a lot of attention from authorities, municipalities, and potential purchasers of these noise barriers. Then we used these panels in our workshop as whiteboards for creative sessions about how to produce that. Our first idea was that we would put segments vertically and put them together. Now on PowerPoint that works very nicely. You even got a patent for it, but in practice it's more difficult because the dimensions vary a lot. So it was, this is probably not the winning concept. Instead, we have this green model now where we put vertical segments of different dimensions on top of each other. And you can see these segments, there's no straight surface in wind blades. Everything is curved. So to accommodate the segments, we put them into U-shaped molds where the curvature can be accommodated. We glue that together, and such a segment is easily transportable on site and can quickly be fixed. So time at the construction site is the expensive part. So we hope this is the winning concept, and we hope to install the first noise barrier in the Stockholm area already this year. I'm moving on to the next project. Railway sleeper, you may find that that's the most boring product ever to develop, but it's of course a very important function to keep the rails on place and to distribute enormous loads dynamically safely onto the ground. Therefore, the specifications for these products are tough. Not only technically, fatigue and the like, but also environmentally, leakage of materials. And they have to be cost competitive, of course. What you see is the sort of skeleton of a sleeper. It's replacing steel reinforcement in any matrix, concrete, plastic, thermoset, what have you. And in cooperation with a sleeper producer, we have produced lots of different embodiments with different number of rods, different structures, different areas of the blade. The market for composite sleepers, already composite sleepers, is enormous. I'm not talking about concrete or wood sleepers, but here composite sleepers. It's exceeding $10 billion. So basically, the sleeper market alone could absorb the huge waste volumes which we do expect. Now, of course, we will not win this immediately. There's a whole lot of work to be done. With the customer, we're going into FEM modeling, trying to develop sleepers which meet specifications. So you see some modeling results on shear and tensile behavior. There are lots of embodiments and also lots of application areas, from trolleys to normal trains to high-speed trains and the like. So we will have to develop a range of different sleepers, but it will be a substantial market. So summarizing the composite sleepers and what is distinguishing us from the composition. The most important thing is, instead of granulate, we use this strong skeleton, which really reinforces the sleeper better than concrete. And compared to wooden creosote impregnated sleepers, we have, of course, no rotting. In terms to steel, like Albert also earlier said, no corrosion. And the really benefits, they relate to the technical side, the environmental side, and the project management side. We achieve a higher strength than conventional sleepers. We started an LCA analysis, and there you find that, of course, the composite parts have a zero carbon footprint. On the epoxy side, that is sort of driving the CO2 impact. So we are very interested in sort of renewable or epoxy types with a lower carbon footprint. There's work to be done. But this sleeper development could solve the issue for the wind industry. We work on further products. You could use this stuff in wood laminate, in beams for housing. You can build frames for solar parks and the like. And we employ 3 master students and gave them freedom to design new products and come up with new ideas. But as a business, we have to focus on noise barriers and sleepers at this time. I'm moving to the value chain from wind park to final products. This doesn't really exist at this time, so we have to build it up. What we hope for is a bit like what Bettina was talking about, that there is a constant flow of blades, a predictable flow of blades into our processing factories, whatever that is, ours or the colleagues here in the industry. It is, of course, heavily regulated. We need to have some certainty about the nature of the blades. Our factory falls also under investment regulations. We need to report back we have wind park owners operating under ESG Chapter 9 considerations. They need all the documentation back, what happened to the material, also what happened to the granulate if we give it to someone else to produce panels. This has to be documented. And the final customer will need to work on the approvals. He will have to have some benefit on CO2 savings. After all, we need to compete with virgin materials, and it has to be a fair competition at the end of the day. Going into detail, we call this the early cutting of the blade. We call that the blade circle phase. We hope that we find partners who can cut the blades into 4 to 12 meter segments. According to the needs, we will know beforehand 10% goes to noise barriers, 20% to sleepers, what have you. We will want the materials arriving at our factory in the right shapes and dimensions. The factory, you could say this is easy, we're just cutting segments. Of course, it's much more complicated. We need to sort out, we have a pre-inspection, a qualification, we have to sort out metals. We have the cutting operation, sawing operation with diamond saws at the heart of the factory, but then materials need to be sorted, dust needs to be collected, granulates are shredded, maybe put into sleepers as a filler material, maybe sent to other locations. A lot of quality control going on to document the final properties of our end products, and then it's going to the customer. So it's a quite a complicated process here. Now, our issues which relate to all of us, I think at the end of the day, in order to develop bankable business, there have to be some common ground rules. There has to be an established gate fee, and even if it's zero, what we all want is a sort of degree of certainty that you can build a business upon. Maybe a gate fee comparable to car tire fees or the deposit you pay for any plastic products at this time. We mentioned logistics, it's complicated. Cross-border logistics is even more complicated. We need ground rules for that. We want external verification for products. What is actually the CO2 saving in reusing materials? And ideally, we have information from the OEMs about the composition and the structure of the blade, because this type of material passport would make our work and documentation work for customers much easier. Sorry, I'll flip this way. What we have to do company internally is almost easier. This is quality control, product specifications. That's what we are used to do in our careers. Maybe the most difficult part is, and we had the question I think earlier, how do we design our products so they can be treated in a circular manner in 50 or 60 years? That is definitely a challenge. I think I talked about this. We have some key trends. EU, Green Deal, expansion of rail, a lot of business going on there, demands regarding circularity, chemical legislations. And I think with our products we answer that quite correctly. There is a considerably better LCA analysis for products made from used wind turbine blades. It's local, it's long life maintenance. And to conclude my talk, I hope I could show you that we started an industrial scalable method to convert this waste into valuable products. We need to cooperate in our industry, from wind park owners or OEMs to product users. No single company can accomplish the whole thing. We said we need some sort of predictability, otherwise business cannot be bankable. And we need, at this stage, stimulation, support, government support to build up the infrastructure to do it. We think long term we can live with zero gate fee, just the ground rules are clear, and customers get some premium for ordering products. We know that. In Norway, for instance, in some other countries, there's already a demand that public purchasing needs to reflect CO2 footprint with a certain percentage in their purchasing decision, and that's the right way to go. To conclude, we, like many companies, we are in an expansion mode. We are in a financing round. So if you have any spare money, just leave it to Frode or me. We're happy to work on a license basis. We're happy to cooperate with any of you. International partners are very welcome. So you see our contact details, and thank you for your attention.
Let me, I have one question. There's quite some structural components that you basically develop. How do you deal with the structural properties of the materials you basically get in? And I think, as Eric already has shown, there's a lot of quality variation in the production of blades, and even in the designs there's a 35% knockdown for manufacturing efficiency. How do you deal with those numbers? Because the OEMs don't open up. They will not give you the structural properties of it.
Thank you for that. It's a very good question. I think the short answer is the composites are way over what you actually need for a noise barrier or a sleeper. So we have that. We have an enormous safety margin in that. But I did have a little box in the picture, in the flow diagram in our factory called quality control. So I think at the end of the day we need to sort of do a certain characterization of the flexural modulus or some mechanical properties that needs to be documented. It needs to be on the rods before it's sent to any customer. The customers will demand it. They are demanding it already. So, but the short answer is the products are way better than they need to be.
Thank you.
Mm-hmm. Very good question.
Yeah, over here. Hi, Matthew from Rewind. First of all, amazing to see how far you guys have come. I met Paul maybe 3 years ago wandering around Hamburg with a piece of something he'd made himself in his garage saying this is going to be amazing. So I think kudos to you guys building it up so far. But the question I have is following on around documentation. One of the big questions we get from our customers is around proof of, you mentioned LCAs, mentioned kind of recovery rates of materials as well. Like, how have you generated that kind of documentation? Has it been certified? Is there third parties? And how important do you see that in terms of being able to scale these solutions?
I think the industry is evolving. You know, we're way off from having documented everything. We started with LCA analyses, but we think we get a lot of support from the Swedish and Norwegian research community. They, of course, have funding for that type of things. But it is evolving. You know, starting a business, if you knew what sort of difficulties you will encounter, you would never start a business. This is why we're only men. Women are too smart to do this type of. But no, there's lots of work ahead.
And maybe just to follow on, do you have kind of a rough estimate so far as to what percentage of those blade sections that you can actually recover through your process?
It has been said earlier that some parts are sort of easier to use, like the root is really a tough one. Well, you know, I'm not the guy standing with a diamond saw. This is Paul Francis and Patrick, whom you've seen on the picture earlier. It's really tough to cut through the root. I think at the end, this is sleeper material. We could talk endlessly about fractions containing PET foam, PVC foam, even in older blades, balsa, carbon fibers. So there will be some some nasties which we have to take care of and document. On PowerPoint, it's relatively easy to say we use that for noise barriers and that for sleepers. I think I don't have all the answers.
No, that's perfect.
One more question there from Angie.
Hi, Angie Nagel from Bladebridge in Ireland. How important is the waste management aspect for the wind asset owners or for decommissioners who, I mean, you're talking about maybe going to a zero no gate fee. So I'm wondering about how important are the optics of the repurposing of the material or recycling of the material to the asset owners?
It's maybe a bit, you get a very mixed picture depending on whom you talk to. I think the owners of very large wind parks like RWE, Vattenfall, so the very big ones, they have at least thought about the issue. Then you find smaller players who sort of deferred the problem to the future and maybe to the next generation of managers. So you find everything on the scale from 0 to 100. Increasingly, I know in a different business, I work with a bank, and they have wind parks under Chapter 9 commitments, so they have thought the whole thing through. So recycling is guaranteed in 20 years. So that's the sort of best to have in the industry. But you have the whole spectrum.
Joachim, thank you very much indeed. There's tremendous progress there, and it's
thank you.
Just incredible what you're doing. Thank you. Gianmarco is very well known. He works in Wind Europe, a very significant player there. An advisor is an understatement for what he does here. So Gianmarco is going to talk to us today about the 2026 landfill ban. It used to be the 2025 landfill ban, didn't it? But he's pushing this hard. And the Circular Economy Act, advancing sustainability and circularity for wind energy.
Thank you, and good morning, everyone. Great words, I mean, very, very kind words. Yes, I will already pick from your comment on the 2026, 2025. Let's say that we said in our commitment, now we'll elaborate going on with the presentation, we talked about a commitment as of, let's say, the end of 2025, so now it's 2026, so I just, we earned a couple of, I don't know, a month or something anyway. I will, first of all, again, I am sustainability advisor at Wind Europe. You probably know what we do. We are based in Brussels, and we are the Wind Energy Association, representing now over 600 members across basically the whole value chain. Plus, of course, the national associations, so let's say our peers in the different member states. Before I delve into all the topics that I would like to cover today, I will quickly give you a bit of an overview of where we are, how much wind we have installed currently today in Europe. So you can see the gigawatts installed per country at the moment. We see, of course, striking number there with the 71 gigawatts installed in Germany. And also the interesting number here is actually the share of electricity demand that we're covering. Of course, in Europe it's 20%, and then you can see also the differences per country. I think this is very good map to have a bit of an overview of where we stand in different areas of Europe. So here, I guess, again, I'm not saying anything new. We know where our older, here, especially we're talking about onshore fleet, because for offshore we do have very, let's say, limited experience and therefore limited numbers, so it's not really in this map. But you can see where the oldest turbines are. Obviously, they are located in the, let's say, the key countries where wind energy was actually born and developed. So we have Germany, we have Denmark. That's where, in fact, we will be witnessing decommissioning, the highest, let's say, rates of decommissioning in the coming years. Now, let's maybe frame where let's say the problem of circularity around wind is. It's actually framed around that 11%. So when we look at the materials of a wind turbine, we know that most of the materials are following well-established recycling practices. And that 11% is actually the big, let's say, elephant in the room that we often, we're having these conferences for that specific reason. And it's a tough beast to deal with, that 11%, but we're doing our best. And I mean, all the examples that we're hearing today are definitely great examples on how, let's say, the industry is progressing from pilot to something a bit more, let's say, established at the industrial level. So this is to sort of set the scene a little bit. And now, these are quite fresh numbers. This one, I will have a couple of charts. Sorry to bother you with this numbers. Then later we have some more exciting things. But here, these are the, let's say, the latest numbers that we have on the commission capacity forecasted in Europe from here to 2030. I mean, I guess this is, again, quite obvious. We will see a growth in the coming years of the commission capacity. For the moment, we're still talking about, I mean, looking at last year, I mean, yeah, 2 years ago, sorry, this is actually from a presentation of December. So the latest information that we had was actually the 2024, so 1.3 gigawatt of the commission capacity in Europe. But I think that to have a better understanding of the materials that will come to end of life, I mean, here we're talking about blade mass. This is really the latest information we have. It's basically, these numbers are coming from a collaboration between Wind Europe and DTU under the IEA Wind Task 45 that has also been mentioned before. This is basically the best we have at the moment in terms of what we see coming to end of life in the coming years. And again, here it's confirming the same, let's say, the same tendency of the decommission capacity, obviously. So we see a growth, and therefore this growth in terms of volume is also making this, let's say, called an issue of blade recycling more pressing. It's getting more and more relevant. So this is showing us that there is an urgency. I mean, let's say better being prepared as early as possible than finding ourselves with no solutions. I think this is also a very interesting chart. I mean, it's a bit old now. It's 2020, but this is just to give you a bit of a, let's say, broad numbers of what the problem of wind, I mean, and boating as well is if we look at the whole plastic waste. And here there are these two percentages that are quite interesting, because if we look at the whole plastic waste in Europe, we have 29,500, I would say, kilotons of plastic waste. And then if we look at, I mean, the numbers are talking for themselves, but we see that boating and wind waste is extremely small as compared to the broader composite waste and even more the plastic waste. The reason why I'm showing this is very, I would say, simple. We're very visible as a sector. Wind is visible from also from a political perspective. We all know it's very much now on top of the news at the moment, and of course the media as well. So it's a very visible volume, even if it's actually way smaller than the rest that we see out there. And this is a tendency we see also with other type of waste. You're all very familiar also with this hierarchy, but I'm using this to show you that what we don't want is let's say the tip of the triangle upside down, which is disposal. So you saw in the presentation that we talked about the landfill ban. This was a very bold commitment. Now we'll elaborate later on, but this is where we're heading to. This is what we need to do, and this is, as an industry, what we've signed for now almost 5 years ago. We said we need to find sustainable end-of-life solutions for our blades, and landfilling cannot be an option. Even if, as I heard before, landfilling per se is not even bad for the environment. Let's say, I mean, there's wars probably out there, but it is a waste of resources. It is I would say, reputational damage for the whole sector, which just doesn't look great. And I mean, it's wind, right? It's in the DNA to try and do the right thing. So we just cannot accept the last option, even if it's clearly the cheapest one and the most available in the market out there. Let's quickly look at what's happening in Europe at member state level when it comes to landfill bans. This is just showing you where we have landfill ban in place in Europe at the moment. But at the same time, and this is also, I think, a key element to keep in mind, there are exemptions, even from these type of landfill bans, which often make it in practice not really enforceable. So we know that in certain countries, when alternative treatment are costing more than a certain threshold, then landfilling is again allowed. So that means that in practice you have the ban, but then you still landfill. So do we like that? Well, we don't. So as I said before, you see that's the by 2025 that we kind of played with the 2026, Andrew, that was connected to your point. So what happened in 2021? So Wind Europe's board signed a position paper saying that the industry called for an EU-wide landfill ban of the commissioned wind turbine blades by, let's say, as of January 2026. And with this commitment, we commit to reuse, recycle, or recover 100% of the commissioned blades. Now, as I said before, this does sound like a very bold statement. It is not easy at the company level to have this type of policy because obviously, as I said, there is an economic element there that must be considered, plus the legal framework is not really in place. So it is a very ambitious target, but that's what we're working for. So this is the commitment. Then next to it, we needed to somehow be held accountable, right? We cannot really commit to something if we cannot bring evidence that we're doing the right thing, or at least we're trying to do the right thing. So the goal was, after signing this paper, especially within the working group sustainability, which I coordinate at Wind Europe, we had to put a system in place to monitor what is happening with our members that decided to accept the reporting initiative with us and therefore sending us each year the numbers of what they've been doing last year. The year before the reporting. So practically we asked two questions to our members. One is, how much did you decommission last year in terms of capacity? And what did you do with that blade waste? So did you landfill it or not landfill it? We need to keep this reporting very simple for obvious reasons, also to sort of not overburden companies with extra reporting elements. But although it's not now I'm going to show you some results that this is the first audience that sees these results, because up until now it was only within the working group sustainability. So as I said, we basically ask every year, so this year we'll be asking the numbers for last year, those two questions. Now, the following slide is giving you the results, actually comparing them with the numbers of 2023. Now, the reason why I'm saying this is the first time you're seeing this is because we actually do not have any real data today of where the blade waste is going and what's happening, what every company is doing with their blade waste. Basically, we don't know that. For one reason, later we'll elaborate even more in detail, but we don't have waste codes, so we cannot really track where these blades are going. There are no public information on this. It's mostly assumptions and predictions. This is real stuff. Like, these numbers are coming from the members that decided to report. This is not the whole of Wind Europe, and even I will give you a very specific information. If you look at these two numbers, you think this is amazing. I mean, we only have 11% left of blades being landfilled. Well, we need to look at how much we are covering in Europe with our initiative. And here is a bit let's say the more difficult part. So if we look at what happened last year, we decommissioned, when I say last year, I mean what's been reported last year, so with the numbers of the year before. So in 2024, we decommissioned 1.3 gigawatts in Europe. Of that amount, 12% was covered by our reporting initiative, which sounds like a very small number. So it's like, yeah, guys, you are so big, but then you're covering so little. Where there are a few answers to this question. So one is, most of the decommission capacity in Europe is coming from small wind farm owners at the moment. When I say small, I mean the ones that are not really part of Wind Europe's network. So really in countries like Denmark, in Germany, where we see that really there may be 2-3 people that have maybe a few wind turbines in their backyard to power whatever maybe small factory they have. And they're not really aware of sustainable end-of-life solutions, or maybe if they are, as we all said before, and literally last week I had a call with the commissioning company, and very clearly they told me, look, price is what really matters, and no one wants to spend that much money, so the small wind farm owners obviously will be looking for the cheaper option, which is landfilling. So that's one of the reasons. Another reason is that our members are not decommissioning yet that much, because we'll be sort of covering more of that decommission capacity in the coming years. Once, of course, the Vattenfall, the Ørsted will be decommissioning more, then obviously we're also going to cover more of that capacity. But again, this, I think, these two pie charts are giving you really good, a really good understanding of the progress that we've been doing at Wind Europe with our members, which, I mean, most of the companies that I heard here are actually part of the initiative. And this is great progress, because as you can see here, we know there are companies, only for 11% are still doing some landfilling. And obviously, as I said before, this is an ultimate goal to try and reach zero. But without the proper legal framework, this is not going to be easy to do, probably going to be impossible in the long run. So we actually need a harmonized legal framework at the European level to actually have that zero that we're really looking for. But again, good progress, and the companies that are participating in this reporting initiative are growing year by year. So now we are at 25 companies, I think. So, you know, looking in the future, I see hopefully more and more positive numbers. Now, yeah, there is an S that was not supposed to be there. So, circularity campaign. So why am I talking about this now? Again, we talked about the landfill ban, very important commitment, but we needed something else. Our members told us, and I mean, this is also what we understood from policymakers, there is very little understanding on the success stories that we already have in Europe when it comes to recycling, repurposing, reusing. Second-hand market is actually thriving at the moment. So there are a lot of good things happening out there, very little knowledge, and lots of mis and disinformation, really like a lot. That we're trying to fight in Brussels very much. Now, this circularity campaign was, the idea was, apart from this landfill ban commitment that we talk about, we need to go to the factories. We need to go visit these places and showcase that things are possible. So we created a landing page on our website, which I really, really recommend you take a look at, because it's kind of, let's say, I mean, as you can see, there are tabs that reuse, repurpose, recycle, recovery. So if you click on each of those tabs, you will find either me going somewhere. I mean, yeah, there you go. That's me on the left-hand side visiting. Actually, this is Business in Wind facility here in the Netherlands. It was just newly opened, so I went there to see a bit how things are being done. And these are other videos or media content that our members sent us last year. So now this is already a pretty busy web page, but again, we're very happy to include also non-members of Wind Europe here. The idea was very simple. We need to create a web page that we can send around to policymakers, just a very simple link to first rebut these misinformation claims coming from just people that probably don't like wind very much. And again, bring those real life stories, because I did hear people saying, hey, you don't really have these factories, you know, shredding, blade recycling is not really a thing. I was like, no, we go to these places, we do visit these facilities, so they do exist. And this really helped, because then later on, we actually got in touch with the policymakers at the European Commission mostly, and they reached out to us actually, asking more information about this. And this is a nice infographics that we have created. I mean, you probably are all familiar with what's happening here, but this was our way to make it very simple and very digestible, all the topics around blade circularity. This has also been circulating with policymakers, and the idea is there are different R's, all of them at different level of the technology readiness. They're all important, and they all are complementary for the ultimate goal, which in the first place is not reaching disposal, so landfilling. That's why we don't have a road getting there. Also, this is part of our, of course, our webpage on circularity. Now, what do we do in Brussels? I mean, we are policy people. I have a degree in law and in European law, and that's basically what I do. I try to talk to policymakers to see whether, I mean, to try and bring the interest of the industry when it comes to sustainability, mostly waste management in this specific case, to the attention of policymakers in order to have at least, let's say, not disproportionate requirements, that's the very least, or even better would be to have a legislation that really is going to help the sustainability of our sector. So, what's happening this year? In Q3, the proposal for the Circular Economy Act will be presented to the Parliament, the European Parliament. The Circular Economy Act will be a very big piece of legislation. They call it sort of omnibus. It's going to amend different policy files, which are all very relevant to us. We've been talking a lot in the years about, again, waste codes, landfill ban, and all these kind of things, and this is the moment to work on it. First policy file to be amended will be landfill directive. Second one, European list of waste. Waste shipper regulation and the WE directive. This is not really, I mean, the WE part is not really sort of pertinent for today's conversation because that's more for the electronic part, so the permanent magnets, but that's maybe for another conference. While the other policy files are all sort of covering all the things that I mentioned before. So the goal here would be to, in the landfill directive, to finally have a landfill ban in the EU law. So something that says we need to ban the landfilling of that type of waste. But which waste is it? Well, probably the European list of waste is going to tell us which waste it is. So we need a code for that. We need dedicated waste code for composite material waste. And the same, I heard before, I think from the speaker before, about logistics and I think also transportation. I mean, transportation is really key. We don't know exactly how many blade recycling facilities are around Europe, but we definitely need to map them and allow member states companies to move these blades around without being stopped at custom controls because they cannot really tell which waste it is. And so we need to green list that. We need to green list this type of waste. And this is not just coming from wind, but this is coming, you can see some, the logos up there. These are our colleagues from different trade associations of, let's say, the composite users value chain. So on top of the work that we do as Wind Europe, we also cooperate with, with trade associations that are working with us. So we sent basically 2 different position papers to the Commission to reinforce our messaging around the points that I've just mentioned. Because as I said before, this is definitely a cross-sectoral challenge. This is not just a wind challenge, or at least it can be also of other sectors. So maybe by pooling the waste coming also for different sectors, we can get those volumes that at the moment are a bit lacking for our recyclers. So this is, I think, an important point to mention. This is just, I took a screenshot of this. This is the letter that we sent to the Commission. It's an extra note on relisting composite material waste in the waste shipment regulation. It's basically to even reinforce even more in detail the importance of having a streamlined, let's say, path for our blades once they are decommissioned and they need to move around Europe for being treated in different ways. You can find all of these papers on our website, so or anyways, you can also reach out to me. This is a bit of a summary of what I've said before about the Circular Economy Act. But I think apart from all these points, I think what I wanted to stress here is this is a key moment from a policy perspective to act, to do something. Up until now, when I joined Wind Europe, now it's almost 3 years ago, we were talking about the ambition of having something like this, we were hoping to have a policy, a reform that would actually amend all the legislation that would be, good for wind. So we need to do something there, but there was not a window open. Now the window is open, and so we're really active. We're really active to try and get this point where we need, because I think without the policy support, we can only do this much, and this is not enough. So. Here we are today to showcase different, of course, solutions from a technological side of things, innovations, but policy is also key, and we do need to do the right thing, but the legislation must be supporting us. And with this, I conclude. If you have any questions.
There he is again. Gianmarco, absolutely very interesting. Actually, I have 2 questions. First of all is that the numbers you showed, I assume is based on the installed blades and what is then being...
The numbers, which ones? The blade waste?
The numbers you showed earlier on what is being landfilled. How do you deal with, because Europe is very creative in exporting waste outside Europe. Do you take that into consideration?
Let me maybe to respond to your question, maybe the answer was already here, sorry, but I think it was just next to there you go. Is it there? Okay, the ban should also apply, no, okay, it was not here, sorry. Basically, next to this commitment, there is also the part on exporting blade waste. We also don't want to do that. So that's this is just a shorter version of the commitment. So there is only the part on landfilling and the commitment to reuse, recover, or recycle 100% of the commissioned blades. There is an extra part of it, which is we also don't want to export our blade waste outside of European borders. And again, this is becoming not just a matter of, again, sort of credibility at political level, or reputation, etc., but today is also a matter of resources. We need to keep things here. It's even more than resources. I mean, the word that in Brussels they really love using is resilience, and this is also what's happening with the permanent magnets. The idea is we need to keep the waste here, because that waste is actually valuable resource, and it's going to help our energy security, independence, and staying away from critical dependencies that we have from other countries. So yeah, keeping the blade waste here would be the ideal scenario.
Perfect. Second question related to that is that in blade production, there's a lot of waste created in the processed materials, up to 15%. How do you deal with that?
Yeah, this is actually a good question, because we are now our initiative, reporting initiative at the moment, is not covering the production waste for a simple fact. The Blade Waste Reporting Initiative is mostly dedicated to developers for obvious reasons. They are the ones with the sort of dealing with the end-of-life responsibilities. Our OEMs are reporting only for the, let's say, the guarantee period when they sell the blades and the turbines, and then they, for a certain amount of time, they are the ones dealing also with the, in case there is a malfunction or something, so that they are reporting. What they are not reporting yet, but again, this is an exercise that we started doing. It is very complex from a data perspective, because companies are very protective of their numbers and their information. So at the moment, this is what we're able to do. The idea is to also cover production waste. So that's the next level. And again, also maybe another point that I haven't mentioned here. Our campaign that I talked about before is not just to showcase it to policymakers how the good solutions that are out there, but the idea was the louder we are, the more people, possibly the general public, will be aware of this, and also those small wind farm owners that I was telling before. And ideally, that is also to include them in the initiative. So the long-term goal would be to not only have Wind Europe members, but a broader group of owners. So again, those numbers are really not that representative today, but it shows that we're really doing an effort.
Good. Thank you.
Yeah. Hi, Gianmarco, over here.
Sorry, I do not find...
Over here. Super interesting presentation, as per usual. I have a question around your forecasting for decommissioning volumes, and I've been seeing these numbers probably on an annual basis at Aeolus every year for the last 3 or 4 years. And every year it seems that what actually is decommissioned turns out to be, no, one further back, yeah. Since I've been going to Aeolus in 2021, we've been predicting this exponential takeoff in the amount of decommissioning, but we see more and more life extension happening, less decommissioning happening. I'm wondering if you expect that trend to continue, or how confident you are that 2025 really was the year that decommissioning took off. And yeah.
Well, no, that's really a very good question, and I think this is also the reason why we failed our predictions quite often, because the reality is a bit different. I mean, we all know there are different reasons. I mean, energy crisis, we just keep those turbines running as much as possible, so longer than expected. Then there is an element of the actual composition of the turbines is showing that the blades are lasting way longer than expected. We have lifetime extension, we have a second-hand market that, so we decommission somewhere else, but we recommission those turbines in other geographical locations. So there is definitely going to be a growth, but it's a very unpredictable growth in terms of volumes. So we'll see. This is the best that we could do in terms of numbers, but again, it might be the case the next year. If I come here again to this conference, I will probably be bringing something a bit different.
Yeah, and then on top of that, is there any kind of key policy drivers in those key markets like Germany, Spain, for example, that you think is going to contribute to more or less decommissioning volume?
Well, I think there are a couple of. I think one that I can think about, like one policy element that definitely will change this is. So the permits for lifetime extension, certain countries are very diligent, so they do deliver very well. I mean, Germany is normally the one, mostly on the permitting side of things, but in general, when it comes to sort of administrative processes, well, Germany is really like the front runner. So that's maybe a country that would be affected by, depending on the type of policy, also the statistics will change. But that's the one that I can think of, and that's it for the moment.
Yeah, thanks.
Yes, thanks for the presentation, Gianmarco. Jos from BladeMate here. I've got two questions. Looking at the inverted pyramid that you've shown, and I'm very happy with the landfill ban sort of coming in. When do you expect that we will take the next step? Because that will not be sufficient for 2050 to scratch the second part of the pyramid.
So recovery?
Yeah.
Which we all agree we consider SIM and co-processing as part of that, right? Yeah. So that's definitely a good point. I mean, I don't know if I have an answer. What I can tell you is, again, as representative of a business association, I can tell you what our members, what the feeling within Wind Europe is, which is we do support SIM and co-processing as the solution that, let's say, will pave the way for more sustainable solutions. But yes, the flavor is that our members are more and more saying we might want to look at even more sustainable solutions than that, because of course there is also, again, reputational element. Maybe it's not seen as a great option. Although we do support it, we do. It's just that I think we want to do the next step, really. As Wind Europe, at least, we're trying to do even the extra step in trying to say, okay, yeah, this is what we can do at the moment, because at technology level is the most ready one. But are we sure this is what we want to show to the public? Well, probably not. So we'll look for something even more sustainable. Although today it's still the most, let's say, used technology of all of this. So this is maybe in the future, very far future, this is also going to be cancelled from the pyramid.
Okay, yeah, thanks. And well, that's of course also shown in the circularity initiative with the 4 steps of reuse and repurposing. And I think, especially for those two, it's important that there's also a chance that material will not become waste or not labeled as waste. Is that also included in the directive, so that materials come down as spare parts that are able to be reused in wind turbines or repurposed before it actually becomes waste?
Yeah, there are this type of conversations. It is a lot around, let's say, semantics, and that's why we talk to the Commission quite often, because this is actually a very key point. I mean, also when it comes to, I mean, I can give you so many examples of thinking of a type of legislation that maybe applies to, I don't know, OEMs, and actually it's not OEMs, but it's I don't know, the generator manufacturer. So this is a completely out of context example, but just to say that yes, that is something that we're looking into and trying to understand whether there will be changes also in this, because of course labeling requirements will change, waste codes, end of waste criteria will change, so what is actually being considered waste or not. So these are all things that are in discussion at the Commission. I will let you know. We have a meeting very soon with DG Environment.
Okay, great, thanks.
Yes, thank you for the great presentation. I have just maybe a comment that we can discuss later, and then a question. So the comment is, I appreciate the work you do with the policymakers, and I want to give an example that we can discuss later, because I was in the battery industry before, and the battery industry had something called the battery directive and the battery passport. And that was one of the front runners how to really document the whole value chain. And if you get something similar here, this might be a very good way to copy something to get fast forward into information and transparency. So happy to share a bit of experience with that. My question to you is that you had the positive news that only 11% was going to landfill in 2024. That means that 89% was not going to landfill. And I think you mentioned you had 2 questions. And the second question was like, what do you do with elements not going to landfill?
Yes.
Can you please talk a bit about what you found out?
So, very good point. So what we have there is actually, when I said 2 questions, there are also other 3 sub-questions that are on a voluntary basis. So some members responded, some members did not respond. So what did they, so the part where we don't have complete data is when you don't landfill, what do you do? I do have a chart. I did not show it here. I was not allowed because they told me that Wind Europe is not fully representative, so don't show that. But I can tell you that we do have those numbers, and that's really, really, really gold, because for those ones that have reported, we know exactly how much tons they have sent to which type of strategy. Recovery is definitely, I think, the first one, so cement co-processing. We have a lot of stockpiling, so they actually just keep those blades there until they figure out what to do. We do have recycling. Reuse is really, I mean, I'm not sure if this number has been already said before, but in countries like Germany and Denmark, we have more than 50% of the commissioned turbines actually go to second-hand markets. So there is that too, to be considered. But again, we don't have, let's say, final numbers, so I did not really show that. But we do have an understanding a little bit of what's happening when it's not landfilled.
Yeah, Reinhard again. I do have a question, because I am personally, and I think through research, totally opposed to accepting that cement co-processing is a good way of recycling, because it's not. Now, let me just give you a handsome example. You go with a end-of-life wind turbine blade to your local waste-to-energy incinerator, which you have in every big city. Guess what happens? And I've tried this not once. They say, go away. What you're doing, if we process this, we're creating toxic waste, air pollutants, and so forth. The only excuse we have why cement processing, co-processing is allowed is because that industry has found a loophole, and they're exempt from measuring air hazardous pollutants. So your local waste to energy, they're complying. Although they have RTOs, regenerative, thermal oxidizers, they cannot cope with that material. The cement boys, as I call them, they found the loophole, and that's why it's accepted. So it is a total scam, as far as I'm concerned. 100% scam. It's just an easy way out.
Definitely message received. I do not work for Cement Europe, but I will report this information to the colleagues in Brussels.
Please do.
There is a, look, I'm also I'm not an engineer, I'm not really a material expert or anything, but I did follow our, so we did commission a study, with those other Composite Users Association, an LCA on cement co-processing a couple of years ago that we also presented at the European Commission. Basically, the whole point there, I mean, there are numbers. We save up to 1 ton of CO2 per 1 ton processed there. I mean, besides that, the point there is we don't need to use fossil fuels to burn, right? That's what they're saying. So it's an alternative fuel that has to be burned anyhow, and at least you sort of recycle the mineral part, how they say. Now, this has been something that we've been sort of supporting up until now, because this was part of a narrative and a cooperation between two types of industries. But I do understand where your comments are coming from. As coming from wind, again, I don't really have much to say on this, but I do see that this is what you just said now is coming a bit more and more. I hear these comments a bit more also within our membership, maybe not necessarily heavy criticism, but definitely some concerns. Are we sure that this is something that we can still support? So I would say message taken, and then that's extra food for conversation with the working group as well.
Yeah. Just a final comment. They cannot use just the wind turbine blade waste. They have to put in additional fillers in order to increase the calorific value.
Yeah.
Otherwise, as we all know, glass doesn't burn. So, like I said, there's a lot of work that needs to be done, and recognition.
I think this is a very good point, and I mean, I really like to come to this type of conferences to have, I mean, what I call reality check. I mean, reality check in the sense of people coming to me and saying, hey, I don't know what you guys are doing advocacy about this, because this is actually not working, or this is working. So whatever comment when it comes to practical reality of things, it's really very welcome, because it gives me also a broader picture of what's actually happening in Europe. So thank you very much for that. Thank you.
Gianmarco, thank you very much. That's been quite an interesting... It's always a pleasure to have you here. We'll break for lunch now, and I think, Teresa, you want us back a little earlier, don't you, yes?
Yes, so if we can be back at 13:55, because we will have also Pascal presentation in the afternoon. So if we can be back exactly in 1 hour 13:55, please.
Okay.
Thank you. And lunch is downstairs. And please know that the QR code for the photo was the wrong one. So we will distribute new QR codes on your table to download the photos. Okay? Thank you and bon appetit.
Good afternoon, everybody. You're not allowed to sleep after that very good lunch. Therese, you made a very good menu selection there, and thank you very much. I didn't eat the sweets because I don't, but they look delicious. Pascal is joining us now. Pascal Gallo is a co-founder and executive chairman of Composite Recycling SA in Switzerland. He's very specialized. I'll explain what he does. And he's achieving circularity for wind blades by composite recycling.
Thank you, Andrew. Thank you. Indeed, we're recycling composites. We're part of the value chain. And in a nutshell, what we're trying to do here is to go back to commodities. So transform the components of the composites into fibers that can be reused, right? And we go a bit further than the thermolysis oil, which is extracted from plastic part by performing distillation and trying to extract the molecules, useful molecules actually, through our collaborations. What I can say is that through the various applications, this is quite well known, but composites are here to stay because they helped last year to save about 1 billion tons of CO2 out of 30 billion tons, you know. So they're definitely here to stay, but they're not recyclable, obviously. So need to find a solution because there's a temptation to go back to metals. We have examples in the automotive industry where people would like to go back to metal, basically, because composites are not recyclable, and it's dramatic. And of course, you have those nasty pictures, right, of wild deposits of wind blades. This was in Texas, and they don't even bother actually landfilling the blades, and this harms the industry as a whole. So if you take a look at the technologies available now, you have several branches, and we will focus on thermal recycling, and in particular, actually, low temperature pyrolysis, a technique that we call thermolysis. I will go deeper into that, but when we started the project, we were pretty agnostic about the solution. Mechanical recycling, solvolysis, and thermal recycling. The reason why we chose thermal recycling was, first, it's pretty straightforward. And second, if you compare to solvolysis on the one hand, you don't need to handle the solvents, right? And compared to mechanical recycling, well, this is linked to what I said earlier. We want to go back to commodities. And through mechanical recycling, we think that you restrain the applications. Though actually, it's a very good technique as well. So we think that there is no silver bullet actually. So it's a combination of technologies that will manage to tackle the issue. Let's take a look at the results that we're getting. So the first step is, as I said, actually a low temperature pyrolysis. We perform that below 500 degrees Celsius. It depends very much on the matrix, the plastic part that we're addressing, right? And you get this vaporization, the plastic, you recover the oil. And you see on the picture here that there is still a carbon residue on the surface of the fibers. And if you do microscopy, so these are SEM images on the right-hand side of the optical pictures. You get residues that you need to remove. And this is done in a subsequent step called calcination involving oxygen. And what you get is pretty clean fibers. This can be applied to carbon fibers. Of course, it's more graphical, you know, in the example of glass fibers. But with these fibers, you can do many things. I will go to the details later. So the first thing you can do with the fibers is you can combine them with new fibers. So by mixing the recovered fibers with new fibers, you can recover the mechanical properties of mat. Okay. Second thing you can do is you can put back the sizing, the surface treatment on the fibers. And with that, this is the example that we're giving here. You're reaching very close to the initial flexural strength of the virgin material. And the other way, and this is an initiative done by Owens Corning, you can remelt the fibers, and there you go back really to the original properties of the fibers, and you can have woven material, because here actually you can only do mat, which is not woven. Now, when you come to the other component, so the plastic part, it becomes an oil, and we have several use cases. I'm presenting here polyester. When you do the thermolysis of polyester-based composites, you get this mixture. And you can see here that you get quite a lot of styrene, which is interesting because this is a commodity, actually. And you can sell it to manufacture, for example, a new polyester resin. But the yield is pretty low. And it's going to be the same thing for epoxies, where there actually you recover phenols. It's even more complex because you get a variety of phenols. So we have another use case. It's a collaboration we have with Arkema. And Arkema developed well-known now ilium resin made of polymethyl methacrylate as a base. And when you do the thermolysis of the ilium resin, so first of all, it's done at a lower temperature, so you save energy. In turn, since you operate at lower temperature, you retain the mechanical properties of the fibers. And finally, you see the yield, which is much higher, actually. The concentration we can get is up to 85% here. So the yield is much better than polyester or epoxy. It's a very good use case, actually. Now, in terms of impact, so of course we produce CO2. And there are 4 steps during which we produce CO2. So first of all, actually, the energy, whether propane, which is the case for the current version of our technology. You need to burn propane to heat up the reactor. Then you have the pyrolysis gas that contains CO2, the calcination to clean the fibers with oxygen, and burning the non-condensable gases, okay? I think this is kind of worst case scenario. We're working on an upgrade of the technology, and I'll go deeper into that later. But if you sum up the contribution for 1 kilogram of composite treated, we're below 1 kilogram of CO2 produced, you see. Already there, actually. Now, switching the energy input from propane to electricity, depending on the country, actually, but in France, for instance, the electricity is a very low carbon emission, so you'd reduce to 100 gram the energy input. The pyrolysis gas, unfortunately, you cannot do much. Depends on the matrix. But we estimate that we can go below even 500 grams per kilogram of composite treated, you see. And in contrast, sorry, my slide was not updated, but in contrast, actually, for polyester, it takes about 2 kilograms per polyester produced. In epoxy, it's going to be slightly more than that, 3 kilograms. Glass fibers, on average, 2 kilograms. And carbon fibers, well known, actually, it's about 30 kilograms. So So indeed, actually, we save a lot. Now, of course, we need to consider the rest of the value chain. I'm just focusing on our technology, our tiny part of the value chain, but still, actually, we save a lot, actually. So I haven't presented the machine in which we are treating the composites. This is our containerized system. So it fits into a 30-foot container. And what you can see here is a rack system that is about to be slid in an oven, let's say. So when you close the door, you flush with nitrogen to remove the oxygen. Otherwise, of course, the plastic would burn. And when you heat up without oxygen, the plastic vaporizes. You see, so you depolymerize the plastic. Without opening the door, when the thermolysis is over, you just introduce oxygen in the chamber, and then you remove the residues on the surface of the fibers. So this is beyond the 3D picture. Actually, made a machine, and this is the rack system. It's 3 meters long. It's 2 meters deep, so you can fit sizable parts. Of course, way smaller than wind blades, so we need to pre-process the blades. I'll come to that, but still, we're operating now at a few tons per week scale, and we're working right now on an industrial scale version capable of treating 4,000 tons per year. This is the result that we're getting. On the left-hand side used to be composite made of 30% polyester, 70% glass fibers, and you see that you keep the woven structure, which is quite nice, and there, since it was made of multiple layers of glass fibers, we just, opened up the assembly like this, and to show that even in the middle of the composite, the glass fibers are very clean. On the right-hand side, I have a carbon fiber composite. It used to be a hydrogen tank. And this is to illustrate the fact that we can treat large pieces. So beneath you have the size of 2 meters. The tank is 2 meters long, you see. And especially the thickness. Thickness is 40 millimeters. So of course it takes a longer time to process that kind of material, but you can still do it. And the same principle, actually, we removed half of the composite, you see, to reveal the structure of the composite material. And you see that in that case, epoxy is gone, actually. Yeah, our technology is patented. Now, I would like to go a bit deeper in the business model. So here you have 2 circles. So first of all, actually, these samples were produced by the group Beneteau, which is a boat manufacturer. But the same thing could apply to the wind blade industry, for sure. So the waste is collected by a partner, Veolia. It's a waste management company. And they will take care of the pre-processing and the logistics. We treat the waste, and of course you have 2 branches. So on the left-hand side you have the fibers, okay? The fibers here are remelted by Owens Corning, and they go potentially to, of course, many customers of theirs, but a typical partner for us is Shomara, with weaving the fibers, okay? And the textile goes back to Groupe Beneteau. On the right-hand side, when the composite contains helium, so we produce the oil that is then taken by Arkema, and Arkema is processing the oil to purify it. Then manufactures helium that is then sent to Beneteau, and Beneteau remanufactures composite, right? So you have those two circles. And now, in terms of revenues, there is indeed actually the waste collection fee or treatment fee that is taken through Veolia. And we sell the fibers to Owens Corning, for instance, and we sell the oil to Arkema. So these are our revenue streams. In the case of carbon fibers, it's the value of the carbon fibers is so much that we're willing to accept the waste at no cost. In terms of market size, I think I would encourage actually other companies to go into that business because it's a massive business. And if you consider the composite waste, of course, we all know that the volumes are huge. And if you combine the waste market, the fibers market, and the oil market, combined, we estimate that the market size is 30 billion by 2032, actually. So it's a good business. Takes some effort, actually, but it's worth going because sometimes we feel a bit alone, actually. Now, going, let's say, into the future, 2032 projects capacity, a treatment capacity of 100,000 tons and revenues of 70 million. And with the waste management, waste fees, actually 92 million. And here is the distribution of the revenues. So it's pretty balanced, you see. Now, coming to open questions for the future developments, we have some issues that we'd like to tackle, and we're open to collaborations. So the first issue that we have is to deal with the halogens. This is an issue for us, typically in those thermal-based technologies. When you do the thermolysis of halogen-based composites, you create acids, you see, so hydrochloric acids and so forth, and HF, HBr. So this is an issue. The way we're dealing with that currently is by introducing carbonates now. So we managed to remove 99% in mass of the halogens. So it's good, but we're still in the 100 ppm range in the oils, which is an issue for us. And we know that especially old blades do contain halogens in the foams, you know, so. And of course, one way to do that, to address this issue is to shred and then separate before doing the thermal treatment. So that's one way to address it. But open question, so if you feel like collaborating with us on the topic, we're open to that. The second topic is to reduce further our CO2 emissions by capturing CO2. Here again, actually, we're open to collaborations. Yeah, so feel free to reach out. Here's our team. We have a very strong advisory committee, and we're a small team, let's say, for now, but through collaborations, we're a total of 10 to 12 people. And we're based in Switzerland, and we're currently manufacturing our industrial facility in the northwest of France. And this is it. So thank you very much for your attention. Yeah, so if you have any questions, thank you.
I have one question, very interesting. What is your view on traditional, let's say in the plastics industry, there's a big gap between recycled materials and virgin materials, cost-wise. What is your opinion on that if you look at your processes?
It's a very good question. I was attending a conference a month ago on the plastic recycling business, actually in Barcelona. And it was really dramatic. Everybody was depressed because of the oil prices, you know, and it's highly depending on the oil pricing. The luck that we have is we have the fibers. So this saves the business model somehow, because the fibers are priced higher than the oil. And so that's and then, especially if you somehow manage to get a decent balance between carbon fibers, priced about 5,000 euros per ton, right? And glass fibers less than 1,000 euros per ton, right? So that's one thing. And then, this is why I didn't dwell on that, but Arkema's an initiative with Ilium is really a game changer, because the MMA pricing is about 2,000 euros per ton, you know, market price. And somehow it goes down to the value of the molecules that you sell. In the plastic industry, the issue is that they don't have another material to rely on, and that's the issue. And I totally agree that, I mean, they all go bankrupt. Those companies are doing recycling of plastics, which is terrible, and they should receive way more support than that. It's political support, and yeah.
Thank you very much for your presentation. I had a question concerning, you had your example with your current client, Beneteau ships, beautiful client, I would say. And you said, well, I'd imagine that you can use it for blades. Does this mean that your fibers are long enough to make blades with it? Because you're not shredding, that I saw.
Yeah. So that, you know, as a startup, we had several pivots, right? So we started with an idea, and then we realized that probably we should switch. And the initial idea was to preserve the length of the fibers. Truth is, for carbon fibers, we shot them. We have a customer taking our fibers, 20 millimeter long fibers, mixing them with thermoplastic and to make car parts. You know, so it's not necessary. And for glass fibers, we think that, one of the best initiatives is done by Owens Corning. And there, you don't need very long fibers. And going through Owens Corning with this Sustena fibers. So what they do is, I don't know if, Alessandro, you have a presentation then, or you can.
So Alessandro, working indeed for Owens Corning. So we remelt glass fiber waste, meaning that we recover the glass properties at the initial level. So it's like chemical recycling applied to glass fiber. Okay, so basically what we can provide after is a fiberglass 100% circular with the same properties of the virgin one. So it's a drop-in solution. We use ISCC+, so it's mass balance allocation. And this is basically how we can recover the fiberglass, providing a glass with same properties. And we do that, I mean, if I can share a bit more. Of course. We develop a proprietary technology, and we invested in a new process. So this is brand new. This is from 2025. We had this process in our plant in L'Ardoise, so it's in France, near Avignon. And this is how we can recover glass fiber after pyrolysis, solvolysis, let's say, end-of-life process.
And then you can actually use the recycled material to make a new blade. Yeah.
Potentially, yes. Maybe to complete, what we do in L'Ardoise, so in this plant, is Advantex glass. It's not H glass, high-performance glass. So depending on the customer, we can provide or not glass fiber with circular content. So this is really today for our Advantex glass, not for the H glass, not for the high-performance glass. Because we produce high-performance glass in a different factory, it's not in L'Ardoise. Okay.
Okay, no, as a starting, we can also discuss about the glass fiber reusing, but I'm absolutely clear that remelting the glass fiber is the way to use it in the blade again, nothing more. And with the carbon fiber, it's a total another story, but at the moment there's no chance to bring the carbon fiber in the blade again.
For now, I agree.
No chance, but we take it loud.
Well, I can maybe dwell on that a bit. And we have waste from Airbus, you know, and these are prepregs, so prepregs and rolls of prepregs somehow, and we can treat the rolls as a whole. Actually, you know, they fit in the oven. So we're working on that, but it's more complex because we need to then put back the sizing on and so forth. We're years from yeah. But anyway, that's
if you have a continuous fiber, then you can reuse it. If you have cutted fibers, you cannot reuse it. But
Yes,
this
I
is
agree.
not my question. Very interesting, your process. Tomorrow we have a presentation in the same matter. You go the right way. My question was, we know that the rotor blades mostly exist from sandwich panels. We have the flange, the spar caps, it's full laminate, what you show, but mostly what you have is sandwich, balsa wood sandwich or PVC or PET sandwich. Do you have experience with this?
Yes, we do actually, and this is why actually I was crying for help.
You can have to
you know,
give you the help, yes.
It's a challenge. It's a challenge. So there are several ways, and especially so I was trying to explain that the way we treat PVC foam in the reactor, the issue is that chlorine produces HCl, right? And so you need to capture the chlorine before it does. So we put cartridges with calcium carbonates, and through a reaction you produce a salt, right? And you remove 99% for now of the chlorine. But we have to go further than that, because then you have chlorine in the oil that makes it really hard to process. And so the other way is to remove the foam beforehand, but this involves shredding and then sorting by relative density, and that's another way. But it makes the whole thing more costly, I would say, and of course more complex.
Yeah, this is absolutely the way I will present this. You have to separate the foam from the glass fiber. You can reuse the full laminate carbon and glass fiber, also separated there, and then going to the pyrolysis, and then you have the oil and the fibers, and separate it before the sandwich.
I
Only
agree.
one way.
I agree. Yeah.
Otherwise, you have an oil what's a lot of waste in, and also the fibers are not purely.
Yeah, absolutely. We did maths on that, and you can go down to 1 ppm or 100 ppb. You know, so yeah, absolutely. We can discuss afterwards.
Let's discuss. Thank you.
Hi, I think one last question over here. Me again. Really interesting that you mentioned that you can take carbon fibers at essentially no gate fee because they're so valuable. And we spoke about cost there and the kind of pre-processing that's required for these blades. Can you say anything on the kind of prices that you're expecting for glass fibers as well? I presume it's not for free. Yeah.
No, it's not. We have a tipping fee. So we have a partnership with Veolia, you know, the waste management company. We're discussing actually pricing. Luckily, we have customers willing to pay, let's say, a higher price than current market price. I can discuss the prices in France because I know them. General waste will be taken at around 200 euros per ton, you see. With the first customers, we're at 600 euros per ton, and that's okay, but they're asking us to have a schedule to understand when exactly they're going to we are going to converge towards 200, 250 euros per ton. So that's the aim. When we go to larger volumes, that's the aim. So we don't want to be above the current pricing. So that's a purpose. We'll see. We'll see. According to the Excel spreadsheets, it's working, but you know, there can be a gap then. Yeah.
Thanks very much.
Welcome.
Let's go. Thank you very much indeed.
Thank you, Andrew. Thank you very much.
It's very dangerous because everything slides off here onto your toe or something. This is Plaswire's factory, and a delivery of blades actually came in from Scottish Power, where we processed the first onshore wind farm for decommissioning in Scotland, famous across the UK for the publicity it got from the media, often very wrong, in fact, mostly wrong, Hagshaw Hill, and we had tremendous support from SPR Iberdrola on that. We started our business as Plaswire in 2023 with a telephone call in January from Ørsted, and that put us into where we are today. So today we have a scaled business, which is processing wind blades onshore and offshore, with a commercial market. But if I gather everybody's capability in this room today and aspirations of capability and aggregate that, add that all up, together we don't touch the surface of what the problem is with wind blades just today. So I'll take you on kind of a journey of 30 years. Let's see where we're going in 30 years' time. We're all familiar with these diagrams, and they vary a little bit, but they all come down to the same thing, more and more every year. Now, this study was done with a professional consultancy that works in the sector in the UK in 2024, and they phoned me last year and said, "Do you want an update?" I said, "Why?" I said, "That's enough for me to go on, because it's not going to be much different. You will earn money, but talk to me in a few years' time." But this is where numbers get real. Now, bear in mind, somebody brought up today about what about manufacturing waste? Manufacturing waste today across the world exceeds 500,000 tons. It's far more than end-of-life blades. And it's not until 2035-ish that the two numbers converge. As we know, China has been, what we know now, because a lot of people didn't talk about it until a few years ago, has been putting up wind energy, particularly up in the northwest of the country there, and are the leaders in wind energy in so many ways. But by 2025, 30 years from here, Europe's going to be producing in end-of-life blades nearly 500,000 tons. The USA, 500,000 tons. And Asia, which is mostly China, but other countries as well, 1.5 million tons. But it's 3 regions and 1 challenge. Composite waste volumes are outpacing today's recycling capacity by magnitude. And so what? 2010 to 2030, there's been this boom that we're in now of more and more capacity being put up. And that doesn't plateau until 2050. And the waste continues to rise on and on into 2055. And Asia's the big driver here. However, we can say Europe is a policy driver. Now, that might change because massive things change. Only today, China announced that it's banning these flush-level door handles on car doors because people get locked in an EV if the power goes. So they're starting to lead policy. So that might be a comment that's not valid shortly. So let's have a look at regional waste curves. Asia's curve is twice as steep as Europe's and the USA's combined. If we repower or we extend life, it just shifts the problem, but it doesn't change it particularly. So we've got this window here of 2050 to 2060 where it's real stress. How do we do this? How do we deal with this stress? Recycling has to deliver, and it needs an infrastructure. And we've talked about process and systems. This is where we have to go. – 2055, the mass flow reality check. So we take a look at Europe. Gianmarco's done a lot to kick us up the pants and say, stop landfilling. And he's making it happen. That man really works hard at it. And you'll see there that we're going to be moving on to make sure that the blades get recycled some way, ideally through mechanical recycling, and some through chemical recycling and so forth. But can we actually do this? And then it gets worse yet. America, landfill is so cheap. I was told only last week from a friend in Texas that they're struggling to find an argument to put in a proper blade recycling service which is sustainable because their neighbor, who has colossal amounts of land, is charging a massive $45 a ton to take end-of-life blades. And there's a country there that doesn't like legislation, so the change in America has to be led by OEMs because the legislation isn't going to do it. So the bottleneck isn't waste, it's the treatment capacity. We've got to get there. It needs policy alignment, and it needs investment discipline. Now, we've talked today about investment, and various conversations have been had. Investors don't want to put the money into it. They're cautious. Of course they are. Do you go into a shop and not know what you want to buy? So you've got to present to investors a valid case for them to want to go with you. How do we process blades? We've got to remember, all of us here, that corporate governance is across the system, and we see it in Europe, and it will stretch across to the USA and into Asia, because it's essential for those countries to be able to trade with Europe. So they're going to have to comply with our legislation. I've seen this in aviation, where we do work with Airbus and Boeing. End-of-life aircraft are typically sent out to the USA for destruction. That's not attractive now, because the operators are turning around saying, what's happening to my aircraft? What's the ESG? And the USA can't deliver on that. So they're losing the business now. There will be global alliance in policy. And we have to think about health and safety standards. Now, we talk about China, cheap place, good value. It's not good value in the sense of you being a human operator in an ordinary factory. On a level playing field where everybody respects the individual in the factory, costs start to level out. And that is changing now. China's progressed tremendously. Absolutely tremendously. And we mustn't underestimate that. But we, whatever we do, have to look after our employees. And we have to look at the air we breathe and we put out for others to breathe. We must take care of the water table, about the water streams, about our lakes and our rivers and the land. And that means, how do we process our blades? How do we cut them? How do we clean up? How do we protect the neighborhood from the noise we make? Have you ever seen a blade or heard a blade getting cut? Here in Plaswire, I had to spend a lot of time and money getting sound engineers in to prevent that noise going out in the community before we had a complaint, thank goodness. Because I was actually quite shocked when it happened. It's an alpine horn, and it can throw noise kilometers. And ultimately, your clients, they want to know that you're sustainable and that your delivery is circular. Now, in Plaswire, we have a commercial operation, and I'm not promoting Plaswire here today. What I want to do is talk about 9 essential parameters that we find enable a business to scale in this industry. And the first one is feedstock flexibility. Put yourself on the other side of your system. If you are producing a wind farm decom fleet of blades, and you go to a recycling company that can do it, and they say, I don't want that blade, it's the wrong brand. Or that's got PVC in it. Or that's got that in it. You've got to work out how you can deliver on a flexibility service for your client. Otherwise, it's a frustration. And nobody wants a frustration. We live our lives by convenience. And why not? High throughput. A wind farm comes down, 750 tons in one hit. Can you handle it? Have you got the facility? So these things have to be thought through, and they're not something that's solved overnight. So these are the sort of things you may want to talk to investors about and partners of. How do we get our resilience in our business? Because we need to deliver for this incredible story, which is a factual story of high volume at an accelerating rate. Are you energy efficient? Are you pumping in loads of energy to produce something? And then, what are you making? Now, we can all work at different scales and different sizes, but whatever you make, someone's got to buy it. And they'll only buy it if they want it, they have a need for it, it's justifiable, it's economic. What we did was focus on the construction industry because we know the construction industry and we were already manufacturing for that sector. And we know that construction products, particularly the ones which go subground, on the surface, in basic preliminary civil engineering is where we've looked at. They're enduring products. They don't change. The design is 50 years old. So we're offering substitutes for those. Substitutes, so instead of using concrete, use our polymerized product. But it has to be price value for them. So don't be offering someone something which is, yeah, that's beautiful, but it's £5,000 and I can buy one of those in the supermarket in Lidl for £5. Work it out. What's marketable? And you need something which you can sell volume at. What's the capex? Think about what your capex is to do what you need to do. You have your capex sorted out. What are your operational costs? Don't be put off by this. Just realize these are things you work on. When you work on them, you can get there. And they're not easy work-ons very often. But you just do it, yeah. And then minimal pre-processing. Simplify your process. Be pragmatic in everything you do. Look at it. Can I simplify it? Do I really need to do that? I have a friend from China, and she so loyally and enthusiastically followed her mother's and her grandmother's way of cooking food. I was having coffee with her one day. She said, do you know what? She said, for all these years, I followed that process, and I realized I can just do it like this and this. She looked at it and realized that a lot of the steps weren't necessary or could be simplified. And she said, tasted the same, just like I got more hours in my life. Are you policy compatible? Are you trying to do something that policy isn't wanting? And that policy can be from your OEM. That policy can be from the state. That policy can be from the community. So make sure you're aligned with policy. And is your operational robust? Now, one of the things that gives you robustness is continuity of input. So if you focus your business on only the supply of blades, you're going to have some bumpy ride. And it might mean you need a ginormous storage area to buffer stock so that you can get continuous output. Or you can look at it another way and engage with other suppliers so you get input balance. And that can be the waste coming from the manufacturers. It can be waste from other sectors in the composite sector. So you get yourself a more operational, robust business. And strong unit economics. Look at the whole thing. Do the economics work out? Is this something which you say, jeepers, that's all right? That's a great business. However, when you show it to people and say that's a great business, make sure you've got barriers to entry in there. Do your business at the highest level. Have the highest level of health and safety. Have the highest level of the latest technology, of the most efficient machines, of traceability. Now, one thing we did in Plaswire is give traceability. So what do we do? Initially, QR coding product in. And that QR code lives with the product all the way through. How do I deliver that to someone like RVE? As in a few weeks' time, we have an online blockchain-protected portal where Bettina can log in and say, Andrew, well, she won't say it to me, she'll say it to the computer, what's the LCA date on that blade? And I can give it. And work hard on that. When we did our pilots, I call them a pilot now, I thought it was great at the time, but now we've moved on a lot now. Ørsted and Airbus independently sent in the National Composite Centre of the UK. They have a SUSWIND organisation for blades to measure our LCA data. And they came up with a number of 1 to 1.7 carbon negative. I thought it was great. But you know, a few weeks ago we found with putting in our LCA data collection system across our factory and unique software we built for it, we're nearly at 4 now. But, you know, I'm not going to say too much about the app because it hasn't been verified, and when it's verified, we'll get it certified. Just to clarify, because we know this really, you know, let's have the language right, because marketing people send us around the bend, all of us here, and it creates misinformation and confusion for ordinary people. Ordinary people in the sense they're not in this industry, but they see it, yeah? So carbon positive. You're adding more carbon for the work you do. It's not good. Get your business into carbon negative, because that's what the industry wants. It wants end-to-end good stories, honest stories. Get it challenged, get it verified, get it certified, and work on it, and work on it. Our ambition is to get to 6. Incidentally, you said, how the heck does he do that? That's because our primary product isn't wind blades. Our primary product is waste plastic that normally gets incinerated. Your wrappers, all your food packaging and so forth, constitutes 70% of our output. By diverting that from incineration, that's 2.7 tons of CO2 prevented. And by manufacturing products that substitute for high CO2 raw material products in the construction industry, we're preventing another 3 tons of CO2, depending on the product, but it actually can exceed in 3 if you're talking about replacing plastics. And then we have to take off our carbon cost. So we're around about 4 now, but as far as the documents go, I'm only saying 1.7. Maybe in 2 weeks' time I can tell you something different. And we've hit on this, you know, this is so important. And Bettina had a pretty hard time today from you guys, and she's there to take it because she stands for her company. But we need collaboration. You can't go from landfill to total solutions without something in between, and the cement kilns have been part of that. And if we stop cement kiln burning immediately, then what do? So it's a gradual process. But it's not for the OEMs to put their hands in their pockets and say, here's some money, we'll give it a try. They're not gamblers. It's a tough world out there for the operators. We see billions in the numbers. But at the end of the day, as we saw with Ørsted, under their stress, with the US situation, they started shedding people rapidly. They started cutting costs all over the place because it all comes down to a proper, well-managed business. So any support you get from the industry has got to be based on what you can deliver, what you are delivering, what you can evidence to deliver. So we continually, I would say it's every 2 weeks, we get a visit from an OEM of some sort. RVE's been with us twice, EDF, B&M, SSE, it just goes on. And it's great. We're proud to have it. It proves that we're doing the right thing. But the collaboration isn't just with OEMs, it's also with the asset owners, which are not the same. It's with recyclers. So we need here to collaborate and realize we've got different benefits to each other. And material innovators. Who's innovating with materials? Let's make that happen. Then you've got your local players. You've got to build that relationship with the logistics people, with the decommissioning specialists, with the permitting agents, and with regional recyclers as you get bigger. And of course, you've also got to collaborate with the government. We have to spend a lot of time talking with government at high level. Currently with the Scottish Government, because we're in the process of getting ready to build a second factory in Scotland to support a new manufacturing facility that's there, plus their onshore blades, plus the offshore blades. So we need that relationship with the government. Incentives, find those incentives. Nobody owes you anything, but you deliver and it's a bonus. Get out there and find out what incentives you can get to demonstrate that you're offering, for example, net zero benefits. And the frameworks need to be harmonized. This is something that Gianmarco's big on. How do we get harmony across the whole of Europe so that we can work more easily and not see those borders when it comes to moving waste blades around? There's no single act that can solve this blade problem. And the global ambition is needed. Execute it locally. Get your policy organized. And then you can have scalable circularity. So what we did, what you can do, is build a blueprint. So we spent the last year or so building our blueprint facility. And this is a facility that can be dropped into any country. It's an off-the-plan RX polymer production facility. We offer process setup and training, the software and support to prove the sustainability and circularity, along with the QR coding system, and essential traceability in ESG delivery. So that's how we see it. But you might see it differently yourselves, yeah? So there are the 9 points again. I gladly will share these slides with you, and thank you very much.
Questions?
Here we are.
Thanks, Andrew. Always fascinating, but wondering, there's a bit of an echo. You've had some really good kind of case studies with a number of companies now that have been quite public. I'm just wondering, is there any of those where you learned something, I suppose, new, that the process was harder or easier based on the type of blade that you received, or any pre-processing that was done, or yeah, just interested to see if that's helped to evolve your process as well.
Well, to start at the end of it, we're evolving all the time because we have to develop and develop. So, for example, how we cut the blades has developed, so now we have a dust-free operation for blade cutting, feed a whole blade into it. So with our legislation on the roads in Ireland and the UK, we can take a 25-meter blade as a single element. That really makes an easier life for us. And the bigger the better. And several people have said the same thing here. The bigger they can take an element onto the site, the safer it is for the environment, for handling and so forth, yeah. We are always learning about the blades, and we're building up our own library of blade data as we get them in for Vestas and LM and TPI and whatever, yeah, I'm doing that. We do get the situation, generally speaking, where, you know, these blades are old. So the ones we've taken from B&M in Ireland, County Mayo, there's 60-odd blades there. Nobody really got any documentation. They're just saying, here they come. Yeah, and the same Hagshaw Hill to much the same extent. But then we get a brand new big onshore blade from a company that got damaged before it got erected in the storm last winter in Ireland. 72-meter blade, and I get everything I want on that. Detailed, yeah. So we are evolving all the time and developing our processes, and we're moving forward now. We've got the designs ready for when we're to build it, to take blades with a 5-meter diameter end, so we can deal with offshore blades and so forth. Yeah.
Yeah, thank you, Andrew. You're speaking about my heart. We need a data sheet. We need a library about the old blades. There are no companies existing anymore for 25-meter blades, 25 years old blades, and you're not known which material they used and not which resin they used. And it will not help to make it by our own in the country. There are some more actions than you to do this. Let's discuss how we can do this together, because in the end, everybody who dealing old blades have to know what is inside.
Yes, there was a commitment, can I say commitment, from, was it DTU in Scandinavia there to produce this passport. But I don't think it went past a couple of blades, did it?
Yeah, Vestas and LM makes such an initiative. And also in Germany, there are some actions around there, and then we as a research institute finding out how we can deal with this and how we can find it out, especially how we can measure which resin it's in, or maybe we can find out which glass fiber is in, or is there PVC in or balsa wood in, because you had also to separate it there, because it's a raw material in the end. But not knowing what's in the blade is, then it's higher cost to find it out. And as I can say from my experience, from my former experience, that in the old blades there's a kind of differences there used, because we used several resin, sometimes another foam, and also the glass material is always not the same.
Yep, old blades are absolutely brilliant. You know, we get them in sometimes. I think, gee, this could spin for another 50 years because they were so over-engineered. But yes, now we have a pragmatic business, so we can be pretty easygoing about what material comes into us. But when you start getting to what you're doing there, I think we need to put some pressure on the blade builders that are available. That data must exist somewhere. It must exist.
I'm building 25 years blades by my own in a company, and I can say 25 years old blades that doesn't anymore exist which material is in. It's this paperwork. The paperwork was stored for maximum 5 years, and that's going away. It's not finding out anymore. We have to find out by a proper incoming control of the blade what is in. It can be easy, but to think that we can find out the material what is built in from 25 years, I have no chance, and I see no chance to do this in the end.
Yeah.
I
don't know what your answer is for that. I would say it might be good that it's mandated that current blades in manufacture and recent history blades, where there is data, starts to get put into some sort of database. However, we must bear in mind there's corporate information there, which is highly sensitive.
Yeah. For today's blade, is totally not a thing.
Okay, thank you. You're disagreeing with me, yeah?
Yeah, sorry, but I agree actually with I don't know, it's Niels probably. So, yeah, I've been also working for a lot of the big OEMs. So, in the end, for example, if you just take the glass, if you would find out or had the information that, you know, it has boron in it or not, that would make a huge difference for remelting. But there's no way to find out. And at the OEM, it mattered, and probably, you know, my former colleague Robert can even, and Dirk Jan can even answer that better. So there's no clue what's really in the glass, for example. Yeah, the paper is gone. Probably the OEMs themselves didn't know what was in it, what they actually put in, because what mattered was that it lasted. You know, the mechanical properties and a lot of E-module or other properties mattered, but not the chemical composition. Same for the sizing. I mean, if there's PVC in it or PET or balsa, I mean, you can see that, you know, you can test that. That's fairly easy. But yes, I agree. If we can pre-select it before, it makes, for example, for us, that we can take out all of it, but it would, you know, make the cleaning process a lot cheaper and more reliable.
Yeah.
But that, you know, the basic data on PET and PVC, that exists because certain producers have used certain materials, so you can take a 99% guess. But on the glass and other components, you can't find it out anymore.
That's a Wind Europe challenge, I believe, yeah. Listen, folks, I've gone over my time. I'm the one saying we should stop, so I'm going to stop myself, if you forgive me, yeah. Maybe you won't, yeah. Coming up here now is Marcelo Caledani, who's going to discuss about the latest results of the Deremco project.
Okay, so good afternoon from my side. Welcome. Well, thanks for the invitation. I was here last year presenting you the Deremco project, and I just arrived from another project meeting, so unfortunately I lost the morning, but I will stay here until tomorrow in the evening. I will give an overview of the latest results, of course summarizing as well what is the Deremco project about. And I brought also many samples, many examples of products, and I have them in my luggage, so I will take them during the break. So I'm the coordinator of this project. I'm professor at Politecnico di Milano, Mechanical Engineering Department. I'm also the founder of a startup company called Fiberuse Tech. And I will give you an overview of what we have been doing in Fiberuse, what we are doing now in Deremco, and what is Fiberuse Tech offering to its customers. So I don't think I need to spend too many words now. It's already afternoon, so I'm sure you have been discussing about the importance of composite materials all around different sectors, in wind blades in particular, and numbers about the expectation of volumes of post-use wind blades in Europe and through all around the world. I totally agree, these numbers are every year changing, also because many companies are delaying the decommissioning because there is only few solutions for recycling these blades. So every number is really prone to be adapted throughout the years. But what is true is that what we learned last year here as well is that there are many quite large plants for recycling blades already under construction. Last year they were under construction. This year we will see where they are. In Spain I counted 3, and there are other in other areas of Europe. Total capacity will be pretty high. The point is, who will be the off-takers for these materials? So I totally agree with the previous presentation. We have to concentrate on solutions that really add value to the material that is delivered in output from the recycling processes. And this is the core aspect that we are been dedicating the last 15 years to try to find circular solutions to integrate fractions of recycled GFRP and CFRP from composite material products. And the vision that we follow is in line with these 2 big principles. First of all, the cross-sectorial approach, what I call cross-sectorial approach. Basically, what does it mean is that we don't need to only concentrate on solutions that can bring back the composite material, the glass fibers or the carbon fibers into the original product, but, you know, substituting virgin material in other sectors that can act as off-takers of the processed material is still having quite important beneficial effect on the overall value chain of the composite material. Why? Because you don't use virgin materials, but you use recyclates. And this is what we mean by cross-sectorial approach. Of course, and we go to the second point, trying to continuously respect specifications of the target application. What we call demand-driven, specification-compliant circular economy. Many times you hear recyclers accepting, as you said, dedicated or specific input flows, and then applying the process with always the same parameters, and then asking themselves what to do with the output materials. And the answer, unfortunately, is many times is nothing. Now, we are reversing this principle, and we are really starting from different specifications that come from the different reprocessing activities of different application cases, and we are pulling this specification to make the recycling system completely adaptable in terms of process parameters to feed in output in a continuous way material that meets the specification. So we really think that this is a key for first of all, feeding this cross-sectorial model, but also making it possible to avoid big adaptations of the normal manufacturing systems that the reusers, the application sectors will apply. So we will reduce the barrier for uptake of this solution. Of course, this is not just theory. We started, as I said, a few years ago, 2015, 2017, there is this book publishing the main results, industrial results of the fiber use project. We also developed many products that were integrating different fractions of mechanical and thermochemical recyclates from wind blades, and we presented these results to the design community in the Milan Design Week. Why the design community? Because we need designers involved. If we want to go for this specification compliant approach, we need the designer to consider that virgin material is not the only available option. Recyclates in their product can be integrated certain level and guaranteeing good performance in output. But this is the past. Now we are moving forward with Derenco. Derenco started in 2022, and we have, you see here, 14 investment cases, so companies that are really investing in integrating different fractions of mechanically and thermochemically recycled materials from blades in their products, proving that the product itself meets the desired KPIs, desired performance. But it's more than 14 because, as you will see, through open call mechanism, we funded other companies to do experiments and prove that the material can be integrated. At the end, we will see, well, we'll not see all of them, but you will see that we end up with 30 investment cases in different sectors, all focused on the reuse of these fractions. I will concentrate most of my presentation to the output products. So it's really not that much on the recycling process itself. I only have 3 slides on the 2 strategies that we follow. The first strategy is the mechanical recycling process. So, I mean, you can do it with different technologies, different equipment, different volumes, different throughputs, different pre-process sorting of the blades. Who drives the process chain and who drives the parameters of the process chain? The application, in our case. So we start with the desired granulometry and design concentration on fibers, and then we pull the specification to the adaptation of the process chain. That's the first point. And you see some parameters there of cost and energy. Again, this depends pretty much on the scale, but you see a little bit here the technology that we have patented, the fiber use stack, that is basically a control technology for the shredding stages that enables to combine the parameters of 2 or 3 stages that you can use to obtain a control material in output. Now, this is the pilot plant that we built a few years ago, but now we can scale up to different volumes, and we are offering the potential to integrate this patented technology in common mechanical recycling solutions. This is strategy number 1. Strategy number 2, and I have to say, I won't talk too much about this because it's more what we suggest for carbon fiber recycling, is based on thermochemical process. Is a process that was developed and patented by Corec that we operate in Fiber Use Tech, and it allows to obtain clean fibers through a controlled environment pyrolysis process and a byproduct of the resin that can be reused as well. Again, for glass fiber, the economics doesn't work. For carbon fiber, the economic works. So that's why I won't talk that much about this process in the remaining of my presentation. I don't know how far I can go with the time in terms of examples. Let's see. Okay, I still have 15 minutes, more or less. So I will go on with some examples. Of course, as I said, concentrated on the target market and the target product. First example is BMC. Now, you know that BMC is a huge potential market for granular recyclates from blades. The only thing is you have to adapt the receipt to make sure that you obtain a product that respects the specification. And here we are working with an automotive tier 1 supplier that is building different automotive components in BMC. And you can see, I mean, automotive is pretty demanding in terms of specifications and certification of materials. Here you see what we have been doing by mixing recyclates from GFRP and their internal SNC and BMC industrial scrap. I have a bit more details about the company that we have been working on. NTS is an Italian company from Bergamo. And you see here more details about the process. So we applied our mechanical recycling process. They have been recompounding the BMC, mixing the recyclates, of course, with a receipt that is the core, so I won't disseminate what they have done. And then they have used their usual processes, molding processes, for obtaining a product that is, from the mechanical viewpoint, pretty comparable to the product you only use in virgin materials and definitely respecting the market KPIs. So this is a use case that shows that this, let's say, reuse application is market ready. So, of course, you have to elaborate on your receipt, but that's exactly what you do when you produce your product starting from the virgin material. We all elaborate the receipt on the composites, right? We select the right fibers, we select the right resin, and we select the mix, and then we test. That's what you have to do with the recyclates. So nothing really new from the industrial perspective. That's the first case. Second case is using 3D printing as a reprocessing technology. This is Caracol. Again, is a Lombardy region company producing these large 3D printing machines. And in this case, they have been producing a tool for lamination. Again, in small wind applications for integrating 30% of recycled glass fiber. In the previous slide, I didn't mention the percentages, but usually we can go 50% of GFRP recyclates or even 60 in the last experiment, so pretty high quantity of recyclates. And well, this is a niche application because 3D printing is still niche, but of course you can produce very flexibly large parts. Very high added value parts. So we are not only concentrating on the cost of the process, we are also concentrating on the added value of the material and the product that we obtain. And that's what always should be balanced in this field. Third is more design furniture. I won't go too much in details, but we mix the granulates with the fresh resin and we produce pretty nice and beautiful design objects that we are now integrating in our outdoor terrace at Politecnico di Milano, and they have been, of course, presented in Design Week because, again, we want to give this flavor of the texture of the material that is super interesting and that cannot be achieved so easily with the virgin fibers as such. Then this is more industrial, technical, fancies for the outside application. This is Technola, is a Slovenian company. And of course, this is the interesting part of this application field is the volumes. I mean, when you build construction material, as we have heard before, you can really target pretty high volumes with the same repeatable material. Again, another case, hybrid yarn. This is using more the strategy 2. There is this company, Centro Coat, that is developing respinning technology for starting from the clean fibers from the pyrolysis and then respinning a yarn that can be used then to produce a different textile. Here you see an application of the respinned carbon fibers for building a network with very interesting performance. But of course, you can do the same application for GFRP if the economics work. I have a last application case, well, a last transformation strategy for the material, obtaining matte. You can give either granulates or the thermal recovered fibers to Airlay technology, it's a textile technology. We are not the only one using this technology. And you can obtain mat with different density and different mechanical characteristics. And of course, depending on the final application, you have to select the right mat. What we have been doing in our project is, together with a company from Slovenia, building these shelves for motorhomes, integrating the recycled mat. And the process that you see here is basically based on RTM. So again, industry-ready process that is applied for many other products. So, I mean, you can see how flexible the approach can be. You can see how many applications you can feed, and hopefully you can reach quite high volume of taking the material and bringing it back to the market. I have a few more applications. Well, this is what we are doing to showcasing all the products. We'll be at the JEC this year as well, so if you are there, just pass by and I will show you more samples and more products. In Derenco, as I said, we also paid other companies for testing our solution. So this is called cascade funding in the language of European projects. And we have been managing the funding for attracting new off-takers, basically. And this way, we have been financing 8 more application scenarios in the first open call, and in the second open call, again, 8. So that's why I'm saying we are talking about 30 investment cases by companies. And you see here the name of the companies and the specific application. The 2 applications that I like the most, I have to say, is this one for e-mobility vehicles, small vehicle, electric bicycles and e-scooters, where we develop specific parts in embedding recycled GFRP, particularly this part here. I don't know if I can point. Well, is this part, the pointer is very slow. This part here, and this part here for the bicycle, so not really structural parts, but parts that can be definitely built by substituting the virgin with recycled glass fiber. And this is also a very nice application in my view. This is for the ultralight skin guard made, which is this product here, that were done by introducing 20% recycled glass fiber and a formulation that involves other recyclates and virgin materials. So again, flexible. The only issue now is testing as much applications as possible and trying to really open the demand for these materials. Also trying to, gather the imagination of the designers and let them thinking about the integration of recyclates since the very beginning of the design process. That's, I think, the next step. My last slide is this one. We have another project that come from a project meeting of this project. It's called Urban. Here we have built a mobile recycling plant on 2 containers, one for mechanical recycling and another one for reprocessing technologies. And this is existing. As you see here, we have done the presentation in Milan in September, involving many designers and stakeholders to test the material and to create their own design. This is very important to train how to use these materials and to create a school out of reusing these fractions. But that this is also accompanied with a business model of my company that is basically bringing this into the composite part manufacturers to treat their production waste, for example, or maybe in the future, why not, in conjunction with on-site pre-treatment of the wind blades. The capacity is not high, as you see. The capacity is 1 ton per day, so it's 50 kilogram per hour, basically, but can be what you need for your production waste if, as usual, you have probably 40 ton, 60 ton of production waste in composite production in a small, medium enterprise. Why not? It could be rented for 1 month and you can reprocess your product to obtain some usable secondary materials for your own production. I think I said everything, so I will be around if you have any question, but of course we can, I think, open for more questions here. Thanks a lot for your attention.
Thanks for that fabulous presentation. Angie from Bladebridge in Ireland. I'm wondering how you'd handle the waste aspect of that pop-up repurposing line or pop-up recycling line, if you've...
You mean the mobile plant?
Yeah.
Yeah, so here we were only dealing during the all workshops with production waste of NTS. So basically is a composite material that was brought by them and was no waste because they brought it. Well, of course, if you would need to treat waste, even in plant, you would need special permits. Yeah. I don't know if I answered your question, but of course you have to limit the let's say, capability of your plant when you do shows in public areas. This was in a public space in Milan. We will repeat the same event in Barcelona in April. It will be 3rd of April, 3rd of May, and in Vienna between the 6th and the 10th of May.
I just wonder, is this, you know, this might be a question also for Wind Europe, would something like this be possible to do with the current, with the waste handling requirements? I mean, this could be it's something we're looking into.
I will ask to Gianmarco more hints on this, definitely.
Thank you, Professor. Very good presentation. I like the approach. Like, you have to take care of the entire value chain when you are developing something. And also, we should know the materials that we need to work with, their properties, and then develop a product. Now, my question is, what challenges did you face during the shredding and during the recycling?
Yeah, good point. I can go a bit more in detail. So there are processes that are very robust to the presence of impurities. So I was hearing before talking about balsa wood, other reinforcements. There are processes where these reinforcements donate specific properties to the material and they can be embedded into the reprocessing step without any problem. Especially those processes that then produce more aesthetic products, right? You can even exploit the aesthetics of this mixture. In functional products, of course, you may avoid you don't want to have many impurities. So what we do here is pre-processing, so pre-sort the material, and we have a selective cutting technology for different parts of the blade. I've heard before that pre-processing should be kept to a minimum. I agree, but it always depends on the value you bring to the downstream material. So you have a higher cost of the process, true, but if this can bring higher value to the material that you give in output, and this is justifiable, why not? I mean, everything needs to be really designed in function of what you want to obtain and what product you want to feed. So combining both approaches, I think, is the best way, because you combine a more robust approach, probably higher volume, and then a more sophisticated approach, probably lower value but higher value, lower volume but higher value. That's our perspective.
One last question. When you are shredding composites, have you done a study to see, like, what is the life of the blades?
Yes.
Blades,
the tools. The tools, yes, the tools. Yes, our patented technology takes, I went very fast here, but I don't know if I can take 30 seconds to explain. It's based on, yeah, here it is. It's based on a cyber-physical system. So you have a model of the shredding process, and then you have the integration with the shredding machine through OPC and through a direct link to the local PLC. So what you do basically is considering the tool wear as part of the objective function in the cyber part of that controller. So we optimize the rotational speed in order to minimize the energy required and to increase the lifetime as much as possible of the shredding tools. But of course, in shredding composite, the life of the shredding tools is an issue. Also because many times, and this is the case, the rotor itself is multi-tool. So you have to take into account the overall behavior of the rotor. So this is the way we take into account this aspect, but of course there's more you can do.
Thank you.
Yes, question. Thank you, Professor. You've shown very inspirational products. But wouldn't the reuse in fashion products or consumer products like shin guards or bicycles or furniture just postpone the landfill, the unwanted landfill, with a few years?
I mean, in principle, this material, since it's created by integrating recyclates with the virgin fiber/resin, can be recycled many times. I don't have any number justifying this statement, sorry for that. But in principle, you can take a product, reshred and remix with virgin material, and there must be conceptually some, let's say, limit that is not one cycle, of course, for reusing this material on multiple life cycles. I know my answer is not scientifically sound, but is a little bit of logical answer I can give to this question. More needs to be done in terms of investigation, definitely. Also because the shredding process is random. So you don't know exactly if you are cutting how you are cutting the fibers within the granules, right? So this randomness help in this direction.
Oh, but these concepts then need, or it needs a concept where a consumer then is let's say, supported in bringing the product back to the manufacturer after, you know, you've been a footballer for 3 years with these shin guards, and then, you know, you don't want to throw them away in the kitchen waste, but or in the normal waste stream, but you need to return them for proper reuse or remanufacturing.
Yeah, this could be the model for attracting more consumer products, definitely.
Professor, thank you very much.
Thank you.
That's
Thank
fascinating.
you.
Thank you. We'll be joined now by Jos de Kruijger, who's a co-founder of BladeMade. He's going to talk about scalable blade repurposing with BladeMade.
Yes, thanks. And hello, everyone. Glad to be on this stage together with the awesome presentations we've seen before. And with BladeMade, we're a Rotterdam-based startup in the Netherlands. It's these four people. Thijs is with me today. Some of you might have met Tony or Jan Willem in previous conferences or meetings. And what we're doing is working on the repurposing of blades. And it started, well, almost 20 years ago with designing this project, the playground in Rotterdam, as an intern at an architecture firm. And that was built in 2008, which proved to us that repurposing blades was a viable solution to the material that is available. But it took a while to, well, mature, to scale, and it went around the world in press things, but not necessarily in production. And 3 years ago, 4 years ago now, at Dutch Design Week, we launched BladeMade as a company to show that scalable repurposing is an alternative before recycling. And there we launched it with some more, let's say, conventional products that can go into the urban fabric. Smaller playground elements, furniture for public space. Not consumer products because of the issue just mentioned before, because we need traceability in the long run, because at the end of this life it should be recycled. And there we see an opportunity for synergy. So looking at the material that is available and the flows that are coming to us, and especially sort of the peak waste that was mentioned as well, we need to reduce that peak and use the material for a second life for 25 to 50 years, so that we can better balance the inflow of material into the recycling system in the long run. Besides that, it has a really high quality. So what we're doing is giving that ever-growing, well, ever, at least for the next foreseeable future, material stream of composite wind turbine waste a second life as structural building material. And building material we're taking more literally now, so not just smaller urban products, but larger scale, where we are a circular alternative to concrete and steel. So that means repurposing. And looking at the table that we've seen before of the 10 R's, which I think is a very good manifest for decision making, we want to be as high as possible. And as you can see, repurpose is not that high. So we support all the other things. Reuse it as wind turbine blades before for as long as possible. Repair where possible. Refurbish your current wind parks. Do all that before you start to repurpose. But do repurpose before you start to recycle. And definitely don't incinerate if you can avoid it. So within these steps, reuse, repurpose, recycle, the more easy steps, it's important that we look at that material with the qualities it has. So it's a pretty simple piece that can be connected at one end and has a long distance that it can cover just by using that, the physical properties. And if you put that on the ground and add them next to each other, you can create, for example, a blade barrier that is functioning as a sound barrier along highways. And of course, you can also create surfboards, other smaller consumer products, but they can all come as a second step. So first, make the blade barrier. If that goes end of life, 25 or 50 years from now, then create the surfboard and make sure you have the capacity to intake that material again at a point where it's easy to connect to all the other parties in the chain. And with that, you can create a circular value chain for the whole material flow. So looking at the onshore and offshore wind farms, we use the regular transport companies for blades that have the knowledge to handle them. We try to bring them to storage and transformation facilities, which doesn't have to be ours. We can cooperate with all the parties that are already working with blades that can use our designs with a license to produce, where we put blade-made products in outer space. And that's not just a blade barrier, that can also be the smaller products up to what I think is the smallest feasible size, an insect hotel of a section of 20 centimeters, which is roughly the size you need before you put it into a recycling facility. Depends a bit per facility, but in general, you go down to like 1 meter up to 20 centimeters, etc. And then you can recollect the fibers for all the other products that you can make. And again, same transport companies that are already in part of our circular value chain, they bring it to those recycling facilities. And hopefully the recycling facilities develop in such a way that it can become material for wind farms again. But if not, then there are other value chains connected to it in the long run. And basically with the strategy that we have, we are working on 2 levels, not just the repurposing, but also on the refuse. Because we supplement, or we basically give an alternative to the conventional material use of concrete and steel for these urban products and in the sound barrier as well. So looking at that, here are some realized projects on different scales in the past 3 years. Left top is a small piece of furniture in China. Right bottom is a playground in Terneuzen in the Netherlands along the beach. So there's different applications where different materials can be used. But in the end, as Andrew also told us, we need scalability and repeatability. And that's what we're looking at right now. That's the main challenge for BladeMate in the next year or 2 years, to go from these strong concepts to scalable and repeatable objects. And looking at the full 11% of GFRP waste from that turbine, we said, okay, we have the blades that we can use for sound barriers, and we have the nacelle that we could use for micro homes. And together with Vattenfall, we developed the micro home not because it should become a micro home, but because it's the most complicated thing that you can make out of it. If you can make a micro home, it's not hard to make a shed for tools in your garden, or it's not hard to use one part of it for a carport. But if you would just show a carport, then people would ask, yeah, but can you live in it, or can you do this? So go complicated first to prove all the other solutions. And that's what we've done with the blade barrier as well. Together with the National Road Authority, Rijkswaterstaat, Dura-Vermeer, one of the large contractors in the Netherlands, and the Provincie of Noord-Brabant, we've built a 60-meter prototype where we used 2 whole blades and 1 cut fragment to be able to do physical tests on production, but also other endurance tests, and do calculations on the sound effects. And actually today we released a press release together with Rijkswaterstaat on the results of this project, specifically on the sound performance. And it's outperforming what the experts expected it would do. So that's interesting. When you start an innovation project, you know that it's going to take a while. And we've built a prototype half a year ago. We started with Rijkswaterstaat roughly 1.5 years ago to make this construction happen. And the test will go on for the rest of the year to deliver the other results that we need to be able to repeat this on scale in highways in the Netherlands. But I think that looking at Dutch regulations, it can probably be repeated also in all the other EU countries. And if not, I would like to know which rules differ and how we can tackle those as well. Because we can outperform a standard conventional concrete barrier, not just in looks, but also in acoustic performance. Of course, our modularity is different, but that also helps us in a way. And what you can see in the sound performance results is that, well, left top, no screen at all, the standard view. Right top, a concrete screen that is sort of reflecting in a very regular way along the whole line. And because of the completely changing shape all the time of the blade, we have a very diffuse refraction of sound, which means that we can outperform the standard barrier for almost all the measurement spots. And while doing that, if we build 1 kilometer, we can repurpose 240 tons of GFRP and not use 1,000 tons of concrete and not use 100 tons of steel. So all these materials become available for something else, where we also have big assignments in building houses, building, well, new roads. I don't think they're necessary, but sometimes they are. So using that concrete and steel elsewhere, it might have more value than in making sound barriers. And with this, we have a basically designed material storage for 25 to 50 years, helping to put all these blades in a good place. It's very traceable. It's relatively easy to connect to in terms of construction. You use the whole piece. You don't need cutting at all. And the same goes for the micro home, where we've tried to do the same thing. This is a, well, depending on which model it was used, but V66, V80, V90 nacelle. It's roughly 10 by 3.5 meters, so a 35 square meter footprint, where we created a 25 square meter interior that is compliant with all Dutch regulations. In the prototype, there's some minor things that we didn't manage to fix within 8 weeks of building time, but they can all be, well, engineered out of the process when we start to scale up. Because right now we're looking for someone to work with us on co-funding 10 units of this, so that we can upgrade the engineering, and we have potential clients for that, but the up cost front for a startup of 4 people is just a bit too much. So we're talking to investors, etc., as well to make this happen. But maybe the wind energy sector is much more prone to deal with this as well, because it can also be an office extension or on-site office or whatever for a wind farm, etc. And again, here the numbers are smaller. You repurpose roughly 3 tons of GFRP per unit. But in the end, if that scales, it can also go up to 35,000 tons per year of GFRP that you can repurpose instead of throw away. So that's roughly what I wanted to share with you. And if there are any questions, then you're more than welcome to discuss. Thanks. Yes, of course. Just put your name on the list, and then we'll get back to you as soon as possible.
Thank you for this very interesting presentation. I have a question for the noise barriers. So I don't know much about the material using for this field, but I want to know, will you do some pre-characterization for the qualities of the aged wind turbine blades to be used for that? Because we are not sure after 20 or 30 years, there may be some micro cracks in the blade. I don't know whether this can be a major barrier for using for the noise barrier.
Yeah, thanks. I understand your question. And of course, that's also one of the concerns of Rijkswaterstaat, so the Dutch National Road Authority. That how can you prove the quality of something in a second life phase? So that's part of what we're testing as well. But most of the issues can be tackled by coating them once. Of course, if there are cracks, you might have to repair them. But the repair is not necessarily for structural use, because the loads on it are completely different than when it's in the air. So what we've shown, what Albert has shown before or what Erik has shown before, those kind of repairs are not really the issue. And we think that it can last for 50 to 100 years outside. Basically, the 100 years that Albert showed, this is still a first use scenario, where it's in a non-stressed situation, but you might need one coating that deals with anti-gravity, fire resistance, and UV resistance to tackle those issues. And that also gives it one consistent, clean look, where you might also be able to choose the color. So for example, next to Den Bosch, they might be yellow, but in the rest of the Netherlands, they're white.
Thank you.
Yeah, my question goes more or less in the same direction. So, I mean, specifically, for example, in Texas, we see, blades basically stored above the ground because people are so afraid that they get sued in 30 years if they actually bury them. So, and even if you recode it, there is the issue that it will deteriorate. And then you have a lot of microplastics in the environment. So how do you actually control that? That's one thing, because I think this is a major concern. And then the second thing is more a visual thing, because we have been, fighting for acceptance, with the public, as people say, hey, wind energy, great, but not in my backyard. So now you bring it even in front of them, even closer up. So, so that would be interesting to, if you have any studies on that, if that actually is acceptable. And the third one would be, what about the risk of, like car crashes or truck crashes into it, because then it will splinter and you have it like everywhere. And right now there's super hard restrictions on the decommissioning, when you actually take down and cut the blades. So I think that it's more than one issue to tackle with that,
Yeah. Yeah, thanks for the questions. I'll try to answer all three. But first, the one on the public perception. I think within wind energy, there's lots of people that are in favor of it, but also a lot of people opposing it. The people opposing wind energy in general are not going to be convinced by this, because it's part of the problem they already don't like. But in general, a lot of people won't recognize it as being a wind turbine blade. And if they do, in this room, everybody will. But not everybody outside this room will immediately. And even if they do, maybe it might help them in the long run to accept, okay, there's actually a second life for this. In contrary to coal power plants, nuclear power plants, where the waste is endless and, either it's immediate or it is, 10,000 years. This is doing something useful with it, even reducing the carbon footprint of wind energy even more. Then the other one with car crashes, what we've done in this case, this is a prototype, but it's on a sort of earthen hill. So I think in general a car will crash into the earth hill before it crashes into a blade. And in the Netherlands, in most cases, there's a, what do you call it in English? Well, sort of protection barrier before the actual sound barrier. So the car will crash into a metal barrier and the sound barrier has another function. So I'm not really worried about these, but there might be cases where it does become an issue. And in that case, either there's some big damage with splinters that you have to clean up and that you have to repair, or you have to take the whole blade out and replace it with a similar one. That's tricky, because, the blades are end of life. They come from a wind farm that is also end of life. And if you have, let's say, 100 Vestas blades of a certain type, who's going to say that within 3 months of a car crash, you're going to have another one of these available? So that is something that we haven't tackled yet, but that might be the same in case of some other sound barrier options that are considered nationally with bio-based materials or earth. So I'm not convinced that it's going to be something that makes this impossible, but it's something to be wary of. And then your first question was? Yeah. Well, again, the wear and tear in this situation will be much less than it is when it's in the air hitting wind speeds of 100 km/h. So the edge erosion that you see in the picture, one of the pictures that we've seen before in the presentation, I don't think that's going to be an issue here. And if it is, you could coat on the spot to repair those kind of damages. So it is a concern, especially for the Dutch Road Authority, and it's also a question they asked internally. So why should we put another value chain's waste in our system? And the easy response to that question is that concrete will also have an end of life where it becomes waste. And that is also not part of their natural value chain. So it doesn't matter which material you put, the material has an end of life, and that end of life you will have to deal with at some point.
Maybe to add to that on the microplastics, I think that's something that comes up quite a lot. Almost all the microplastics, I think 99.999% are coming from thermoplastics and not from thermoset materials. Because of the cross-linking, the way it's structurally stable and doesn't get degraded. Mechanically it does degrade, but then you're not talking microplastics, you're actually talking macroplastics, you're talking flakes, etc. And they behave very, very differently. So the microplastic problem is not a real problem with thermoset material.
Thanks. I could not have answered it like that.
I could just confirm that we've seen pictures, and it was typically leading edge erosion, and this is when a blade goes with 200 kilometers per hour through hail and snow and what have you. This is causing abrasion. In your case, you will hardly have any erosion, and I think the issue of chemicals leakage or something can easily be solved by coating, like you said. I mean, if you take a marine heavy-duty epoxy coating, this will hold 100 years in your application. So I think you can guarantee a full inclusion or encapsulation of any toxics. So I think that's the least of the worries you could have. So just to confirm also what Johannes...
Yeah, thanks, I agree. I would like to have a paper that confirms that as well. That will help towards the National Road Authority to tell them this will be safe in the long run for you regarding maintenance and end of life. Well,
I think we can work together on it.
Sounds good.
George, thank you very much indeed. That was fascinating. I've learned so much about what you do. I've taken a lot of things for granted, and I know a lot more now. Thank you very much indeed.
You're welcome.
We can break for coffee now. Please, can we come back a little bit fast to this? Because I've overstayed the presentation, among things I'm guilty. Coffee's outside, and then we'll come back for the final part of the afternoon. Thank you. Hello, everybody. Am I live? Yes, I'm alive, yeah. Okay. As we progress through the afternoon, I'm pleased to present Paul Leahy from, he's the head of energy engineering at the University College of Cork in Ireland. And he's going to discuss with us environmental decision support for optimal end-of-life blade repurposing. Thank you, Paul.
Thank you for the introduction, Andrew, and thank you all for the invitation here, the opportunity to present to you. So my day job is I teach wind energy in the university in Cork. I'm also co-founder of the repurposing startup BladeBridge, and our CEO, Angie Nagel, is here. She'll present tomorrow. So kind of what I want to present today is a little bit of a journey from research to some real-life repurposing, and then back to research again. So I structured it the wrong way around. So the background to this is the ReWind network, which was an international research project, not to be confused with the next ReWind presentation, which is coming after me. From that, we established a kind of a technical basis for repurposing, and then that was commercialized through BladeBridge. But there were, as we all know, some barriers to repurposing and some challenges. So we went back to research and formulated a second project, Airblade, and I'll talk a little bit about what we're trying to do in Airblade at the end of the presentation. So first of all, show you just our kind of history, our track record in repurposing and what we've learned from it, and then what we think is needed in order to take repurposing. And I'll talk about repurposing here because that's my interest, but actually almost everything really I talk about applies to all the other end-of-life solutions as well, and recycling in particular. So many of the issues that we face in repurposing are the same ones that we face in recycling. And I think it's very clear from what we've seen today as well, is that we need all, everything is going to be a multi-technology solution that's needed for dealing with the diversity in terms of location, materials, structural properties, and condition of end-of-life blade materials. So I think everybody's in this together. So with our Airblade project, we developed a suite of online tools that can be used to help and support repurposing or indeed recycling in order to kind of streamline the process and eliminate some of those barriers that we found when we actually did some repurposing projects. So I'll talk a bit about that. And then one of those tools is a life cycle assessment streamlined tool, and I'm going to show you the background work that was done on that. So a full life cycle assessment on a particular case study of repurposing, which is a blade pole, so a transmission pole, which is taken from using a single upright repurposed wind turbine blade. Okay, so just a little refresher, and everybody has their own variation on the waste hierarchy, and I really liked the previous presentation one because they kind of stacked in a lot of things at the top that aren't on my one. So we've had already today, we've had repair, but I think refuse is R0, which I think was a really, really important one. So we're sitting near the top. If we look at repurposing, we're not at the top, but we're close to the top of the waste hierarchy. But some things that we need to think about for all these solutions is, okay, we have a waste hierarchy, and but if you think from a full life cycle perspective, it's not so simple. And I think some people have touched on that today. I think a very interesting example is landfill. In fact, if you put things through an LCA, depending on how you define your impacts, landfill can actually come out as quite a good solution. Because, of course, it's very little emissions to the air, there's almost no kind of chemical toxicity. But if you don't put in land take, you're not going to see the negative, you're not going to capture the negative side of landfill. And this goes for everything else. Some of these solutions are good for low material input. so generally the things that are near the top. Some are better on emissions, whether it's air or water emissions. Some are good for energy inputs, but maybe they don't recover as much of the material. And some have high residues. So it's difficult to capture this, and I think the waste hierarchy doesn't always serve well in when we're looking at trying to capture the overall environmental performance of any end-of-life technology solution that we have. So I'm going to now just take a little look backwards on a repurposing case study, going from a blade, which actually we don't even know how long a service this had in its first life. And again, this is one of the other problems we face, is that we often don't know the condition, let alone the material inventory of what we're faced with. I would say this is one of the benefits of repurposing as an end-of-life solution, in that it's not as important because we're not using it as a material feedstock, we're using structural property. However, it's still advantageous to know what you're dealing with in terms of materials. Anyway, so how do we get from a blade at end of life to a structurally repurposed product? And that was one of the outcomes of our ReWen project, was the Middleton to Youghal Greenway Bridge, which is located in Cork in Ireland. So this is a public pedestrian bridge. It's rated for an emergency vehicle, so it can take a 10-ton vehicle crossing this, even though its primary purpose is a footbridge. Okay, so what do we learn from that? Well, blade data rediscovery is costly, and there was a really good debate earlier today about, wouldn't it be great if OEMs shared their blade material? I think it's clear OEMs are not going to share the blade material, and in fact, even worse, that blade material is lost. Blade designs are lost. So if you want to you find out the detailed structural design, you have to reverse engineer. If you want to find out the materials, you're going to have to take tests. There's been some work done on this by Decon Blades, so we have materials passports for certain families of blades, but it's expensive. It takes time, it takes money. And maybe it's not always necessary, so that's the other thing. So when we repurposed, when we did our bridge project, we started with taking a blade, carrying out a 3D scan, and then fitting a geometry. So basically recovering the geometry, and that takes time and effort. Extracting coupons, burning away the resin, looking at the fiber layup and trying to peel off those layers one by one and look at what the structure of the blade was in terms of the laminate. Looking at the internal geometry, of course, as well. And then doing a series of destructive and non-destructive tests, including taking one sacrificial blade. So the bridge has 2 blades, but we had 3 from a turbine. So one of those blades was put in to a test rig and was ultimately tested to destruction, just to prove for that initial demonstrator the ultimate load strength of the blade. So what can we do about that? So just to kind of put some ideas in the air, some of the things we can do are trying to streamline that blade assessment process. Obviously, if you do one blade from a turbine or from a family or from a model, you have a pretty good idea. If other blades are in similar condition, you don't need to repeat that battery of tests, all those tests again. Some kind of certification would be very useful, where one entity carries out a certification and then that's available to other people who want to use the same blade in a similar application. Having databases of the key characteristics. So as repurposers, it's generally structural information and geometry, but if you're involved in some other type of processing, it might be the material, so it might be the blade passport, it might be the material inventory that you need of the blade. But having access to those avoids repeated work across multiple actors in end-of-life processing and can basically help everybody. So data sharing is key. And then speaking specifically about repurposing is coming up with designs that are scalable, which is something I think everybody's interested in, and hopefully mass producible and non-bespoke to the best extent possible. The second lesson, and again, I think this is familiar to everybody in the space, and apologies, because these are kind of imagined trajectories of the blue line is kind of like a model prediction of what we would expect to come out of service, what blade, the volume of blades coming out of service in Ireland over time. But we know, and especially in small markets, and this is one of the unique qualities of operating in a relatively small geographical location and an isolated geographical location like Ireland is that it's an island. Transportation on and off the island is hard. It has a border on the island as well. So you have transboundary if you want to access 1/4 of the area. These are things that I'm sure, you know, and myself and Andrew have been talking about this as well. So the supply is spiky, and that doesn't really help for operating at scale and predicting volumes. You know, that kind of spiky red line gives you, you know, some kind of imagined idea. You may have a large farm that comes out of service, gets decommissioned, and a very large flow of blades, and that can very quickly overwhelm a small operation. The only solutions to that really are, you know, transport, which costs money, brokerage, storage, but being ready, being prepared, having the data on hand so that there's not that lengthy run-in time of a battery of testing, you know, and sharing that information in a repository is something that would help streamline EOL downstream solutions. And then the third lesson was that location is really important. And again, this references back a little bit to some of the problems that we have in a relatively small market. Moving things around is expensive, and the emissions, as I'll show later on from the LCA study, the emissions are also important as well. So what you really want to avoid is you know, shipping blades either intact or cut down from one location hundreds of kilometers to another location, doing something with them, processing, and then maybe shipping that again hundreds of kilometers. It adds expense, but it also adds emissions. And those the cost side of transport, so not just the emissions, but the cost is very, very heavily dependent on the size of sections, and that brings in the whole issue of cut on site, or cut early and store, or do you preserve the structural value by minimal cutting and then cut later? So these are all trade-offs that you have to make. And then I would say the final thing that we learned is that, you know, trying to keep things local is generally the best possible solution. Generally, it'll cut down on the transport emissions, but also I think it's important from a sustainability perspective that the value, so any added value that's going on in terms of fabrication, refinishing, and in fact, whatever value the finished structure gives, whether it's a bridge or a blade pole, is something that's putting value, or a noise barrier, that value is kept in the local area. I'll just take a very short aside, but when we were doing our original research, this addresses a comment that came up earlier, but we approached a very wind energy skeptical group of people who'd been kind of negatively impacted by wind energy, and kind of showed them some repurposed designs, and it was contrary to our expectations, but they were quite well disposed to the majority of them actually. So even though they had very strong anti-wind opinions, repurposing opinions were not strong, with the exception of the case study I'm going to show you, because that's a piece of electrical infrastructure, which is, you know, again, probably after wind turbines, one of the least popular pieces of infrastructure that people want in their locality, at least in Ireland. Okay, so just to kind of go through just quickly go back through them. So challenges for repurposing and indeed for recycling, scalability. And I think when we talk about scalability, it's important to think as well, but scalability, we're always talking about scaling up, which is really, really important, but, you know, volumes are not what, you know, turbines are staying in service for longer. Volumes haven't materialized in terms of end-of-life blades as predicted a few years ago. So actually scalability downwards can also be an advantage as well. And I think that's somewhere where repurposing can come in, because it can be a little bit more agile sometimes. You need a big investment to set up a large production line and handle large volumes, but having something that can slot in can be useful as well. Reverse engineering, materials characterization, testing, we know, yeah, these are all slow and costly. And the impacts and the benefits are both very dependent on the blade type, where the blade is, and what the blade is going to do in its next life, and how far away that end use is from the location of the original blade. So that led us to start a new project called Airblade, and I'm just kind of go through what Airblade is doing now. So Airblade was trying to address those challenges by going back and looking at how can we develop some tools that would ease some of those barriers. So what we imagined as the kind of use case of Airblade would be that a designer who wants to build something, maybe it's an architect who wants to build a noise barrier even, for example, they might have a specific dimension in mind, and they have a specific location of applications. So they have a client who needs a noise barrier, particular latitude, longitude, location. And if you have a database of available wind turbines, blades, and the dates at which they are expected to come out of service and be decommissioned, and if you also know something about those blades, so perhaps those blades belong to families where you've already reverse engineered them, you'll have the information you need to inform that client of what blades match their application. So a client can search our blade database by location, by blade dimensions, and we also have condition ratings, which I'll come to in a while, and select the blade that will match the application. And then it has owner and operator details as well. So the idea of this is to try and match, find for every application, find the best suited blade with a view to minimizing those transport emissions as well. Because if you can source a blade that's near the end use, then you minimize the emissions. The second part is trying to reduce and streamline the need for the very expensive reverse engineering. So this is actually a mock-up of the tool. So the actual production tool is on our website. I should just mention actually the tools. So the tools are available on request. So if you want to try out the website, please just get in touch with me afterwards and we can open it up for you. This is something that can be done at the point of decommissioning. So a blade is taken down. So this is for a blade that's on the ground. Either the decommissioning contractor or a potential recycler, repurposer can go in and very quickly do a visual assessment on the blade. So this is organized by section, blade section and condition, and rate the sections, log the condition, just looking for visual evidence of small cracks, large cracks, delaminations, and there's drop-down menus in this to just allow you to very quickly work through the blade. That then gets logged and tracked in a database, and then that specific blade is tagged to those properties so that somebody, when a repurposer comes along, they can select the condition, the overall condition rating for their blade. We hope that this will go to reduce the need for extensive testing particularly in the case where we have good knowledge of how those blades perform in structural applications in the first place from previous experience. And then the third tool, which I'll talk about in the most detail, is a life cycle analysis tool. So the idea here is to have a simplified LCA tool, so not a full LCA, which takes a lot of time again, and that it's informed by the actual use case. So taking the actual blade and taking the actual application, end-of-life application, putting those together, it can calculate the transportation emissions, it can estimate the emissions associated with the processes, and generate the circularity and impact metrics for that particular use case. And we would hope here that the goal is that it would feed forward into certification and reporting, support reporting requirements in terms of ESG as well. So everything you see in the dashed line on the screen is within the scope of the LCA. I would say that what we're doing here is that we have inputs. So these are the material inputs for a repurposing product. So if it's a blade pole, we're going to need to do some refinishing, coating, fixings. We're going to need some steel. We also then have a displaced material, and this is something that what we're replacing. And this is really the R0 of the previous presentation. So what are we actually replacing with this new product? What materials are we avoiding extraction of in the first place? And then also an avoided process. So if we didn't do this, we have some counterfactual scenario where the blade gets landfilled, and what is the benefit over the counterfactual disposal scenario. And then it just works through the life cycle of this product, in this case a blade pole, manufacture, a 60-year lifetime we've assumed in this particular case, and decommissioning, and all the preparing, transporting, installing, maintenance, and decommissioning that needs to be done for that. Okay, so let's go into the blade pole. So we took a specific example. So this is actually a detailed life cycle assessment. So this is a full life cycle assessment which was used basically to develop the simplified assessment which is embodied in the tool. So we did this actually using the full LCA approach. So we imagined a use case where a client has a requirement for a 15-meter electrical distribution pole. Location, County Tipperary, Ireland. It's about 100 kilometers from the blade location. And then they go into the database, they find, okay, V52 blade is coming out of service. We expect a high condition rating, and that this would be suitable to repurpose as the main structural component of the tower. The processing will be to take a 17-meter segment, so there will be some process inputs and emissions associated with that. This is also transportable on a vehicle-trailer combination, so again, it's cheap to transport, so it's kind of a good use case for this type of blade. And then finds suitable blade locations for the repurposing site. So this is the idea behind the LCA. The most important part on this screen is really just to look at, again, we have our scope in the dashed line, but the two red boxes on the right are what is not in scope. So if we're doing a blade, if we're doing a distribution pole, there'll have to be some cross arms to carry the conductors. We don't include those because those would be included in the alternative product, which would be a steel tower, so they're common to both, so they're not included. And we actually don't include the post-end of life beyond the actual decommissioning on site, so we don't include that. But again, we wouldn't include that either for the actual alternative scenario as well. So we maintain consistency across the two. CIMA Pro and EcoInvent, kind of global, they're industry standard tools that are used for a full LCA study. So we use those in order to carry out the LCA. These are the kind of inputs. So we have a series of non-transport process inputs. So we have cutting on site. So for this particular example, we took a wet circular concrete saw. We have simplified the estimation of the blade segment weights. So basically using kind of these are methods that, regression estimates based on power rating and blade weight, and then where you're cutting from on the blade, we can estimate the material mass, how much drilling is needed. Again, these are going to create energy inputs. We have crane operations on site as well. And then coatings and sealing. So refinishing the surface is going to require more material inputs. So we have paints, resin for repairs, and adhesives as well. In terms of transport, transporting the actual unit to the site, so we're saying it's a 858 kg blade pole moving 100 kilometers. So it's got two movements from wind farm site to fabrication location, and then from fabrication location to the actual end-use site. Transporting concrete has to be included as well, and then the transport of all the other materials that are required as well, so coatings, adhesives, and any other materials that are needed. And that is also for the maintenance and the use phase of the project as well, not just for the installation phase. So this is for the lifetime use. So in-service maintenance is included in that as well. For installation phase, concrete is needed. So in this particular design, the base of the blade section is actually filled with concrete, so that will increase the embodied materials in that particular design. Excavations on site, so a hole is excavated in the ground, and then there's a backfill of concrete there as well, so there's more inputs there. And then crane use on site as well, and this is something where it differs from the conventional structure, because in a steel monopole, which is our alternative scenario, it's a much easier on-site operation. So this is where a blade pole would be at. This particular category is where a blade would be at a disadvantage compared to a conventional structure. Maintenance, decommissioning, so 10-year inspection frequency, and again, there's going to be some use of materials through the life cycle in terms of just maintaining the surface and maintaining the condition of the structure. And then at decommissioning, dismantling again on site. So we include on-site decommissioning, but not post-decommissioning end of life, end of second life in this particular study. The counterfactuals, so what we're replacing is a conventional steel monopole tower. It's a particular grade of steel. It's the grade that's used in transmission infrastructure, compliant with Eurocode 3. The dimensions are given here, so it's basically a slim steel cylinder. There are other designs that could be used, so it could be a concrete tower, or it could be a composite tower, or it could be a lattice tower as well. And they'll all have slightly different requirements in terms of materials. And then what we're avoiding, in this particular case, we took landfill. So what would happen to the blade if it wasn't repurposed? We assume here that it would go to landfill, but of course it could be compared to some other end-of-life solution. Okay, So here are all the numbers. They're all, so each row is in a different unit because each row corresponds to a different category of impact. So just moving along the rows, we have greenhouse gas emissions, which is probably the most, one that people look at first. So that's in kg of CO2 equivalent. But we also have human toxicity impacts, and these are calculated by the EcoInvent database. Mineral depletion or mineral resource scarcity. So the more materials you use, the higher you score on that. Fossil resource scarcity, so that is strongly related to the CO2 emissions, and that's generally coming from transport, and fossil fuel depletion. So when you tot up all the life phases of the blade pole and total them, you get the column that's in orange. Then the counterfactual scenario is in the next two columns. So you have steel tower, which is the alternative product, and a blade landfill, which is the alternative disposal scenario. Just to note, you can see that landfill, in fact, doesn't score very negatively on this. And again, this is, it's a very low material input process. You transport the blade to the landfill site, and not much else needs to happen. But land take isn't included in this. So this is probably making the alternative scenario look actually quite good. And so it's probably quite conservative, actually, in this sense, because we haven't included land take as a category of impact in this. But you can see there's a benefit of the blade pole over the alternative scenario across all the impact categories. And when you tot it up, what you find is really what's mattering the most here is that foundation work, the concrete that you would fill the base of the pole with, and the crane operations on site. Those are the key contributors in the case of the blade pole. It's also, I think, important to note here that this has kind of got a product perspective. So we can look at the life cycle impacts and benefits of two different products, but a decommissioner might take a slightly different approach. So because some of those benefits will accrue to the second life owner, not to the decommissioner. Transport distance is also really important here, so there are key influences on our LCA. So trying to get the local applications is really important there. I think this is a flexible approach because it can allow people to explore different scenarios, different use cases, different end-of-life usages, different blades. And that's the end for me. I just want to quickly flag up a couple of things. Firstly, we have a second special issue in the Sustainability Journal on wind turbine decommissioning, dismantling, demolition, recycling. We'd love your reuse and repurposing. We'd love your contribution. If you're interested in publishing a paper, you can get in touch with me or scan the code there. And you can find out more about these projects on airblade.ie or re-wind.info. Thank you.
Yes, thanks for the interesting presentation. I was wondering, of course, we come across the same problems, and with the testing data, for example, would you imagine the database to be open source, or is it, I don't know, paper blade info, where, for example, other repurposers could also upload their information and get paid back in the long run?
Thanks. That's a really good question. But firstly, I think we're open to anybody to try this out. When we did this, so our funding for this was very much kind of pushing us in a direction of commercializing it and trying to turn it into a service. I think the problem with that is that it's of more benefit the more open it is, because you want people to use it, but it costs money to operate it. So one model we had was the kind of that you would basically get some kind of limited. So maybe we supply the geometry free of charge, but then say, okay, if you need to use any further detailed structural models, or maybe get the condition ratings, that you have to pay for those. So we haven't really figured out how to do this, but what I would say is, if anybody's kind of interested in using it, the more data it gathers, the more useful it is to everybody. So. Yeah, I don't have an answer, but it's the same problem we all face, isn't it? Yeah.
Let's schedule a talk in the future to talk about this.
Hi, I have a question for the Earblade LCA tool. I want to know what's the original context for the database. I mean, because we all know for different types of the database, it may cause the different results. Let's say if we consider in the Netherlands and in the Belgium, the electricity component can be different. So I want to know whether this tool can be useful for the other countries, except the.
Thanks. Yeah, that's a really good question as well. So yeah, the electricity mix is going to have an impact. So at the moment, that part of the tool is specific to Ireland. So it only looks at Ireland mix for electricity, but there's no reason why we couldn't easily modify that, and that based on the location of the processing, that it chooses the local electricity mix. So we need to keep this simplified for this tool because it's not a full LCA, and providing a full LCA would require a database, which would lead into licensing, commercial licensing for these products is as anyone's used them, it's expensive. So we also want to keep it simple so that it basically can be used to very quickly run scenarios for somebody just looking at a decommissioner can look at two different scenarios. Maybe it could be something like, move to Belgium and cut and then install as a product there. It would be nice to be able to do that, yeah.
Thank you very much for the presentation. Yeah, really interesting to hear repurposing from your perspective. My question was around the Blade database, because I can find the sort of the raw data, which probably lays behind this platform, but then I would also encounter, for example, that we know the turbine model, but especially for like the first generation, for I don't know, like a Nechmicon 54, that could have 6 or 7 different independent blade companies that made like these 26-meter blades that have all gone bankrupt in 2001. Have you found the data, or would I encounter the same issue on your platform?
So we haven't found all that data.
That's a bummer.
So yeah, and this is the big problem. The blade data discovery is very, very laborious, very expensive, and I suppose what I can say is that when you begin to look at it, and maybe we're a little bit more fortunate in Ireland because it's a small market. It was always a little bit more consolidated with fewer manufacturers. That if you tick off the kind of top 5 to 8 blade models, you've got most of the fleet, and maybe that wouldn't be the case in some other areas.
Yeah, because I wonder if there is maybe, because usually once decommissioning starts happening and stuff starts coming down, then there is something of a label somewhere, and you can find out more, and then with some backwards engineering, you can sort of put all the pieces of the puzzle back together. So if we then would be able to put that data into platforms like this, then we can sort of create this network. That would be really nice.
That's the ideal. Yeah.
Thank you for the presentation of the business case. I have a question on probably you have done studies in this direction, but you have not touched upon this aspect. What is the social acceptability of your products in general for the repurposing business case? Because you are quite constrained in terms of geometry. Of course, you are constrained from the original product. You are not really refunctionalizing intrinsically the structure, but you are finding a new application for the same structure. So I think that social acceptability should be an asset here. Should be could be a barrier. Let's put it this way.
We looked at this, but I don't. So we carried out some. I mentioned that we had an exercise with a community group who were quite opposed to wind energy, and the results were very positive, but that was only one engagement. In general, I would say, and this is just kind of only really based on feedback and kind of anecdotal, it's not scientifically collected, but that generally the public responses to these kind of projects are very, very positive. People generally like these kind of repurposed products. I think it's, when there are products that benefit the community, it makes it a lot easier. So if you have something nice like a public rest area, benches, sculptures, these are all good things. If it's a transmission pole, perhaps maybe not so positive. But I do think it's important that it needs to be worked in. But it's difficult from a methodological point of view. How do you kind of score in that? Yeah, are you going to talk about it tomorrow? Yeah.
Thank you. Yeah, that would be very interesting to see.
Yeah. So.
Because as long as there are few examples, okay, but when there will become many, and I hope for you and for the community that will become many, it will be interesting to see. Thanks.
Yeah. So Angie's talk tomorrow will focus on that. We'll include that.
Paul, thank you very much indeed. That's very detailed, very informative. So I'd like to welcome Matthew Geraghty onto the stage. Matthew has got something very interesting to offer us all here. He's got a database, but he's going to explain everything to you and show you what he can do to help us to be engaged for the end-of-life blade processing for owners and OEMs.
Excellent. Thanks very much, Andrew. Yeah, hopefully you've saved the best to last. I think there's one more coming after me that's going to be just as good. Very nice to meet you all. My name is Matthew. I am the CEO of Rewind, and today I'm going to talk you through a little bit about what we do, but also we work with some of the biggest owners and operators in the industry, and I want to show you a bit of their perspective on blade recycling and how they're working with us to choose solutions for end of life for their blades. But first, a little bit about me and about Rewind. So my name is Matthew. I'm from Ireland. I live in Norway. I apologize for my accent and for Paul's accent. So hopefully everybody can understand this presentation. Yeah, and Rewind, we are a spin-out from DNV, which is a company many of you guys might be familiar with. And basically we provide a software solution to help our customers optimize the end of life of their wind projects. We're not just focused on blades, we look at everything to do with decommissioning and circularity for wind projects. So very quickly, what is Rewind? So we build ourselves as the ultimate end of life decision-making tool for renewable energy. We help our customers to optimize their decommissioning costs, to help them to size bonds for new projects as well, try to build circularity into design of those new projects. We've also built a database and mapped the entire supply chain for decommissioning in the wind industry. So we've got 1,000 providers worldwide in there now as well. I'm going to show you a demo of it in a minute. And yeah, finally, we also provide a breakdown of the materials that are within your turbines, including blades, although, spoiler, it's not going to be as detailed as some would hope. So I'm going to talk you through that in a bit of detail in a minute. So who do we work with? So typically we're working with the developers of these projects who are looking to comply with various different regulations, particularly in the EU. CSRD requirements and Net Zero Industry Act are requiring that you report on material inflows and outflows of your assets. So understanding the material breakdown of those assets is really, really important, not just for the blade recyclers here, it's also important from an owner's perspective. And then we work a lot with operations managers or asset managers looking at managing projects towards end of life. And really relevant to this room is we work with a lot of customers who are trying to rapidly develop different scenarios for managing their projects at end of life. And that includes choosing the right providers to partner with, to manage those blades, and to manage the other components of their turbines at end of life. And yeah, just to say who we work with 23 of the biggest owners in the world, and we're very proud of this. Companies existed for a year yesterday, and we're already working with some of the biggest names in the industry. And just in that last year, I mean, we started this 3 years ago, but just in that last year, we've learned so much from these customers. And what I'm hoping to give you guys today is a bit of a perspective as how these owners are assessing end of life and assessing blade recycling options. So with that, how do owners actually choose a blade recycler. The first thing I would say is that most owners don't choose a blade recycler. Most owners choose an EPC contractor and they set some employers' requirements in there, and what happens to the blades is pushed onto the EPC contractor. But in some cases, they do actually look deeper than that, look at who that contractor is subcontracting with, who's going to manage that waste at end of life, and we see some of our customers making real decisions about their tendering process, going for a more expensive option because it has a higher circularity rate, for example. And this means that they need to assess kind of 3 critical things when they're looking at choosing a blade recycler. Number 1 is cost. Number 1 is always going to be cost for these owners. That is not going to change. Number 2 is circularity, looking at a circularity rate, and then also looking at the net emissions for these projects. These companies exist to reduce carbon emissions. Therefore, it's a huge decision-making factor when it comes to end of life for them. And this means that they need metrics that they can measure these things on and compare on. And that means decommissioning costs as well as the residual value of that asset. Is there a second-hand market for these components? The actual recovery rate of those materials from a circularity perspective, and also the avoided emissions due to producing second life products instead of sending them to landfill, as Paul illustrated. So basically, Rewind is trying to help our customers assess these factors and make decisions rapidly and make them with confidence. So I'm going to walk you through an example in Rewind. I'm going to show you exactly how our customers use this product, and hopefully it'll give you a little bit of an insight as to what kind of information they're looking for. So, here we are. Nice. Okay, sorry, this is our website. If you want to learn anything more about us, you can go to rewind-energy.com. But if you're a user of Rewind, basically what we do is we break down decommissioning costs, materials within your portfolio of turbines, average circularity rates across your project. But typically what you will do as a user is you come into our database of turbines. We've got over 250 turbine models modeled to date. And what we provide is this high-level breakdown of the materials within the turbine. So across the entire turbine, but then also within the blades, but we're not just looking at blades, hub, nacelle, tower, and overall. And anticipating the questions I'm going to get after this, how do we model this? So we are a spin-out from DNV. We're sitting on 30 years worth of data that we've been collecting. That's our starting point. But as we know, the OEMs don't give out this data, so even DNV doesn't have this data, and their certification department isn't allowed to share that data, even if they had it. So we have a 2-step process. We use a loads-based model through a program called Renewables Architect that DNV and Bladed has been producing as one of the original digital twins for the wind industry. We produce a breakdown of the weights of each major component, and then we have knowledge around which suppliers each of these manufacturers use, and we apply a breakdown of material based on data sheets we've got from those providers. And then as a final step, we manually check this against any actual data sheets we have from our customers. And for 99% of owners, this is detailed enough data for what they need to make decisions on. It might not be detailed enough for you to decide what recycling process works best, but it's what they need to know from a regulatory standpoint and what they need to report on. We don't just do this for the turbine, we also do it for balance of plant. So here I've built a fake project in the Netherlands, for example, and we do material analysis across the turbines. I've got 2 different turbines types in here, a G47 and an M117. We look at breakdowns of materials in the balance of plant, the entire wind farm, and then also in line with the EU Critical Raw Materials Act, we're breaking down the critical raw materials in that asset. Obviously, big focus on magnets there. Any company here that needs to be CSRD compliant from next year, if the EU ever signs off on that, then you're going to need to understand the material inflow and outflow of these materials. So this is kind of the inputs and the data that we're providing with Rewind, but how does our customer actually use this? Well, what they do is they create scenarios, and here's a few I've created earlier. So for example, let's take a base case of a decommissioned scenario where they're going to landfill the blades. What we do is we've got this database of, as I said, 1,000 different providers worldwide. I actually think I have that open already. You can see our database here. We've got everybody from Second Life facilities, so people buying and selling second-hand turbines and components, material processing facilities, which are the actual recyclers, like people in this room. Many of you are in our database already. If you're not, I'm going to tell you how to get into our database at the end of this presentation. The EPC-style decommissioning providers, and then we also handle offshore, so we're looking at what facilities are available at ports. And basically, you can click into any of these companies, see who they are, where they're based, description of their process. We're trying to gather information on their capacity, on any certifications they have, and trying to build up this database more and more as we go. But basically what you can do then is you can select who you want to handle your materials. So in this case, we've chosen a local metal provider in the Netherlands. We've selected landfill for the blades, and then on the concrete side, we've selected another local provider. But you can click to change whoever you want to add to your project, for example. And then what we produce is the expected decommissioning costs. And again, I can't stress enough, this is the only thing that a lot of owners care about. This is a high-level breakdown we're looking at based on the scope of decommissioning in terms of every single part of that decommissioning project. But what our customers are quite interested in is this disposal cost. So that's essentially your gate fee for getting rid of these turbines based on landfill in this case. So we have an assumption for the cost of landfill in the Netherlands. But also then the transport, the removal costs, the scrap value of the asset are all really important parameters that our customers are interested in. So how this all comes together is our customers make multiple scenarios, they compare them side by side, and then we have a comparison feature. I've created 3 scenarios here. The first one where you're recycling locally. The first case is where you're landfilling. The second one is choosing an international provider in Norway. I live in Norway. Jenkraft are a company that I'm sure some of you know. And another one looking at CRC here in the Netherlands. And what you're able to do is compare the expected circularity rates, the expected costs from those. I've pulled out specifically the cost of blade disposal here versus the cost of removal of the turbines. In this case, cost 200 grand to ship a couple of turbines to Norway. Is that worth your time, or are you going to try and find someone local? There's also a question, is that even feasible with waste codes, etc. But our customers, again, looking 5 years out, are looking to plan theoretical scenarios as well as kind of real ones. So basically that all comes together in a dashboard view. We have managers who are looking at trying to build a scenario database or a strategy for their entire portfolio of assets. And what would have previously taken a consultant 6-8 weeks to do to write you a report on this, we can do in, I showed you there in, I think, 5 minutes. It can take 10-15 minutes to put together one of these. And that's kind of our value prop to these customers. We're updating this data every 3 months. It's such a rapidly changing environment and such a rapidly changing ecosystem and supply chain that our customers just need to be on top of this when you have these projects that are reaching end of life. Okay, with that, I'm going to switch back to the presentation. Yes, perfect. And this one. Yeah, so we get a lot of questions in terms of what our tool can't do. And I've pulled out a couple of things here that we get asked all the time. We collect every single piece of feedback we get from our customers, and these are the top questions that come out time and again. But what is really interesting for the people in this room is all of the time we're being asked, what's the capacity of your facility? How much can you actually handle on an annual basis? And it's a black box right now for a lot of our customers. There's a lack of trust that we see that the industry can actually handle what they're going to be decommissioning. But also, the amount of times I talk to people in this room or outside of this room who are like, we can't get enough blades, there's kind of a disconnect there right now. The second one is, are there more attractive options in different countries? Is a very interesting one that our customers ask. And what's the emissions associated with that if we have to transport these to a different country? So I've got about 2 minutes left, so I'm going to show you just 1 or 2 very quick case studies on this that I think you'll find interesting. First one being ENGIE in Germany. We've worked with them on some of their decommissioning projects Their biggest struggle is trying to understand the responses to their tenders and the quality of those. Price is easy enough, right? But they can't understand what is the difference in the quality of the recycling process that I'm getting from one tender to another. It's all EPC contractors saying, I'm going to recycle your blades, but what does that actually mean? And being able to compare those side by side has been really difficult. They've used our platform to send tender documentation directly and try to engage and compare them side by side. I won't go through this one, I'll send the slides afterwards, but basically in Ørsted's annual sustainability report for last year, they've been using our tool to automate their materials reporting for CSRD. What's really interesting is on the emissions side, again, working with Statkraft on some of their projects reaching end of life in Norway. And there we did a high-level LCA analysis of various different blade recycling processes to help them try and make better decisions around who they want to partner with and who they want to work with. This was comparing a theoretical facility that was the same distance away from the site, but with different technologies. So looking at a base case of landfill, cement co-processing, mechanical grinding, microwave pyrolysis, solvolysis, and pyrolysis. And I'm sure you guys have seen some of this before. When you consider the recycled products, we see that mechanical grinding comes out as best in terms of an LCA assessment for that project. We then, and the reason being that pyrolysis uses a lot of energy, although some facilities, if you've got very low carbon electricity using an electric or microwave pyrolysis technique, you can actually achieve much lower emissions. And we've done the same for SSE as well. They looked at 5 different sites, looked at shipping blades to Europe versus processing them locally in country, in Scotland. And what we've seen there is that the transport emissions can become significant, although there is significant economies of scale when you're looking at much larger sites. If you can transport in bulk, then the impact is a little bit less than having to ship a couple of blades in a container overseas. I'll skip through that one. My last ask, because every good presentation has an ask at the end, if you're a blade recycler and you're here or involved in the decommissioning supply chain in any way, we would like you to be on our map. We can get you in front of big customers who are trying to make these decisions day in, day out. This QR code will take you directly to our website where you can fill in your details and we'll reach out and get you up on our system. And then the very last thing is if you are an owner, we're a startup, we're trying to grow, we need more customers. So if you'd like to try out Remond, let me know. It's a long shot, we're also fundraising. So if anybody knows somebody with loads of money that they want to give us, I'm also very interested in that. So thank you.
Hi, thank you. Very impressive presentation. Congratulations. I have one question about this. Everything free is cheap. How we can be sure that your data is accurate?
Yeah, so we publish our data sources directly in the tool, so you can see exactly where it's coming from. We also have tried to make our tool as flexible as possible so that you can enter your own data as well. So, for example, we have crane data that we collect from like crane suppliers for decommissioning of your turbines. If you have an agreement, a frame agreement with a crane company already, you can overwrite our data and see what that does to your outputs. But yeah, we try to be as transparent as possible with everything that we provide in there.
Excellent, thank you.
Yeah, go ahead.
Yeah, thank you for the presentation. Quite interesting. I had a question about your data acquisition. Can you imagine that you get in your database the quite old blades where DNV and GL certified 20 years before and nobody is there, and may you have it in your computers or in the storage, and it would be help to have such informations there. I'm not known if it's possible.
Yeah, so we've modeled turbines from 300 kilowatts all the way to 22 megawatt offshore turbines. Now, again, some of that is based on real data we can get from DNV, some of it isn't. The certification data we're never going to be able to have access to because that would kind of defeat the purpose of DNV's certification business. But for those really old turbines, we have found that it is easier for us to get our hands on that data than it is for the existing fleet that are being sold. For example, there's kind of a statute of limitations on when that data can become available. Again, some of the stuff that was like hard copy, we're never going to get our hands on, right? But we feel confident in our models. We've also done a little bit of work with some blade recyclers to validate our models as well, to kind of weigh components and compare them to what our model comes up with as well. We haven't gone quite to the level as some people are talking about today, but we've done some validation.
That would be the second question. As you updated as re-engineering from the recyclers.
Exactly, and we're working with. Sorry, I can't say. We're working with some people to take that data directly into the tool where they've done that analysis as well. Yeah.
Thank you.
I have a stupid question. If I misunderstand, please correct me. Because I remember from the presentation given by the GM from the Wind Europe, he mentioned that the non-fuel is already banned in the Netherlands. But in your models, I see the feeling is still there. I want to know, is there just a comparison or?
Yeah, that was just for comparison purposes. I created that scenario this morning. You can select landfill. We don't take into account legislation in any of the restrictions in the tool. It's up to the user to define what their parameters are. Yeah.
Thank you.
Yeah.
Matthew, excellent presentation. Thank you very much. I saw the data. Roughly incineration and mechanical reuse was sort of comparable, if I got the numbers right. Now I'm wondering, you certainly take into account the energy gain when you incinerate. Now, when you compare with new products, do you look at what, like, you may replace steel or some other virgin materials? How is the calculation done on the?
Yeah, exactly. So it was cement processing rather than incineration, although same, right? So in that case, I find the boundaries of LCA calculations also a topic of debate. We could decide where that lies. So we end the boundary at the production of the second-hand material. So whether that's a fiber or whether that is like a reused product, etc. And there we saw that by reducing the carbon intensity of producing cement and offsetting the material that's going in, that came out quite comparable in that case. I would stress, though, that they're all highly location specific and facility specific. So looking at a mechanical grinding facility there that was in Norway could be different to looking at one, say, in Ireland, where you've got different fuel mixes. The one looking at pyrolysis process there was a behind the meter, behind an old hydro plant, so they had extremely low carbon electricity, for example, in that case. So there are nuances there that could make a big difference.
Matthew, thank you very much.
Excellent. Thanks very much.
So I'm pleased now to welcome our penultimate session. It is led by Derek Berry, and he will follow on by adjudicating on our final panel.
All right. Are we good? Yeah, we're good. Thank you, Andrew. I wonder if we should keep this going and just fake an Irish accent now and have 3 in a row. Probably not. I also feel a little inadequate. I have an interesting presentation, but no ask at the end, so it's not as good. I will say this. I'm going to present something that's a little interesting in the fact that I'm presenting data that I worked on a project fairly recently, as little as a year ago, but I have switched positions in that time. So I've been at DTU Wind Energy in Denmark. I live in Denmark for the last less than a half a year. My entire career before that, 30 years in wind, was in the United States. In the last 16 years with what's called the National Renewable Energy Laboratory. Although it's not called that anymore, the new administration decided to take renewable out of the name of the Renewable Energy Laboratory. So that's kind of sad. But now it's called the National Lab of the Rockies, or NLR. But because I'm presenting data from a previous position, I am careful to make sure that I am giving credit where credit is due here. And so all of this was actually funded by the United States Department of Energy in the previous administration, and carried out by 3 laboratories, what was the National Renewable Energy Laboratory, NREL, Sandia National Laboratory, and Oak Ridge National Laboratory. Great. And so I also have a page here just talking about a few things. I am careful not to present information that has not been presented before in some way or fashion. And so the reason I'm presenting this, though, is that the last, just over a year ago when we had this, the previous version of this conference, we're about to publish a new report on wind technology recycling assessment. And there was a lot of questions. I didn't present last time, but there were a lot of questions there for me about that new publication and the data in that publication. And so I talked to Martin, and we decided to present some of that data here, and that is still very, very relevant. But I also wanted to list down bottom all of the collaborators of the 3 laboratories there on the second slide here, just so there's credit there for all that they have done leading up to this. So basically, this is the report. It's report part 1, looking at assessing recycling technologies across entire turbines. It's not just blade, although I'm going to focus on blades here. This is part 1, which then would lead you to believe there'd be a part 2. And there was, we wrote that report, but then when the new administration came in, they said that's never going to be published. And so it has not been published, unfortunately. So I will focus on a lot of the data from part 1 and a little bit from part 2, even though I don't know that they'll ever actually publish that part 2. As I mentioned, this was the entire turbine of wind technology recycling assessment, but I'll focus on blades right now, and specifically on LCA. And I'm going to take a step back right now. I am not even close to being an LCA expert. I don't really do much with LCA. We had some great people on our team, both at Sandia National Laboratories and NREL, that did a lot of this work, and they're experts in LCA. So I will be talking about a lot of the results here. Some of your questions may be beyond. I've watched LCA experts. They're very, very smart. They don't always agree with each other. There's a lot of disagreement between them, and I've watched that over the years. But luckily, I've learned that Paul is an expert in LCA, so I can also rely on him today for expertise. When we started out, we had a lot of stakeholder engagement, and you'll see that we looked at all kinds of different parts of the turbine, the foundation, the tower, nacelle, generator, but the blades would all focus on. But you can see some of the industry partners that we have partnered with in order to get the information we needed for our research and for the LCA that we're going to go through, and that I'll present on a few topics today. We also did a lot with IEA Wind Task 45. So myself and Justine Boson at DTU, when I was at NREL, still lead that, and Paul's been a big part of that, and a few others in this room as well. So I will just start off with a couple of slides talking about volume. I decided to keep this slide there. This slide was I put together that had the projections of where the United States was going as far as wind energy deployment in the next 3 or 4 decades. This has changed, of course. There's been a slowdown or a destruction of what the path we were on, but ultimately in the United States, we still expect long-term to have quite a few, quite a bit of renewable wind energy and other renewable deployment. And so this will change. That it'll be the slope of that will change for a while, but I think we'll be fine long-term. And just kind of numbers here, in 2022, we were decommissioning. This doesn't change, actually, because this is based on what the turbines are already out there in the field. We were decommissioning between 3,000 and 9,000 blades per year in the United States, and we're expecting that by 2040 to increase to about 20,000 blades a year, and an average blade, 20 metric tons for the average blade weight. That won't change. That's going to happen no matter what's happening now in deployment in the United States. And then you'll see that most of the blades that we take down in the United States end up in landfills. And the vast majority still do. And as previous speakers talked about, there are different reasons for that. But there are some states like Wyoming, that's where those first pictures from Bloomberg came out of all the blades and landfills. They've actually have a landfill ban there, not so much that they're so concerned in Wyoming about recyclability and sustainability, but they were just difficult to move around, and they take up a lot of space in their landfills and things like that for any individual landfill. And so we are working on in the United States about looking, how do we, and an earlier speaker said, it's not going to be regulation in the United States that changes this at all. And at least in the near term. And so really it's going to be an industry kind of approach to changing this in the United States and around the world as well. So let's jump into LCA. So I want to talk about metrics first. So obviously, and I think Paul and Matthew and others have talked about the metrics for LCA. There's a lot of metrics that can be used, and different LCA analysis use different metrics. Some are economic metrics, some are greenhouse gas emissions, environmental, social responsibility, things like that. And so we had a lot of reasons or criteria that we used in this research at how we chose the metrics that we used in the LCA. One of it was looking at the Energy Act of 2020, which is back in the Biden administration that came out, and how that helped us understand what metrics are important for measuring the sustainability of wind turbine blades in this case. Talk to the stakeholders. We wanted something that was easily communicated, kind of well studied, and can be versatile. It can be used across many different system boundaries and things like that for the people that want to use this LCA. And so I'm not going to go through all of them. You can see some of the prioritized metrics up on the screen here. Obviously, greenhouse gas emissions is in there. That's something that a lot of people, like Paul mentioned, use, or is it Matthew, use greenhouse gas emissions. I think it's Paul. And then you can see the cost of recycling is in there as well, embodied energy, material yield, percentage of material yield, and others there. I won't go through all of them. And then we also had some other metrics that we considered. They weren't on that top list here. You can see like water consumption, human toxicity that Paul mentioned, and then some others, and some that I don't even understand. I couldn't even calculate the circularity transition indicator, things like that. But there are other metrics in there as well. So then I'm going to just jump in kind of a final push here to look at the LCA results, kind of what we learned for blades using the metrics that I just talked about and the boundaries that I'll talk about here. Evan Sproul, which was part of Sandia National Laboratory, originally put a lot of this together, and so I just wanted to give him credit there for a lot of these concepts and approaches here and how we present this. So there is the end-of-life positions here, or the choices at the end of life. We are focusing in the LCA that we went forth with from mechanical recycling down to the cement co-processing. And I know we talked about cement co-processing earlier today and whether that really is recycling, but in the case of this, we just used the values we had to measure it against other processes at the end of life solutions. And just to give you a sense of that life cycle inventory, what it looked like for anywhere from decommissioning blades, our boundaries were at the decommissioning through on-site reduction, transportation, the different types of recycling or different types of processing, recycling or not, at the end of life, and disposal. That was our boundaries there. And just kind of zooming in on cement co-processing, and we did this for all of them, but just to give you sort of the detailed mass balance and then what the inputs, the energy sources inputs and things like that. This is sort of how we approach every one of those type of scenarios, not only for the recycling processes, but for the decommissioning, for the on-site reduction, for the transportation, things like that. And so that's some of our background looks like. So these are pretty intuitive, some of them. So from mass yield results, obviously a landfill recovers nothing. But you can see that the mechanical recycling and high voltage fragmentation get a lot of that material back. And when I say secondary solid recycling materials or primary solid recycling materials, primary being recycled materials that go back into blade manufacturing, some sort of blade manufacturing, secondary that goes into other composite manufacturing. So you see just kind of what you get back, and some of them have the oil and gas co-products, the pyrolysis and microwave pyrolysis. We can use those for some other resin production as well, possibly down the road. I'm going to move on to greenhouse gas emissions, and some of our previous speakers also focused on this. You can see here that speaking of emissions, obviously landfill and mechanical recycling have very low emissions when it comes to greenhouse gas emissions, and others have pretty high because of the energy usage that is needed in order to get those processes done. But then when you add in the credits that you get, and this looks a little bit like what Matthew had put up there on a couple different scenarios that he presented here, those credits then, you'll see there's no credit obviously for landfilling, but you get certain amounts of credits from this LCA for the recycling process and the other processes. And so ultimately, we're able to put a number on what that greenhouse gas emission, kilograms of CO2 per blade, and this is per blade here, that you get. And so you can see that at the end of that analysis, cement co-processing, mechanical recycling, and microwave pyrolysis actually were kind of the net benefits on this one for LCA when it comes to that metric, greenhouse gas emissions. And then looking at technology readiness level, same y-axis, which is the kilograms of CO2. And you can see here that of all the different processing that we looked at, you can see that pyrolysis was pretty high TRL and moderate greenhouse gas emissions and results in high quality fibers. And then down bottom, mechanical recycling and cement co-processing, again, high TRL and pretty low greenhouse gas emissions. And then there's a large market right now. A lot of blades in the United States go to that cement co-processing, but there's sort of an uncertain market on the mechanical recycling and how to use that material, how to quantify the characteristics of those, the material characteristics, and how to put a supply chain in place to use those materials as well. And then looking at the variable operating costs, or the costs for recycling here. And again, you'll see here that cement co-processing and mechanical recycling have lower costs compared to the other forms of processing, and also have negative or beneficial greenhouse gas emissions there. So, and I'll finish up with looking at some case studies here. And in this case, we're looking at a glass fiber blade, no carbon fiber. It is I think a 47 or approximately 47 meter blade, and evaluating this blade. And so we're also I'll take a minute afterwards and look at a carbon fiber spar blade. So carbon fiber in the spar cap, and then also one with using recyclable resin systems as well, and compare those. And so what I've showed you so far was just the glass blade, the approximately 47 meter glass blade. We're going to now look at a carbon fiber spar blade. You'll see, though, that we didn't have a 47 meter blade. I think it was a 62.2 meter blade for the carbon fiber spar cap blade. And so it is a larger blade, about 1.5 times the weight of the glass fiber blade. But you can see there that we have carbon fiber there, a little reduced on the glass fiber and increase on the carbon fiber. So here you'll see we separated out into the carbon part of the blade versus the rest of the blade. And so each of the recycling technologies, mechanical pyrolysis, microwave pyrolysis, and so forth, get a grade. You can see it's intuitive here that when you recycle the carbon fiber spar cap in this case, on any one of these mechanical properties, the benefit that you get, the credit that you get of doing that is larger than you get for the glass, for the displacement of future CO2 for carbon fiber. And so you can see the difference. So if you have blades that have carbon fiber components, you'll have a better outcome in your results of LCA, and also on cost of recycling as well. I mean, certainly it is a better economical proposition to recycle carbon fiber out of blades than it is for glass fiber. We talked about that earlier in the conference here as well. And then I'll go back and look at the recyclable resin system. So you can see here we're replacing the thermoset epoxy resin system with a reversible thermoset resin system. However, this could be a thermoplastic like Arkema's Ilium resin system as well. We did that as well, and that had very similar results to the reversible thermoset resin system here as well. And then again, just side by side, looking at the solvolysis of a standard thermoset resin versus the chemical dissolution of a reversible thermoset resin system in here. And you can see that actually it has a little more on the greenhouse gas emission side on the chemical dissolution, but a whole lot more credit to, because of the type of material, the quality of material that you get back in that process here. And so we did quite a bit of research on LCA, on using future design of blades, recyclable by design, using new materials, and there is a pathway to having a better return on the investment in those materials for LCA and also for cost of recycling and things like that. So, and then finally, I have some key takeaways here. So right now, cement co-processing, mechanical recycling are really the near-term solutions right now. It's the higher TRL, the lower cost. However, they have severe limitations. And we talked about the severe limitations of the cement co-processing, but even mechanical recycling, as Niels was saying earlier today, you're not getting long fibers back. You're getting degraded material they can use in other processes, not blades typically, but other composite processes. And then just having the supply chain, it's not there yet, en masse for across the world, and we focus on the United States in this study right here. But alternative materials, more carbon fiber, and we see more and more carbon fiber, obviously in longer blades. But looking at recyclable resins and things like that can change the landscape long term. And so some of the lessons that we learned in the LCA here. So that's what I have so far. I just want to go through that quickly. Again, DTU is where I am now, but it's really an input of the National Laboratory Systems in the United States and the Department of Energy back in the previous administration that a lot of this was work was done. So thank you so much. Then I can get some questions. I know we're running short on time, but if there's a few questions, I'd be happy to take them. Yeah, sure.
I just wondering, since the comparing recycling methods, they are developed at the different scales. So how can you make sure the comparison is fair based on the results across the scales? Let's say for the microwave-assisted pyrolysis, it is still in development, but for the mechanical recycling, it's more mature.
So are you asking about the scale? We have some blades that were 47-meter blades and some blades were 62-meter blades, or are you talking about different scale?
No, it's like the process scale. Like for the mechanical recycling is very mature, so which means the processing is optimized, which means the carbon and electricity usage can be lower. Well, for the microwave assisted, that technology is still under development. So which means the processing is not optimized yet. So when you're comparing with different scenarios, what's the fairness?
This is a snapshot in time, no question. Everything we took was as it stood, this is about a year and a half ago, as it stood at that time. And so lower TRL that has a whole lot more development in front of it and may bring those energy costs down and may bring a lot of those costs down, that will change us long term, no question about it. Yeah, but we had our shot, our snapshot in time that we had to deal with at the time. Yeah,
so it's just the comparing at the current stage, right?
Yeah, exactly.
Okay,
no doubt. We did not look into the future to try to predict what that looked like. We would do more studies possibly down the road to kind of do that then and compare it to what it was now. Yeah, exactly.
Okay, thank you.
Yeah, thank you very much. Good question. Yeah, go ahead, Marcelo.
Very nice, very comprehensive. I have a curiosity about the impact of high-voltage fermentation.
Yeah, okay.
According to your data, it seems to be quite high, the emissions and the footprint. While in our experience, it requires pretty low energy
Okay.
to operate. We have one machine and all that. Small scale. But totally everything on the TRL is still low.
Yeah, right, sure.
But what makes the footprint so high?
This is where you're reaching the limit of my knowledge, and so the answer is I don't know. But certainly I can look back into, we have the entire report. And what I can do for anyone, and this is the same, I connected with some of you or others that were at the last conference and gave you the link to that report. I can do that as well and make sure you have that in your hand. I have that link. And so report part 1 is published. All of that data is in there, what we use, why it will have that higher energy input for that process. That I don't know, though. So I apologize, yeah. Yeah, great. All right. Other questions at all, or before we move into our panel, or?
Oh, Derek, that was actually tremendous, succinct, very informative, very compact, and full of energy. Thank you.
All right, sounds good. Thank you, everyone.
So we'll round off the afternoon with a panel that Derek is kindly going to moderate. And if we can call up the panel members, please. Yes.
Yeah, sure. Yeah, sounds good. All right. We'll just jump right into it then. That sounds great. And so I will sit here in a moment, but what I'd like to do is just take a brief couple moments and introduce the panel, although All 5 of them have given presentations today, so you have a general idea of what they do. But I just want to start with Andrew first. Andrew Billingsley is sort of the leader of this entire conference, our chairman, and keeping us on track and doing a great job with that. CEO and founder of Plaswire in Northern Ireland. And he's been doing this for 30 years and really kind of trying to merge waste management with sort of high-tech industry, bring that all together. And I think, Andrew, one of the things that you said last week on our call and even today was that the problems that we're facing, it's not like we have to compete against each other to get this done, really kind of collaborating, and we're not even close to being, able to attack all the challenges yet. But this type of collaboration, and as we're talking about today, but collaboration between our companies and our industry, in our universities and labs is really essential going forward here.
Absolutely, yes.
Perfect. Okay, so Andrew, welcome to the panel. I'll go to Pascal next. And so Pascal is from Switzerland, and you are the co-founder and executive chairman of Composites Recycling SA. You are a physicist. It says in your biography that you're a Swiss physicist. I'm not sure if that's different from other physicists, maybe. But a Swiss physicist. And one of the nuggets in Pascal's past is that he was also working on sustainable diamond production at one point in your life. Not anymore, though, right? Not anymore. Yep. So if you have questions about that, talk to him in the breaks. Yeah, sure. But that's one of his past passions, I'd say, in the past. So welcome to the panel. Joost de Kruger, welcome. And so the co-founder and architect for BladeMade. And I'm assuming that architect part is a big part of what you do, kind of what your presentation put forward is a lot of the architecture behind the work at BladeMade. And so you've been doing this for about 15 years, looking at the reuse of materials and things like that. The really impressive thing is that Joost was the Impact Pioneer of the Year in 2022. TEDx Amsterdam, who kind of is a curator of that impact program, and so you are the only celebrity on stage with us here today. So we are. Yep. Thank you. Thank you for being here with us. Yep. And I think it's probably good to note as well, and you're probably pretty proud of the fact that you have a lot of impact with mentoring students at TU Delft in the graduate program, in the architecture program. Is that? And I'm sure that's something that you probably value very much. Yeah. Well, welcome to the panel. Good. All right, Paul. I've been working with Paul for many years now through IEA WindTask 45. He is the head of energy engineering at, as he mentioned, University College Cork, UCC in Ireland. Also senior lecturer for wind energy engineering. He, as he mentioned, was one of the leaders of the ReWind network, the ReWind with the hyphen, not the ReWind without the hyphen, which we'll get to. Yep, exactly. Sure. Yeah, and the hyphen, I think. Yeah, well, yeah, exactly. So anyway, and as he mentioned, also the co-founder, and Angie, you're going to talk about tomorrow with Blade Bridge as well. And Paul was really has been and continues to be one of the key contributors to our IEA WindTask 45 for wind turbine blade recycling, leading one of our work packages in phase 1 there. So welcome, Paul, to the board here. And then finally, Matthew Garrity. And so, as he mentioned, he is the CEO and the founder of ReWind, coming out of DNV and using all of that knowledge and experience from DNV to really produce a product, as he just mentioned, fresh in your minds now, to help companies across the spectrum in the wind industry for end-of-life management and decommission strategies. You have, I think today, maybe right about now, is your 1-year anniversary of finding your company, I believe. Yeah, so congratulations. Yeah, awesome. But one of the things that I did see is that you have customers on 5 of the 7 continents. So unless you're working with penguins or the South Pole Research, I'm guessing one of those is Antarctica that you don't have any customers on.
No, nothing in Antarctica.
Okay, and the other one, I know you work with Canadian communities for, so it's not North America. I'm going to guess Australia is your other one.
We've got 2 customers. We've got 2 customers in Australia and 2 in Japan.
Okay, so that's not the right one. Africa?
South America, I think.
South America. Wow, okay, gotcha. All right, good. But growing, and customers are growing, and continents are growing. So yeah, welcome to the panel as well. So that's the brief, and maybe not too brief, but the introduction to our panelists today. And so what I'd like to do, I'll sit down here, is kind of get started into some of the questions. And you can see on the agenda that Ledvin has put a good job putting some of the questions started and questions together. We also talked last week as a group and talked about what are some of the things that are important as well. I'll note that obviously we're looking for alternatives for end-of-life blades to keep blades out of the landfill. But what I'd like to do is ask the question a little bit differently and ask the panelist here. Of course, there is a cost to recycling blades, to repurposing blades, to reusing blades. All of that has a cost, a higher cost compared with a non-sustainable option typically in doing so. And so my question is, how do we reduce those costs? How do we look at repurposing, recycling, reuse, or other types of end-of-life strategies? And knowing that there's elevated costs here, what can we do in the near term and the long term to help reduce those costs in your individual sort of fields of expertise to help us get to a point where it's more economically feasible to have an end-of-life solution like repurposing and recycling for blades? And so if anyone wants to jump in there, yeah, Andrew, go ahead.
It looks at me, so it must be me, yes. It's essential that we bring down our costs. So we're having conversations with developers, with OEMs, talking about a degrading cost at the gate. So lowering that cost. How do we do that? The same as any other company that's in something new. We have a high opening startup CapEx. Once we get past that CapEx investment, we can start to improve our efficiencies, and we can then start to bring down our costs and deliver for the industry at a competitive rate to what's common now.
Well, and I think looking at the repurposed solutions, one of the main costs, as Paul also mentioned, is finding the right information, validating the structural capacity of the end-of-life blade. So if all those data become more shared or open source, that will reduce a lot of the initial costs to see if repurpose is a valid alternative.
Makes total sense. Anybody else jumping in? Yeah, go ahead.
Yeah, I mean, I'm not a blade recycler, but I can give my 2 cents. I think you can look at this problem in 2 ways. You can either look at, so what are we competing against? Cost of landfill, right? And I think we've heard today that the cost of landfill varies quite significantly based on where you are in the world, even within Europe. And that's being driven by legislation on a country-by-country level that can increase the penalties for sending blades to landfill, that can force more cost competitiveness with blade recycling. But then also I get asked to opine on investments sometimes that companies are trying to make in blade recycling solutions. And what we see is obviously that scale is really important as well. As Andrew said, there's a high upfront CapEx, but once you start to reach those economies of scale, we believe that those costs can come down over time.
So it makes very much sense actually, and the other thing we can do is to maximize the value of the output, in a sense, and the marketability of the output, right? So in that sense, when we started, we started the business 5 years ago, and when we started, we thought that it would be easy to sell the thermolysis oil, so pyrolysis oil, to petchem companies, to refineries, basically, like oil. It's not the case. I can tell you it's very challenging because it contains too much oxygen, and so basically we're willing now to take this extra step and, as I said, actually perform distillation to extract the molecules and sell them as molecules. And there you can access markets that are not there actually for pyrolysis oil. Or the best case is to use a product that is recyclable by design, like Ilium. And the other thing as a startup, as a small company, is to partner with large corporations, because so we do have the culture of risk, so we're risk takers, but we're less organized, I would say, you see, and so we strongly benefit the
culture of larger corporations. They have processes, they have, and it gives a lot of credibility actually to partner with those large companies. Yeah.
Okay. And I sense that what you said is that when you dove further into this, you found out that there's extra steps that had to be taken in order to get those oils ready to be used for remaking resin systems or things like that. And so that adds cost. But if you can do it and identify markets that can use it, ultimately that can lower costs because you're developing that market and you have a value to that material at the end of life. And so it's really kind of both. You have to sometimes put a little bit more research into it, see about the raised cost, but also have a return on the investment there because you're looking at new markets and things like that. And hopefully you can find those markets. Is that true?
Yeah, absolutely. I mean, we're lazy creatures, right? Yeah. So we want to minimize the effort. But if you have to do it, then you have to take this extra step. And I agree that it takes effort and it requires funding as well. And that's where you can rely on either partnerships or public funding. That's partnership with universities.
Yeah, and I think that's really important. Talk about public-private partnerships, and that's something that my entire career has been so important. Because, and my next question was, where does that funding come from? Is it solely on business? Is it some governments that are putting money through universities or through laboratories and things like that, or other organizations? And I think that is really, really important. And do you or others have sort of examples of public-private partnerships that has been really valuable to what you've done and where you've gotten to so far?
Not so much an example, but just a comment on how important it is as well. As I mentioned earlier, we're trying to fundraise right now, and it's very, very difficult to come across private funding for this space right now. And before I was in Rebound, I used to sit with a venture arm of a large corporate looking at investing in recycling technologies as well. And Pascal raises a very, very interesting point around, like, I've seen business models from a €300 gate fee to a €3,000 gate fee because they assumed that the products they were going to produce were so valuable that it would make sense for them. But in fact, that's just not the reality in case. And the companies that I've seen succeed over the last 10 years have been those that have managed to leverage those public-private partnerships and kind of, national or EU level funding has made a huge difference to some of those that have succeeded.
Any other comments on that?
Only, I would say briefly, we personally have not benefited from public and private partnership in the sense that over the last year we've been fortunate to have trust instilled with us by the Crown Estate, which is a well-known organisation, UK's biggest landlord, and makes a mere 1.1 billion GBP profit every year. It's quite good, isn't it? Yeah. But they've been guiding us so that they can succeed with what they want to do. But as such, we have no outside investment as such, but it would be nice if they did it.
Right. Good, Paul.
Well, accelerator programs are one thing that certainly Bladebridge has benefited from, and some of them are faster in terms of decision time than, say, Horizon projects or these kind of long lead time, which also have very long time to wait for an answer, which in the life of a startup company is, could be just too long. But I would say, the partnerships with public bodies, it's not just about, it's not all about investment or money, but it's just getting over the line for demonstrator projects, having a champion who can make a decision on a demonstrator, whether it's a noise barrier or a bridge. This is key because this is something that the public body can perhaps can do, is empowered to do, and then that creates a market. And we're hoping as well that green public procurement will begin to filter through. This is something as well that public bodies can do, create those requirements for recycled products or repurposed products. Yeah.
Good. All right. Great. Thank you. My next question, and we've been asking this, I think, for a long time now, probably 10 years, is responsibility. And, early on, the owner-operators were sitting there with the responsibility on them, sort of before OEMs started to kind of even notice that recycling or repurposing was something that they had to even think about on their list. When I started talking to them in, say, 2015, none of them were thinking of it, or if they were, it was the very bottom of their list. But now it's near the top of their list, which is good. Responsibility might come from all the way back to the OEM, a blade manufacturer. In this case, we're talking blades, blade manufacturer. It could be others as well. Where do you see responsibility lying? It doesn't have to be with one individual, one entity. It could be across. And how do we distribute that responsibility, or how do we manage that responsibility in order to get the end of life solutions that we're looking for? Any thoughts about that? Go ahead, Jos.
Well, maybe to start, the first responsibility is the knowledge of what's in there, and that's the responsibility of the OEM. And with that information, all the others further up the value chain know what to do with it, because then you can find a good method of dealing with it, whether it's a wooden core or a PVC core, doesn't matter. So that's the first responsibility, and then long-term responsibility might be with the OEM if we can go to a level where it's recyclable within that product again. Then they stay sort of material owner, but I would prefer that the wind farm owner takes the responsibility. If they sell it off to a decommissioner, they take the responsibility. If they sell it to a repurposer, they take the responsibility to make sure it gets back to them towards a recycler in the end. So there will be a material owner always, and if it stays with the OEM, I think they won't, agree.
Yeah, can I come in on that? I want to echo what you're saying, and I don't want to defend the OEMs. I don't think there's any OEMs in the room, but I will also defend them, because I think at the moment there is no incentive for the OEM to provide that data, right? They're already running a razor margin fine business, right? We all know how much they've been struggling over the last years, and putting additional burden on them is just something that, even from like an administrative point of view, even if there wasn't an IP issue, they're like, well, we'd have to hire somebody to start putting together that data, and we just don't have that resource available, So I don't think it's going to change anytime soon, unless there is some kind of legislation that forces them to provide that information. Like, I don't see any of them doing it out of the good of their own heart. I just don't think it fits with the business model. So.
And it's really interesting. I'll go to you in a moment, Andrew. You talk about the incentive to do so, and talk about their margins. I worked for TPI for 15 years, and the margins there are horribly small. Aerospace sells composites for anywhere between 500 and 5,000, sorry about my units here, US dollars per pound, and we would sell blades for $5 per pound, and that's about the cost of a Big Mac per pound. And it's crazy. And so it's difficult to get the bandwidth to get that more information. However, I would say I've worked across the years on many IEC standards, and that's one area where OEMs, blade manufacturers, laboratories, certification agencies, and users more and more now, not so much before, come together and can start to kind of write these standards, and they take a long time, and they're sort of after the fact, but they can maybe provide some of that solution, hopefully long term. Andrew, do you want to jump in there?
Yeah, I'll just add into that possibly the most pragmatic way of dealing with this is that it comes from the government authorities, the utility authorities who issue the tenders, because when they put out in that tender the requirements for recycling, I think it'll sort itself out then.
It's a good point, yeah, and that sort of parallels with legislation. It might not be legislation, it might be the tenders and the authorities there, but is there a role? What role would play for legislation? Of course, it's per country at that point. Maybe the EU has legislation, I'm not as aware of, that governs all of the EU, but is legislation also playing a role here?
Well, I think they go together. I think, typically the governments are behind most tenders for major farms and parks, as some refer to it. And the legislation has to be in line with whatever's in those tenders, otherwise it will break apart otherwise, yeah.
Okay, good use.
Well, legislation is only going to fix the future problem. So 25, 30 years from now for the wind farms we're putting up in the next decade. But looking back at what we've done before, we can share it on a platform together with per variant of blade type that we cut open or that we recycle to figure out what's in there. But who's going to pay for that to get all that data available?
Good. All right. a question I have, and we can also take a question or two from the audience as well. I know we're probably way over time here. I'm not sure. What are we doing on time? Yeah, it's almost 6. Okay, we'll wrap up here pretty soon. My kind of overall question to end with the panel, before we ask one or two from the audience maybe, is what has to change in your mind? What has to change? It could be process, it could be standards, it could be legislation, in order to make repurpose, recycling, reuse, end-of-life strategies more viable down the road? Is it just about technology? Is it about, what in your mind, or maybe each one of you can think about, what was one of the key or couple key changes that has to happen in the next decade or so in order to enable this? I mean, if you want to maybe start, we'll come down the line.
Well, I think what changed for a lot of people is the perception that they think and know that it is necessary. That was not the case 20 years ago. Then it was still a lot of advocating for a certain way, and people were like, yeah, well, we'll see. Yep. So that has changed, and probably with legislation in the next decade, it will also be mandatory instead of optional.
Okay, good.
I think it was in Matthew's presentation, but he said number one focus is always cost, and that's an issue. That's a problem. If you want to achieve higher environmental value outcomes, you've got to rebalance. It can't be just about cost, and maybe the tendering criteria is something that needs to be looked at.
Yeah, legislation essentially, an accelerating tax on waste. So that's already happening, certainly in the UK and certainly other countries as well, where landfill tax goes up every year. And then scaling businesses. And what goes with scaling businesses, we also need competition. Because, when Boeing was going through a hard time, I would know quite a few people in both companies, Airbus and Boeing, and Airbus said, we don't need Boeing to go down, because Boeing keeps us right. And I'm sure Boeing says that Airbus keeps them right.
Yep. That's why Microsoft saved Apple a little bit back then to keep competition. Yeah. Go ahead.
Yeah, I mean, there's so many things we could say here, but I think this room obviously has people who already believe in this future of fully circular renewables. But I think there is a mindset shift in, well, not just like general public, but also within the wind industry, that like recycling and repurposing is possible today and can be cost competitive if we invest in these solutions. And I think there's still an education piece and an understanding of that, not just to see end of life as a cost center, but as an opportunity as well.
I would say that things need to change for sure, but not too quickly. Because we see the example in Austria, where it's completely banned to landfill composites, you see, and it's killing the industry. So I would say, yeah, maybe that's my Swiss side, that is speaking, but yeah, for sure, I concur, actually. It's everything that my co-panelists said, absolutely, but gently, so that the technologies can emerge, and the industry has a solution, actually, to rely on before, actually, the laws simply ban composites. It's
Yeah, so there can be unintended consequences, of course, when you move too quickly like that, and then maybe things moved out of the country or whatever it is, or different pathways you didn't envision happening. Yeah. Any questions from the audience? Anyone want to just ask a quick question or two to the panel here, if there is any? Maybe not. Maybe people want to go home. Okay, yeah, we have a question right here. She'll come up right behind you with the microphone. Yeah, thanks.
If you could make a wish, how does it look like in 5 years?
I've got 150 customers, and we're no.
That's modest.
No, I think like a dream scenario, right, is, as I mentioned, the OEMs are not going to start sharing data anytime soon. But if they did, that would make everybody's life immediately a lot better. That would be my biggest wish, if we had full transparency, at least on the older turbines that are no longer being sold and nobody's trying to copy, right? Yeah.
For me, I would just love to see our blueprint roll out across Europe and the USA and Australia and China, so that we can actually make a significant difference at a very low cost and bring about great change for the industry.
also open data, but I would extend it to maintenance data, repair during first life, and structural monitoring.
And I would maybe even go a level higher, where we say we stop externalizing environmental costs and dwindle it off to society, but incorporate it in all products, not just within wind, but also within nuclear, coal, etc., so that we have a real outlook on what's competitive energy and not.
Excellent. Great question. Thank you so much. Any final question before we finish up? Anyone want to get another question in at all? All right, then let's end it there. Thank you so much for the panelists. I really appreciate it.
Yes, I'll just say a moment here. Listen, thank you all. Today we've cut through the noise. We haven't just talked about blade recycling, we've also exposed the scale of what's coming, the gaps in our current system and lack of system, and the urgency of building solutions that actually work at industrial scale. And across every session, one message kept landing: this sector is outgrowing pilots and prototypes. We're moving forward. The peak waste decade is real, maybe surprise some of us, but not so many probably. The volumes are real, and the timelines are tightening. They really are tightening. And we heard today that it's no single technology, no company or region has the solution. They can't do it alone. We've heard something encouraging, and we're finally thinking about systems, materials, logistics, policy, and end of market. None of this can work in isolation. The honesty and operational insight shared today showed a maturity that wasn't here even last year. So we'll close today, and the takeaway is simple. We know the challenge, we know the constraints, and we're starting to align on what's scalable and what scalability means. Tomorrow we can shift the gears, identify the problem to shape the blueprint for the future. Standards, they're needed. Partnerships, technologies, and the practical models that will carry us through to the next decade. There's been a lot of energy today, some tough sessions for some people. It's been tremendous. The candor has been tremendous. Enjoy this evening. There's some drinks downstairs, I believe. Keep the conversation going, and let's all be here on time tomorrow morning and maintain that momentum. Thank you.
Okay, ladies and gentlemen, few words from my side. First of all, I would like to thank all our speakers for their interesting presentation. Also our audience for asking a lot of questions and keeping the discussion engaging. As mentioned, you will access all the presentations 1 week after the conference and also the full recording. Please let me remind you to fill in the evaluation form. So, few more organization things for tomorrow. Tomorrow we meet here again at 8:30 sharp, please. And for today, as Andrew has mentioned, we still have the drinks, which are happening downstairs. It's gonna be approximately 1 hour or 1 hour and a half of the evening reception. You have wine, beer, and soft drinks included. There is still one condition for that you will all gather out the stairs for a group photo. Thank you very much. Thank you, our chairman, Andrew, and see you everyone tomorrow. Thank you. Enjoy the evening.